This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, hello and welcome to the Linux Plus certification exam practical tutorial for the command line. And in this particular video, this is a part 2. It's a continuation of the lecture that I did for Linux Plus. So if you haven't seen the lecture, I do encourage you to actually watch the lecture. I try to talk as fast as I can, but you can also obviously speed up the whole process just to kind of go through it a little bit faster. There's also a lot of timestamps available in that video as well as this video. And the reason why I say that is because a lot of these commands that I'm going to go through right now, I'm going to demonstrate how to use the command. I'm going to demonstrate how to find the manuals for the command, and I'll give you a few very common use cases for each one of the commands, but I'm not going to explain why they're important. The explanation for why all of these things are important is in the lecture. And this video, just by itself, I'm recording this introduction after having recorded all of the different modules. So this video just by itself is going to end up being hours upon hours long. I don't want to discourage you in any way because, again, there are timestamps available and you can skip back and forth to try to find the most relevant portions for you. But this is not going to be a short video, even as it is. Even me having only shared a few sample commands that are the most common use cases, so on and so forth. So to really understand why these things are powerful and why they're relevant to the Linux environment and to your job as a Linux administrator or a security analyst, you need to watch that lecture. So that's kind of the first piece right here. The second piece is that, again, as I mentioned, I'm going to give you common use cases. I'm going to show what the command does. I will show you how these commands actually connect to each other and what you can do to, for example, workflows and to really combine the power of a lot of these commands to get the most out of the environment and the system that you're working with. And I'm going to show you how to find the manuals for every single one of them. And if you needed further information, I'll show you how to do that as well. But unfortunately, I won't be able to go through every single option that comes with every single command because some of these commands have dozens of extra options and each one of those requires its separate explanation, and a lot of them are out of the scope of Linux Plus, so you don't really need to know them for the purpose of the exam. But you do need to know that, for example, hostname helps you get the system and kernel information, and then uname does the same thing. So you do need to know what the general purpose of the commands are, and if needed, if somebody gives you the sample command that starts with sudo hostname, you need to know what that means and what they're trying to do so that you can narrow down the potential answer options, or if you're trying to accomplish something and get some kind of information and get a certain task done, you need to know which type of command you need to use. So that's the overall purpose of Linux Plus in general, as well as what this tutorial is going to cover. Now, finally, this specific document that you're looking at is going to include all of the portions that were included in the lecture, as well as all of these sample commands. So you can see on the left side right here, there's these 12 introductory sections of the commands, but then for each one of them, we're going to go into individual sections showing you process details, memory usage, for example, all of that, and then file directory, and then we're going to go through operators and all of the various elements of each one of these subsections. We're going to go deep into the details of all of these commands to make it as useful for you as possible, and all of these things are going to be timestamped. So everything that you see inside of this document is going to be inside of the timestamps, and if you wanted to get access to the document, then you could get it as being a part of the Hackaholics Anonymous community. The Hackaholics Anonymous community is a membership community that I am very, very proud of. We have a lot of great members, and it's continuing to grow. And there are 4 tiers to the membership of Hackaholics Anonymous. The first tier is the supporter tier, and they get access to their Discord with me as well as all of our advanced members. But the next tier, which is the agents level, those are the guys that get all of the downloads that come. That I mean, I spent weeks and to develop just this document, and then another couple of weeks to develop the slideshow that goes hand in hand with this document. So you would get these notes, you would get the slideshow, and just those two things are worth literally over $500. If you went to go to CompTIA and you wanted to get the manuals and everything that they have for Linux Plus, you would get those for just literally $25 because that's the price of the membership. So you would be saving hundreds of dollars just to get access to these manuals. But if you didn't want to do that, then you can literally just watch these manuals or these tutorial videos and then just create your own manuals, which is very, very feasible as well. It just takes a little bit of extra time and energy. So it just depends. If you want the convenience of it, you can just go ahead and get the manuals as well as the slideshow by being a Hackaholics Anonymous member. But then just being a part of the membership community, you'll end up getting Python automations that I generate for you. You get access to me. We do live streams every single month. And there's a lot of other exclusive stuff that's available for the membership of the Hackaholics Anonymous. So I really do encourage you to check it out. And if at the very least you just want to say thank you, then maybe you can come in as a cyber supporter, and it's literally $5. And I know people that spend $5 just on coffee every single day. So to be a part of our community, get access to our Discord, and to show your support, it would mean the world to me if you came in as a cyber supporter. So that is essentially the entire plug that I have for you for this thing. So let's jump into the overview of what we're going to cover inside of this specific video, which is just command line stuff. And I want to show you the different levels of the commands and the different categories of the commands. And again, all of these things are timestamped in the description below and in the top comment that has been pinned to the top of the comment section. So you can run through these at your leisure and then skip around if you need to. But here we go. This is what the outline looks like. All right, so we have section 12.1. So the first subsection of our overall section 12, which is the command. We have the system information and status. So this is all about getting more any information that you need about the system, as well as the status of your system. Then we have the file and directory management commands, and this is just an overview. So it goes much deeper into this. These are just the highlights of the commands that we're going to cover. There are many more commands that are covered in these sections. I just need you to know that if you want to manipulate files, if you want to work with the file system and the file directories, so on and so forth, this is where you would go. Then you have the text processing and editing, as well as the text processors that are used to generate documents and modify documents. We have file permissions and ownership, so how to find permissions of files or how to find the owners of files, as well as how to change permissions and change ownerships. We have the user and group management. This is a really big one for system administration, so how to create users, how to modify users, delete users, how to create groups, modify groups and delete groups, and how to find information about individual users. And then we have the disk and file system management. This is a really big one. And this is something that I had trouble with just for this particular recording, because I'm recording this on a live boot of a Kali Linux that's from a USB drive. And to be able to save these videos inside of my external drive, I had to go through an entire mission to be able to work with the partitions and the mount points, so on and so forth. So I speak from experience when I go through this piece for you, and I will demonstrate what I can, and then I'll give you the rest of the cheat sheets that I was able to generate as I went through it, and all of it is going to be inside of this section. So the stuff that I don't demonstrate, I will definitely give you detailed breakdowns, like step-by-step breakdowns of what you need to do the management of your disk and your file systems. And then we're going to go through the networking commands. And this is not a supplement of the Network Plus instructions. So this is just what you need to do for networking and configurations of the network and troubleshooting, so on and so forth, firewalls and everything when you're inside of a Linux computer or a Linux machine. And then we have process and job management. And then we have system monitoring and logging. Then we have package management and archiving and compression of files. And finally, we will get into shell scripting. So the basics and commands to actually create a shell script. And then I'll even go through creating some shell scripts for you so that you can use them just in your day-to-day life to make your life more convenient. And then if you actually get a job as a Linux admin, to make your job a little bit more convenient as well. And we'll go through all of that stuff inside of this video, this very video that you are watching right now. So without further ado, let us jump into the very first section, which is going to be the system information and status. Okay, we are now inside of our Kali Linux machine, and this is going to be our command line, which is basically going to be the place that we are going to live for the rest of this training series. The very first thing that I want to teach you is how to pull up the manual for any specific utility or for any command line tool that I give you. So I'm going to introduce you to the tools themselves, but the one thing that I'm not going to be able to do is go over every single option that is presented from these tools, because a lot of these tools have a variety of different options that you can pull up. So for example, we have the uname tool, right, which is the very first thing that we're going to talk about anyway, because it falls under system and kernel information and system information and status, so on and so forth. So the uname tool has a variety of different options that it runs. So for example, uname by itself, or you could do uname R, which gives you the version, the kernel release version that is available for our specific machine in this case, which is 6.8.11, and it's running on an AMD 64, so on and so forth. So you have all these options, right? So we're going to clear the screen. That's a very basic command, and that's how you clear the screen. So I'm just going to be doing that regularly. The one thing that you need to know is the manual command. So when you do man and then you do uname, it'll bring up the manual for the command uname. And then it gives you all of these options with their individual description. And at the very, very top, it gives you, you can do uname with whatever the option is, and you just press enter. So you can do uname R, and it'll give you the kernel release, or P, or I, or O, and so on and so forth. And then you can even do -- help to display this particular help menu for this particular manual. For the most part, from what I've gathered, is that when you do man and then the name of the command itself, that is universal. Sometimes the commands also have the -- help, like we do see in this case for uname, but in a lot of different cases, they don't have -- help. So what we need is the universal approach to be able to pull up the manual, which is going to be man and then the name of the command. And then from here, if I wanted to exit, I would just press Q and I would get out of that manual. So manual or man and then the name of the command will bring up the manual, and then when you press Q, you quit the manual and then you get back to your regular screen. So that's the very first thing that you need to learn how to do, which is pull up the manual. Now we can look at all of the commands that fall under getting information about your system and getting information about the kernel on your system. So the very first one, as we already discussed, is going to be uname. So if you just type uname by itself, it'll give you the system information like the kernel name, right? There's a different version of this, or there's a lot of different flags as you already saw. So if we do uname R, we will get the kernel release version. If we do uname A, it'll show you everything that's available for this particular system. So we have the kernel name, we have the version, the architecture, and the variety of installation dates for this, for example, and so on and so forth. So this is everything that you would get. If you did uname S, then you would get the kernel name by itself. So the system kernel name, which just ends up being the same exact thing right here, which is the uname command just by itself. If we did uname -n, you would get the node name, which is the host name of the system, which in our particular case is Kali. So if you can actually see that we are running Kali at Kali. So you have the user in this case, which is Kali, at the host name, which is Kali, and then the system name, right? So the kernel name in this particular case is Linux. So Linux is not the host name, nor is it the username. Our username is Kali, and then our host name is also Kali, as we got down here. So I'm going to clear the screen so that we can get back to the top of this thing. And then we can go to the rest of these. So we have uname-v, which will give us the kernel version, which is this full thing right here, SMP preempt dynamic Kali 6.8.11, so on and so forth. As you can see, it's kind of very similar to running just the uname-r, which will only give you the release version. When you do uname-v, it gives the kernel version in full. It doesn't give you just the release version. So a lot of times you would get for the most part, I feel like it's safer to just run uname-v to get the full version information. For example, the preempt dynamic portion, as well as the Kali version, and so on and so forth. You do notice that this has AMD 64 at the end of it, which has to do with the architecture and not just the version of Kali that's being run on my particular machine in this instance. So we had uname-v. Now we're going to go to uname-m, which is going to display the machine hardware name, which is by the x86 by 64, which is the 64-bit. Typically, when you see that, there's either 32 or 64-bit that's available for a variety of the popular computers that are running nowadays. So in this case, we get uname-m, which is going to give us the machine hardware information, the machine hardware name. And then we have uname-p, which is going to give us the processor type. And in this particular case, we don't have a processor because I am running Kali Linux from a boot on a USB. So it doesn't get to pull that information from my actual hard drive, which is technically a Windows machine. So it'll give me everything that I have that is installed on my USB live boot of Kali Linux, but it's not going to give me my actual processor, which is the CPU data. And if you were running this on a Kali Linux machine that was actually installed on the hardware, which is what we saw when we went through the various installation methods. So in chapter 3 of the lecture format. So it's a separate video, but the link to that video is in the description. If you go look at chapter 3 of that lecture video, we went through the installation of Kali Linux, and there was the Kali Linux boot, live boot installation, which is what I'm running right now, which is very convenient. It's like a mobile version of Kali Linux that you have on your thumb drive, and then you can essentially just put it in your pocket and go to any location on any computer that allows you to have this dual boot type of an option, and then just boot it live from the USB. And then there's the full installation that I did. And then if you do the full installation, then when you run uname-p, you will actually get the processor details of the hardware because it's actually being mounted, or not mounted, it's being installed on the hardware of the computer. So that's what we have for uname-p. Now we're going to go to uname-I, and I presume, yeah, this is also not going to show me the information about the hardware because it's not installed on the hardware, but this would give you the hardware platform and the various data points of the overall hardware architecture that is being installed, not just the CPU or the processor. And finally, we have uname, and then we have the option of O, which will give us the operating system, which in this case is GNU Linux. So you had a large variety of commands that I went through, almost every command that was available on our manual. So we did go through A, S, N, R, V, M. I feel like I actually literally did go through every single one of these. I'm not going to be doing this for every single one of these commands. This was one of the ones that I kind of wanted to get you an introduction to how to run the command along with the option that's attached to it. Now, a lot of different options that come with these various commands also require arguments or parameters to be provided. So you would have to include some kind of a bash argument, and then we'll see what that looks like in a little bit as well. But that's it. That's basically it for running uname. Uname is printing all of the system information that you would need to be able to either kind of do reconnaissance on a system if you're doing pen testing and if you've logged into somebody's systems and you want to get a lot of good information about it, or if you just want to understand your own system's architecture, you would go through running the uname command as one of the commands. There's going to be multiple other commands that we're going to go through that are going to give you more detailed information or a variety of different types of information about your system and your kernel. But this one was uname. So moving on to our next one, which is going to be hostname. The hostname command, as the name implies, will give you the name of your host. So when we're looking at Kali at Kali, this is the portion that we're referring to, which is the host, meaning the actual machine, the individual machine that I'm on right now. And my machine in this particular case, because it's just booting live from a USB drive, it's called Kali. Hostname also has its own manual as well. So if I do manual hostname, we'll see a bunch of different things. So we actually have the hostname command, the domain name, YP domain name, NIS domain name, DNS domain name, so on and so forth. These all fall under the category of hostname that will get you a lot of different information. And then you can essentially achieve these similar results by running hostname with its variety of different options that it has down here. So pretty much every command for like I would say 90% of all the commands that we're going to run through, with the exception of a handful that are just standalone commands, all of them have some kind of an option that you can attach to the command itself to get a different type of data or different type of intelligence from the system. So for our particular case, if we just type in hostname, we're going to get just the name of the host that we're on right now. So if I do hostname CTL, then what's going to do is going to hopefully give me detailed information about everything that has to do with this particular machine. So I have the icon name, which is the computer desktop, chassis, the desktop. This is my machine ID. This is my boot ID, my product UUID, universal unique identifier. I have the operating system. I have the kernel. I have the architecture, the hardware vendor, because I'm running on an HP computer that has Windows on it, hardware model, HP ProDesk, and then hardware serial number, firmware, so on and so forth. So you can notice that actually the hostname CTL gave us much more information about our hardware than uname did. So this is, I would say, a more functional command. Just running hostname CTL by itself, it's a much more functional command that will give you a lot of data. Like most of the data points that we discovered with uname, we were also just able to discover by running hostname CTL. So it's a very, very powerful tool. Now, what I can do in this particular case is I can actually change my hostname by using hostname CTL, right? So if I went, for example, if I clear this whole thing and I do hostname, actually it needs to be a sudo command, and we've already talked about sudo inside of the lecture, so you should already know what sudo is. But if you don't already know what it is, sudo allows you to run any command as the system administrator, which gives you the highest level of privilege. So you would do sudo hostname CTL, and then you do set hostname because I want to set a new hostname. And in this case, let's say I want to do set hostname to Linux, and I press enter. And now I should be able to see, if I run hostname CTL, I should be able to see that my hostname has now been changed to Linux versus the previous option that we had where the hostname was set to Kali, right? And still in this case, it's showing Kali. So if I start a new one, it says that my hostname has now been updated to Linux, as we can see over here. So I'll just close this previous one in the background here, and then we'll run with our new window that has our new hostname in it. So now we are Kali, the user Kali, at the Linux hostname. So that is the way that we can actually run the hostname change command. So you would do it with hostname CTL. It is a sudo command, so it requires administrative privileges, and you would basically be able to change your hostname by using the set hostname option with the hostname command. So there's that. And then we can essentially do sudo hostname and then give ourselves a new hostname again without using system or hostname CTL. So I could just do sudo hostname and then do hostname and then give it the new hostname. So I guess I can do Kali Linux in this case. I'll do Kali Linux, unable to resolve the host name or service not unknown. So in this particular distribution that I have, this particular command won't run. So sudo hostname, new hostname in this case will not work for me because I need to use hostname CTL for my distribution of Linux. The sudo hostname, I believe, runs on the older distributions of Linux. Hostname CTL runs on the newer distributions that are required, or they require systemd as the init system as the initializer, and the older versions require sysvinit, and so we're not running on a computer that has sysvinit, we're running on a computer that has systemd. Therefore, hostname by itself won't work. We need to use hostname.ctl and then set the hostname option. And of course, you have to run that with sudo to be able to run that individual command and actually change your hostname. So that's what we got so far with that. So let's go into hostname I, and this is giving us our IP addresses that have been assigned to our particular host in this particular case. So in my case, my IP address on this machine, and here's the interesting thing, every time I boot Linux with this particular USB boot, right? When I do a live boot with Linux, every time I run it, the IP address is going to change. So in this particular case, it's ending in 0.239, and then this would be the IPv6 versions of my IP addresses that are installed on this particular machine. And IPv4 would be this is the most common version that everybody has noticed, but because of the fact that it's limited, it can't generate more than, I think, 4 point something billion different addresses. Because it can't do that, and there's now in the world way more than 4 point something billion devices that are connected to the internet, they went to IPv6, but that's a whole lot of the conversation. So hostname I would give you the IP address information of your machine. If you do hostname -f, it will give you the name or service. Oh, in this case, again, it's not known for me because this would be the fully qualified domain name of my system. And I don't have a fully qualified domain name on this particular system because, it's running on systemd, which I believe the fully qualified, actually not even that. I believe it's because of the fact that we're on a live boot running from a USB device. But if you did hostname F, so if I actually go to man hostname real quick, and then if we went to all of our options at the bottom right here, and if we found F, it should give you the fully qualified domain name, which is the short host name and then the DNS domain name. And this is typically available on every single device. So it would be something like, Linux, which is my current host name, but then Linux would also be followed by something else that would be available for my the rest of my domain, right? So when you're inside of a domain, meaning, it would be so much easier to explain it to you if I was actually on my Windows computer, because the Windows computer is really good with this, and Active Directory is very big on this. So you have the domain inside of Active Directory, and then you have individual trees inside of a domain, and then inside of those, or actually you have a forest inside of the domain, and then you have the trees inside of the forest, and then you have the individual organizational units, and then you have users that reside within those organizational units, and you have objects or assets that reside within those organizational units. So when you get the fully qualified domain name, you're getting the host and then the extension of that host, which would be which domain does that host reside in. So this is what hostname -f would do for you if you were actually inside of a domain. So if I had a full installation and it wasn't a live boot installation, you would be able to get that information. We have hostname -s, which gives us, again, just the hostname, the short hostname for us in this particular case, which has been changed to Linux. Previously, it would have been Kali because I was running, I had Kali at Kali. So now it's been changed to Linux, so it will display that for us. We have hostname -d, which in this particular case, again, is not unknown, which would give us the domain name of our system. So because we're running on a live boot, we don't have that, which is why we also weren't able to get the fully qualified domain name. So the -f and the -d give us the same little error because we're running on a live boot. If we went to hostname -A, in this particular case, it doesn't give me anything, but it should give all of the fully qualified domain names of this particular machine. But that, again, is relevant to the domain instruction, not the domain instructions, excuse me, the domain architecture, or the domain infrastructure. That's the word I was looking for. It would give you the detail of the domain infrastructure that you are in. And then we have hostname lowercase a, which would give us the alias if there was an alias in this particular case. But I don't have an alias on this machine. If you wanted to get the alias, you would be able to get it that way. The alias is kind of irrelevant. It would kind of be like a comment name almost. It doesn't really have to do much with the overall data of the hostname, because you typically can't refer to anything by its alias. You would need to refer to it by some kind of a dedicated name. So it's dedicated host name, for example, or maybe it's dedicated fully qualified domain name, for example, or it's dedicated IP address. So the alias is like a nickname that helps people be like, oh, okay, this particular host belongs to this particular employee in this office, for example. And so let's say you have 5 employees that are using the same host, which would be the same computer, the same physical computer, but they have their own individual login. So the host name may be the same, but the username is going to be different and the alias is going to be different. So that is what is relevant to our specific host name dash A, which would give us the alias. So there is everything that we got, not everything, but everything that I think was worthy enough to cover for the hostname command. So now we're going to move on to the lsb release. The lsb release command would give us distribution specific information. So things that have to do with our specific distribution. Now, in this case, there would be nothing that shows up for just lsb release by itself. But if we do run lsb release with the option A, we will get the distributor ID, which would be Kali, and then we have the Linux rolling, which would be our description, and then the release version 2024.3, and then Kali rolling, which is the code name in this particular case. I can also do manual lsb release to try to get more information about this particular command, and then we will see all the various options that would be attached to it. So that is another way that you can learn more about the lsb release options. There are a few things that I think is probably important if I can actually pull it up, because I am limited since I'm running on a live boot. So the -I will give us the distributor's ID, which is, as you see, is Kali. We also have the lsb release with the -R, which will give us the release date. And then we have the lsb release -C, which would give us the code name of the distribution. All of these things, if you do lsb release A, it will give us everything, right? So we already saw all of that stuff. But if you wanted to get, and this is very useful for coding scripting, if you wanted one specific piece of information, so for example, the distributor's ID, for example, if you wanted this specific piece of information, it's much easier to use this command to just pull this data up instead of using the all command and then having to parse through these data points to try to feed the rest of your script. So when typically, for the most part, I'm not going to say for every command, but for most commands, if you just run it with a -A command, then what you will get is everything that can be released with that particular command. So for example, what we did with uname, and then we did -A, and it gave us everything that can be potentially pulled up with uname. That is usually the option that works with most commands as well, where if you just do -A, it'll give you most of the information that is available for that specific command. Our next piece is not really a command, but there's a location on every Linux machine that has some details about the Linux kernel version and the system information, and that is the proc version location. So you have the proc directory, and inside of that there's the version file, and then when you use the cat command, which is concatenate, which basically displays the contents of any file onto your screen, onto your terminal, this is what we get in this particular case. So again, it gives us a lot of the same information that we received from the previous commands, the uname and the hostname, so on and so forth. So we get a lot of good information with just looking at the proc version file. And for the most part, I feel like everything that we did get from the uname command is actually here inside of this file. And then even some of the data that we got from our hostname command and the lsb release are also located in this particular file. So pretty useful file, which is the proc version. And that's basically it. That's all I got for this particular file in this particular location. It just gives you a little bit more details, information about your system and your kernel. The next couple of commands are actually pretty useful. They're very quick. So the arch command gives you architecture, that's basically it. So if you did man arch, it gives you some other information about it, but it's pretty much a standalone command. It doesn't really have extra options. You can go to uname1 and uname2, which we already reviewed, that would give you more details about the architecture. So if you remember when we ran some of the commands in uname, we were actually able to get this exact data point, which is our architecture. But arc is just another one of those things that just stores this one piece of data that has to do with the architecture of your specific distribution of Linux, of your version of Linux. And then you have lsmod. Now the output for this is pretty massive. And this is all of the list of the modules that are on our Linux machine and their status for the most part. So you have the module name, the size of the module name, and who it's used by, right? So this is a very large list of stuff, and you don't need to know all of the nuances of this, all of the details of these various, IP tables, for example, what that actually is and how that connects to everything and what VFAT is. You don't necessarily need to know all of this. It's beyond the scope of Linux Plus, but you do need to know what the command lsmod does and what it actually lists for you. And the way that I like breaking it apart is that typically anytime that I see ls inside of a command, I know that it's going to list something. And then we'll talk about all of this when we go into the dealing with files and hierarchies and folders and directories and stuff like that. But ls lists something, and then mod is short for modules. So it will list all of the modules and the statuses of those modules that are currently residing in your Linux kernel. So if I go to the next command that I have in line here that goes to deal with modinfo, we can actually start getting details about our modules. Modinfo just by itself isn't going to work because you actually do need to give it a module or a file name. So what we do need to do is go back to lsmod and look at one of these modules, for example, video, right? So if we have video as our module name, so if I do mod info and I do video, then I'll get information about the video module. And most of this stuff is, for me, even this is the signature, this is the SHA-256 hash encryption for it. And then you have just a few other pieces of information that are kind of more useful, like these information right here. So when you just do the command by itself, so if you do mod info plus the name of the module, it'll give you everything that has to do with that. But if you wanted to know who the author was, what the alias or the dependents or any of these things are, you can use the variety of options that come with mod info. So again, if I do man mod info, I get to see the variety of options that I can pull with mod info, and then from that I would be able to get different data points. So if I do mod info and then I do -a video, it will give me the author of the video module. If I do mod info -d video, it will give me the description, so the value that's inside of the description key, I guess, or the description variable of the video module. So the ACPI video driver is basically the value that's inside of the description for this. If I did mod video -l and then I did video, it will give me the license of this particular thing. If I did mod info -p of video, it will give me the parameters that are available for this. So it allows duplicates, which is a Boolean value. Brightness switch enabled is another Boolean value. Boolean basically meaning true or false. Then report key events, none, so on and so forth. So these are all of the parameters that can be associated with this, and then you can set these parameters. So you can allow duplicates to false, which means it does not allow duplicates, or if you turn it to true, it means it does allow duplicates. Device ID scheme, so on and so forth. So these are all of the parameters that come with this particular module, which would be our video module. And then finally, we get the specific field if we wanted to display. So you can do mod info -f and then give it the specific field that you want. So let me try to see if I can pull up, for example, license and then do video. And there you go. So it'll give me the license of video, right? So if you do -f and if you know what the name of the field is that you're looking for, which is available right here. So you have the parameters or parm, I guess. I don't know. What would parm be short for? But you have those, and then we have the signer, we have the verb magic, We have the iEntry, we have the depends, alias, author, so on and so forth. So if you know the name of the actual field itself, you can use the -f flag or the -f option and give it the author, for example, in this case, and I would give it the module name, and then it would give me the name of the author, right? So that is the various options that come along with modinfo. All right, now we're going to move on to system uptime and active processes. And the first command in this position is going to be the uptime command, which, as the name implies, it basically just shows you how long a system has been up. So in this particular case, it's been up for the current time, which would be where I am right now, the duration of it, which is an hour and 21 minutes, three various users, which kind of doesn't make sense, or the number of logged in users, which in this particular case, unless I have been hacked and there's somebody that's logged in on this particular machine, there should not be three logged in users. There should just be one particular user. And then there's the system load averages in this particular case. So the amount of time that it takes for the system to load. So the first portion that we see is the actual current time that we're in, the uptime, which would be the 1 hour and 21 minutes in this particular case. And then if there was a certain number of days, it would actually say the number of days. So it would say, let's say 5 days prior to this portion. It would actually say 5 days or a day, so on and so forth. But in this case, it's just been hour, 21 minutes. And then I have the number of users, which kind of doesn't make sense, right? So, and then we have the load averages. Maybe it's actually counting my Windows logins as well, but that doesn't make sense. So maybe I've been hacked. I don't know. Then we have the login averages. So the load average, that the amount of time that it took for the computer to log in and to load based on when I pressed the password and pressed enter, and then the system had to load my screens for me and everything like that when it kind of loaded from the hibernation mode, or when the system was sleeping and I had to just press the password again and log in. This would be the amount of time that it took for the system to load for me. So this is what we have with the uptime command. A very simple command, but it is a useful command to help us understand just how long this particular system has been up and running. And then you use this data in a lot of cases for incident response investigations, if a system had crashed, or if a system is slowing down for a variety of reasons. If you look at the uptime and it says that it's been up for 45 days, you're like, okay, you need to reboot the system. And it's sometimes as simple as that. Or you can check to see how many users are logged in, to see if there are any other extra users that are logged in that shouldn't be logged in, so on and so forth. So this is what we get from our uptime command. Another really useful command is the top command, and what it does is it basically displays the live running processes and services that are going on this particular computer, and it updates it for you by default every 1 second. What you see at the top right here is a bunch of different data points that you can kind of go into. So we have the current time, the uptime, which will be represented by this. You have the number of users that are represented by the users. You have the load time as well, the load average. Then you have the number of tasks that are running, or the total number of tasks that would be running. The current one that is running in this particular case, it went from 1 to 2. You have 241 tasks that are sleeping. There are 0 that have been stopped and 0 that are in zombie mode. And then we have the CPO usage, and the data information about that. So the user space is what the user space usage of CPU data is doing, which is my current user space that has, my web browser that's running in the background. I also have this terminal that's running. I have Zoom, that is my recording software for this particular session. So that's how much CPU percentage resources that I'm currently using. And then you have the system space that's currently being used. We have the nice space, which I actually don't know what this is. I just know that it stands for nice, and I need to do some research to find out what that is. And then I have the idle space, the idle system resources that are being used. And then we have the input output wait. That is what this is for, meaning if there's anything actually waiting to be processed in this particular case. We have the hardware interrupt that is at 0. We have the software interrupts that is at zero point 0.1. And then you have the steal time. If this was on a virtualized environment and there were multiple virtual machines running, this would have something to do with the amount of processing power, the amount of resources that one machine may be taking from the other machine. And if, so for example, machine A and machine B. So if machine B was not able to process what it needed to because machine A was stealing resources, the hardware resources, then the steal time for machine B would go up, meaning that there's been a certain amount of time that resources have been stolen from that particular computer. And then we have the MIB memory and the MIB swap. So this is just the data about our memory usage. So this would be the CPU processing power. This is the RAM processing power. In this particular case, I have approximately 32 gigabytes of RAM. I have 24 gigabytes that are currently free, 6 gigabytes that are being used by my screen recorder, my web browser, my terminal, so on and so forth, and then the about 5 gigabytes that are running inside of, or megabytes, sorry. These are the stuff that's being processed in the background. So actually, no, I'm sorry, it is gigabytes. So because it's 5,000 megabytes, 5,000 megabytes equals to 5 gigabytes. So I was right. Originally, I was right. So that's that data. And then there's the swap space. And there isn't much that is being used in my swap space. And I have available 25 gigabytes of swap space because and the reason why nothing's being used is because I haven't overclocked the system. I have a substantial amount of RAM that's on the system and still a substantial amount that's free on the system. So I don't need to use the swap space. And if you don't know what swap space is, you need to go watch the lecture so you have a good idea of what swap space is. But this is the basic default output of the top command. So if I wanted to quit this, I would just press Q and I would get out of it, and then I can clear my screen. And then if I wanted to increment everything, for example, based on the amount of time, right? So let's say that I want to do a delay of 5 seconds instead of a delay of 1 second. You'll see that it won't update as frequently, and then it'll wait about 5 seconds, and then it'll update, and then it'll wait another 5 seconds, and then it'll update. So this is how you can make it so that it's not as busy if you're trying to find specific users, for example, that are running, and the various commands that may be running or the services that are running. And then we can see right here from the users themselves, we have the Kali user and the root user that are part of my 3 users. And it doesn't show me who my 3rd user is. Now, if I wanted to monitor one specific PID, one specific process in this case, I would be able to do it with the -P, and then I would just give it the PID in this case. So let's say Zoom, which is the process that's currently running as my recording. I would do the top, and then I would do -P, and then I would give it the PID for Zoom, which is 13670 in this case. And then it would just monitor Zoom and how much resources Zoom is taking this particular case, and then it'll update every few seconds as well. And then we can see that it's updating every 1 second in this particular case. And it shows us, it's using 3.1, I would say gigabytes of RAM. I think that's what's happening. And then we have 113% of my CPU that's being used, which seems like a lot in this particular case. But it is what it is, right? So that's how you monitor one specific PID, one specific process at a time. And then if you wanted to display a specific number of iterations of this. So if I wanted to do, let's say, 5 iterations of what's going on with my system, I would use the -N command. So let me clear the screen so you can see it. -N. And then I would do 5, and then it would give me 5 iterations. So it'll count to 5, and then it'll just quit after it's loaded everything that it has for this specific command. So I think that was the 3rd one, maybe the 4th one. There you go. So that was the 5th one. After the 5th iteration, it cleared itself out, it shut itself down, and it quit the top command. Now, there are a lot of options that come with top, and I don't want to kill anything because I'm only using a handful of processes right now, and if I kill them, I have to restart this whole thing. So what I do want to show you is what the individual command line options are. So this in particular case is actually not the command line options. What we're trying to do is we're trying to find the interactive options that come with this. So there's a lot of stuff, as you can see, because top is a very, very useful tool that's available for us. So what we're trying to do is we're trying to find the interactive options that are available with top. And I may just need to go to my document to show you. There we go, finally, interactive commands. Okay, so here we go. So this is the list of interactive commands that while top is running, you can run any of these specific options to do a variety of different tasks. So the things that I want to point out to you most would be something like the H command. So it'll display the help, the list of the commands that are available for it. The K command will kill a process. So you press K while it's running, and then it'll say, it'll prompt you for the PID. So you press K, and then it'll say, what PID do you want to kill? And then it'll kill that process and it'll stop it from running. The R command will renice a process or renice. I think it's renice a process. The Q would quit the overall top function and it'll come out of interactive command. D would delay, right? It would change the delay. And you can do this interactively as well. So we did the dash D and then changed it to 5 as we ran it to delay 5 seconds. But you can actually do that interactively with top. If you wanted to sort by CPU usage, you would go for capital P. And capital P in this case, I don't think it's actually over here. So maybe this portion right here, this up piece right here is the shift button, and you would hold down shift and you would press P to give you the capital P. And what that does is that it will sort everything by CPU usage. That I can actually show you, so I'll demonstrate that for you. And then we can also sort by memory, the RAM, so capital M would sort by memory, and then we would be able to sort by the process ID by using the N, and then you would be able, which is right here, and then you would be able to sort by the running time, which would be done with the capital T, and then you can toggle between the command name and the full command line by doing C, and then toggle between showing the aggregated CPU usage by doing the one command, which is right here. So these are our full list. So what I'm going to do is I'm actually going to do just the organizational versions of it. So if I run top right here, and now we're in interactive mode right here. So if I wanted to do by PID, for example, I would do capital P. So I just held down P, or I held down the shift and then did P, and then it organizes it. But what happens is that every second it's going to reset. So then it's going to just change that for me. So let's see if I do, we'll do top. And then in this particular case, what we're going to do is we're going to change it so that it will load every, let's say 10 seconds. So I'll do a dash D of 10 and it'll now load every 10 seconds. So if I do P now it gives me a little bit of time to organize what's going on and then analyze everything by its PID, right? And in about 10 seconds, it'll reset this entire list because it's going to update a live format of what's going on again on the computer. So maybe I can now do by memory usage, for example, right? So if I do capital M, it'll show me everything by memory usage, and then the most amount of memory being used by Zoom, and then we have Firefox, and so on and so forth, right? So that can be done by memory. If I do CPU, actually that's what it was. So it wasn't by the PID. That's my bad. So P actually organizes it by the CPU usage. That's completely my bad. So capital P organizes by CPU usage, and then we can actually see again that it's actually still organized by CPU as it's being updated. That is completely my bad. I thought that it was organizing by PID, and I was like, oh, it's resetting every single time. But it's actually not resetting every single time. It is still organized by CPU because I requested that it would be organized by CPU. Let's see. So what else can we do? We can sort by the process ID. So that would be N. So capital N. There we go. So capital N will now organize by process ID. And then when this updates, the process IDs will still be organized in the descending order of things. And then we have the capital T, which we'll do by running time. And that would be right over here. and then it will show us how long something has been running. So in this case, I believe it's been running by 54 minutes approximately is how long Zoom has been open during my recording session. So yeah, that's kind of it, right? So this is the overall process of interacting with the top command. Now I just don't want to kill anything, but if I actually did press K, it would ask me to kill a process, and then it would ask for the PID to kill it. If we did H, it would give us the help command right here, so we can do this, and we can escape the help menu by pressing H. And then what else do we have that I did not? I can press D, and then it says change delay from 10 to 5, so I can just change that. Now it should reload every 5 seconds. And any other commands that I feel like should be useful. Oh, C. So if I do C, we can see that the command line right here has now been changed to the full command line path instead of just the name of the process by itself. So we have Zoom, Zorg, Pipewire, and this is actually useful again for when you're doing security and system administration, because it may be named Zoom, but it may be stored in a completely different situation, and the path for it may give you more detailed information about why it's using up so much data, or maybe you don't recognize it, and so on and so forth. So you can do a lot of reverse engineering and security analysis, incident response, by looking at the full path of the command instead of just looking at the individual name by itself, which would be the process name. And finally, we have the number 1 that will toggle between the aggregated CPU usage and the individual CPU cores. So if I did that, it will actually show me the individual CPU cores on my top portion right here. And then if I do that again, it'll just break it down back down to the percentage usage of the user space and the system, and so on and so forth. So that is what we have for our top command. Now, real quick, there's actually another version of this particular tool. So another version of top, which is htop. And I think the H actually stands for like human top, or like human readable, or maybe helpful or something. And it basically does exactly the same thing that top does, except it's just more user friendly. And the interface is it's color coded, and it helps you organize. It essentially organizes things in the same way. If you go to the lecture portion of this training series, you'll get all of the different variations and helpful portions of htop, so you understand what it actually does and the differences are. But I don't have it installed on this machine, so if I press enter on this, it says it's not installed. Do you want to install it? And then if I press Y and press enter, it would actually install it. So I don't want to install this because it pretty much does exactly the same thing that top would do. And in a lot of cases, if you're doing system administration and you're doing troubleshooting or something like that on a machine, you may not get the privilege to be able to install htop. So you would have to learn how to manually work with top, which is this tool that we went through right here. So htop is just a human-friendly version of top, and it has color coding. It has a variety of different options that you can use to organize the data, which is very similar to everything that we just did with top, except it works with the F keys, so the F1, F9, so on and so forth. It works with those keys. And sometimes the keyboard that you're on does not have those F keys. And I've broken all of this down with the lecture portion. So if you wanted to use htop, but you didn't have F keys, I've given all of the descriptions of how to interact with various keyboard shortcuts with htop, so that you don't have to worry about F keys, and you could still do everything that we just did with top. But again, in my opinion, you don't necessarily need to get htop, because top does everything that you would need. And then when you're dealing with the certification exam and so on and so forth, if they give you a multiple choice question of what is the tool that has been used to manage processes or look at CPU usage, or they give you a scenario that they say, hey, so-and-so is dealing with this situation, they ran top, and they're going to, what type of information can they pull with top, for example, and then you may need to know what type of information that's available by running the top command, and then all the stuff that's displayed on the screen that you see right here. So there's a lot of different, obviously different data points that you can pull from top, and then they may also just do something like this, where it's like, what does top dash n10 mean? And then you would need to explain, or you would need to answer based on the multiple choice of what does this specific command do, which by now you should know that -n actually runs top for a number of times, and then once that's done, it'll stop running and it'll just quit itself out. And this is the -n, which is the lowercase command that is provided to it, the lowercase flag option that we provided to it, and it gives us the number of iterations that top will run for, and then after that, it'll quit itself out. So that's what we have for htop. The next command that you need to know is the ps command. And the ps command basically displays the information about running processes. And just by itself, it'll show you the processes that are running in this particular shell that I'm in. So if I had there's this one tool, I think it's called Terminator or something like this. Maybe I'm misquoting it. But there's essentially a tool that will split your shell into two panes, and then you can run a multiple series of commands in each individual pane. It'll treat each pane essentially as its own shell. So I think if we ran PS with two panes, it will show us what's going on both panes, or maybe it will just show us in the pane in which we actually have the command itself. So what is important in this case is that a lot of times you'll create background processes. You'll create something that's running in the background, and then you don't know what's happening and what's running inside the background. So you would need to run PS to see if there's any background processes that are currently running. And that is a very helpful tool, especially when somebody has done something and they've hacked into your machine, for example, and they're running something in the background, and you don't know that it's actually running, and you're just going about your business and doing what you're doing, and maybe you do something that's a sudo command, and then you run a variety of different commands, and then it prompts you to enter your administrator password, and the person that has hacked into your shell and is running a keylogger in the background can actually see the password that you've entered for your username as the administrator. So this is very important to understand, is that it'll show you all the processes that are running in the shell, and it will show you the stuff that's also running in the background. So in my particular case, I only have the ps command that I ran, and then I have shell itself that's running. So it is what it is. There's nothing else that's over here, but you will see a lot of data by just running ps by itself. There's another option for ps, which is the ps aux command, and that will give you a much larger output, which is all of the running processes currently that are going on the computer. So this is actually kind of similar to the output that you would get with top, but in this particular case, all of these things, whether or not they're currently using any of the resources on the computer or the amount of time that they've been up, and all of these things, these are everything that potentially could be running, and a lot of these things are just background processes that are required for the computer to run. So when we run top, they don't show up for that because these are background processes, right? So this is the other portion of it. If you just do ps aux, it'll show you the full list of everything that's currently running, including all of the background data. If you do psef, it will show you everything in full format listing. So if we do ps aux one more time, just so we can see the difference here, you can see that there's a few extra columns that are available for ps aux. And then let me see if I can go all the way to the top and show that last preview. Okay, so there we go. So now we have this difference in the formatting of the data that's been provided to us. So as we can see, there's the user itself that's available on psef, and then there's the ppid or the PID itself. There is let's see what's at the top right here. Let me see, let's go zoom up real quick all the way. So we have the PID, we have the parent PID, we have the system time available, the time TTY. I forgot what that is. But you can Google that really easily and find that information. But it gives you a full list of processes that are available, and it's in a fully formatted way where it actually gives you the command line entries to actually run all of these processes as well, versus something that was displayed to us on this, where you have the start time, the time that's running, so on and so forth, and this is for ps aux. So ps aux actually gives you more data about the processing amounts that's being used by this individual command. It doesn't give you the parent PID, it can be useful when you're doing incident response and investigations. So you will get two different sets of data by running ps aux or PSEF, so ps-EF. Then we have ps-E just by itself, which will give you the full format listing of the processes. It doesn't give you the user that's associated with it. It's a little bit more condensed of the version of the output. E by itself and then you have EF, which would be full, and it gives you the user, the PPID, so on and so forth. And then we have the PSF by itself, which will just give you the full format of everything that's running, and this will be in the foreground. It won't be the backgrounded data, so it won't be everything, which is what E does. It'll be F, which is the full front, the full formatted, the front. Not the forefront, excuse me, the forefront. Instead of the background, it's the foreground. That's the word, foreground. Instead of the background processes, as well as just giving you all of the foreground processes. So we have the bash, which is inside of user bin zh, and then we also have the -f, which is the command that we just ran right now, right? So let's see what else we got here. We have, whoops, clear is not working. We have ps-u, and then we would give it the username. So let's say if we gave it the Kali username, it will give us everything that's being used by our Kali user, which is the user that we're logged in right now. And then you can give it a variety of other users as well, so that you can get the data for each one of those specific users. And then you can get data by the PPID, by the PID by itself. So any of these things. So if I wanted to see what the rest of the information about this was, or if I ran top and I had the PID for something and I wanted to see what was going on with that specific process, I would just bring that PID and I would run it with the PS command, and then that would be PS, and then you give it the -p and then give it the PID, and it will give you the information about that specific process by its PID. You can also do it by name, right? So if I do PS-C and then give it Zoom, which is the name of the recording software that's running right now. So if I give it the name, it'll give me the information about that. So 669, 670, because I stopped it and I reran it, and then in my current session as 670, I have an hour with Zoom that's been recorded because it's been up, and then I pause the recording and I go and do something and I come back and I record some more. So the length of the recording so far should not be an hour and 10 minutes, but Zoom has been up for at least an hour and 10 minutes. And then what else can we do here? We can do PS-E and then O, and then provide a list of formatted output. So you can specify basically which columns that you want to print. So if I wanted to print the PID, if I wanted to print the PPID, if I wanted to print the CMD, for example, and then I will go ahead and sort it, which is something else that you can do. You can sort it by the CMD, or I could sort it by the PID, let's say, and I'll press enter, and it'll sort everything for me in ascending order by the PID of all of the processes that are running that will be pulled up by the everything. So -E will pull up everything, and it'll give you everything in ascending order because we sorted it by the PID itself, right? So let's see, what else do we got here? I mean, the rest of these are kind of options that you can run that will show you in, for example, the forest format. So it says inside of the shell, there's the PS process that's running, and you can see this like nice little kind of forward or backslash and then the underscore that's saying that inside of shell, there was the PS that's running. So that's something else that's very, very useful. So if I did PS-E and then I did forest, it should also give me something similar in that regard as well. That's saying, so inside the terminal, there's the shell that's running, and then there's the PS command that we ran. And then inside of systemd, there's all of these things that are running. And inside of login, we have shell that's running. And then this one's a really big one right here that belongs to LightDM, and inside of that there's Zorg, and then there's LightDM, and then the SSH agent, and then all these different things. So you have Thunar, and then Zoom, and then so all of these things. So it's been shown to you in a tree/forest format just to make it a little bit easier to organize and see what processes are attached to other processes. So in this particular case, LightDM would be the parent process of Zorg, and then in this case, LightDM would be another child item of LightDM, and then it would have this child item, and this would be the parent process for this, and then this would be the parent process for SSH agent, and then this would be the parent process for panel one whisker, so on and so forth. So this is how you can see what the full parent is, and then what all the child processes are inside of that individual parent process, which is actually very useful. And then if you wanted to output these things, the output is what the O command for us does. So we did EO, and then it outputted everything, and then we selected the columns that we wanted outputted. If you just do output by itself and then select, give it the PID or PP, all of the different columns that you want to be printed, you can just do it as the output command. So if I could do, I can actually do ps aux, and then I can do the -o command with it, and then I say I want PID, PPID, and then let's say the CMD, right? And then it'll, oh, conflicting format options. So there you go. Now I've learned something new. So I can't do I can't do aux with the -o, but I can do, for example, ps, hopefully I can do this. So EFO, and then I can do PID, PPID, and then CMD, and then it should give me, there you go. So it'll give me all of that, as well as the tree format, which is very useful. And that's it, right? So that's all we got. That's all she wrote for PS, the PS command. There's a quick little command called PID of that will give you the PID of any given process. So if you know the name of the process that's running and you just want to pull up its PIDs that have been launched previously. So if you remember, we just saw that Zoom was launched as 13.669 as well as 13.670, which would be the most recent instance that Zoom was launched. These are all of the PIDs that are associated with the process of Zoom. And so you can just do that real quick with PID of, if you know the name of the process that you want to check all of the various PIDs that are attached to it, you can just run that real quick with PID of. Let's see if there's a manual for PID of, which there is, and then we can see all of the different options that runs into this as well. So you have a single shot. The program only returns one PID, probably the most recent PID, and then only return the process PIDs that are running with the same root directory, avoid stat system function, so on and so forth. So these are all the different options that would run with the PID of command as well, if you wanted to do it like that. So if I did PID of and then -s and then zoom, it should give me the most recent. So stat, for example, was the most recent statistic, a singular PID for Zoom, which would be the most recent version of Zoom, or the most recent instance that was launched of Zoom. So that's how you can get a PID of a process. If you just know the name of the process and you want to pull that information real quick, you can run PID of. And a lot of these things may not ever be referenced inside of the Linux certification exam. I'm just giving you all of the information because I want you to have multiple ways to get the same thing done. And I hope it's not overwhelming. I hope there's this old adage that says it's better to have it and not need it than to need it and not have it. And that could be applied to anything in life, especially with information. So I want you to have it. Hopefully you won't need it. But if you do need it, I don't want you to ever worry about not having it. So that's what we got. Now we can move on to something called pgrep. We're going to go into grep by itself in a few sections because it is a very useful tool for searching. But just like when you see ls inside of any command, you can rest assured that most likely it's going to list something. If you see grep in any command, you can rest assured that it's going to help you search for something because grep is a search command. So if you do pgrep, it's now going to help you search for a process. And now you need to give it some kind of an argument. So it could be pgrep Firefox, for example, and then it will give you the PID of Firefox. You can do pgrep and then give a username, and then I could give it the Kali username, and it'll give me all the PIDs that are currently running under our Kali user that we have right here. You can also do a pgrep, and then let me actually clear the screen so we're at the top here. We can also do a pgrep that is listing by the process name. So if I did by Zoom, for example, it'll give me all of the PIDs that are associated with the process of Zoom. If I do pgrep and then list by Firefox, because I do have Firefox open as well, and it'll give me the PID that's associated with Firefox. I never closed down Firefox and I never restarted Firefox, so there's only one PID that is available on this list for the Firefox process. And then just like everything else that's available for us, we can actually look at the manual for pgrep to be able to see what all the different options are that you can use And so there's the count, there's the delimiter, there's the echo, there's the full, list name, oldest, newer, parent, session, terminal, UIDs that are available. You can inverse the results, so on and so forth. So there's a lot of stuff that's available over here. And let's see what other useful options for PID we can actually search for. So you can do a search by the command line value of the process. So if I give and I mean, I can also do zoom as my option here. And prep, not prep, sorry. Nope, I don't want to install this. I should be doing P or G. What is it? pgrep. That's what I should be doing. I would do pgrep. My dyslexia is kicking in. And then I give it F for the pattern, and then I would do zoom, and then it will give me everything that has zoom in it somehow. And if you remember when we did the full list of so let me do the EF, and then I will do the forest formats so we can get this outlined right here. And then if we go over here under zoom, so you can see over here, there's a lot of different things that actually have the name zoom in it, right? So I can do bin zoom and it will probably give me a different output, and it will only give me maybe this one particular PID. If I do opt zoom, it'll give me a bunch of different PIDs because opt zoom is the pattern that exists in a lot of different outputs. If I do zoom web, for example, web v, it'll give me that is stuff that is relevant to that particular piece. So if you don't necessarily know the exact name of the process, you can search for a pattern that would be relevant to that process. And what's useful about this is that you can actually do, I mean, I think for the most part, I'm going to test something in real time here. So I could do pgrep and then I'll do a pattern and then I'll do an asterisk and then I'll do zoom. And then, so the asterisk actually doesn't work. So regular expression error, invalid preceding regular expression. So that actually doesn't process that portion of it for me, which is odd because in a lot of cases it should process it for you. If I do pgrep and I do dash F and then I'll do /zoom, let's see, that will give me everything. So that should work. If I do pgrep, let's clear the screen. If we do pgrep dash F and I do a dot, because that's another wildcard character inside of regular expressions, that'll give me everything that has to do with zoom. So maybe the asterisk doesn't work in this particular instance as the regular expression wildcard character. Maybe it's the dot that would work for us. If you don't know about regular expressions, I did a full-length video about how to, number one, how to understand regular expressions, how to create regular expressions. Regex patterns are very, very useful when you're doing search and where you're doing scripting development. And if you're doing, for example, scraping of data from websites or from sheets or documents, it's very, very useful to be able to create regular expression patterns. So that is it that we have for the pattern portion of pgrep. You can also do a count of the number of instances that something shows up. So zoom by itself, right? Because we only had zoom just by itself that showed up. That only showed up twice, right? So if I do pgrep, and let's see if we can test this out a little bit. So if we do opt zoom, let's see how many times that shows up. That shows up 0 because it's actually looking exactly for this particular thing. So if I do now, let's do this, right? pgrep, you do count, and then we'll do dash F, and then we'll do zoom. And then we'll have 14 instances of it that shows up because now we're looking for a pattern that just has the word zoom in it. And as you already saw, there's a bunch of different instances where there's zoom inside of a path for opt zoom, for example, or bin zoom. All of those things are actually being counted in this particular situation. And so what else do we got? We got pgrep. And by the way, I'm just going through the list of all the commands that I have done. I've stored on that and sheet that I showed you at the top of this. And there's a lot of stuff that's over here. I'm just trying to show them to you and also explain them to you. There are explanations inside of the document. But for the most part, I feel like it's useful if I actually kind of show you and explain it to you instead of just giving you a short text description of what each one of these things does. So if we do pgrep-g, and it will look for something by its group ID. And I don't know what the various group IDs are. So 1,000, I think, would be for everything that's inside of the administrator group. And I don't have the group IDs for everything. So unfortunately, I can't give you a precise example of this. If I do pgrep dash capital P, it will give me the parent PID. So I can search by something by its parent PID. So if we do, let's go to PS, and if we do EF, and if we do forest, we should be able to see some stuff over here that would be potential parent IDs. So, or actually, I think it was PS dash or PS aux, I think it was, that gave us everything. Nope, it was not PS aux. What was the command? I want to kind of memorize it by the full name to be able to. I haven't memorized it. I think it's actually EF maybe. So PS dash EF gives us, yeah, there you go. So we have the PPID now. So we have the parent ID in this particular case. So what we have here is the PPID of 2, for example, is this particular instance, which is K thread, right? So for this PPID, for this PID, this PID is the parent ID of all of these other instances. So you can see that 2 is running down the line for all of these things. So I can go by the parent ID in this case, which would be 2. And then it would give me all of these IDs here, all of those processes there. So then we can search for it that way. So let's do pgrep, and then we will do P, and then we'll give it 2, and it'll give us all of these other PIDs that are listed that were associated with that particular parent. So that is how you search for something by its parent ID. And let's see, what else do I have? I have just a couple more for pgrep, so we can clear the screen. We do pgrep, and then we'll do -n, which will give it the process name, for example, in this case. And this is another one which gives you the process name, but it's the most recently started that will give you that. So for Zoom, it should be the 13670 instead of 669. So -n will give you the most recent instance of that process. And finally, pgrep-o, which will give us the oldest process for, in this case, which would be 669 for Zoom, right? So if I do pgrep and I just do Zoom, it'll give me both. Pgrep-n will give me the most recent. Pgrep, man, I'm messing up my spelling here. So let's clear that up one more time. So pgrep Zoom will give us both. Pgrep-n will give us the most recent, and then pgrep-o will give us the oldest. So n would be newest and o would be oldest. That's how you can remember this. Pgrep-n Zoom would be the newest, and then pgrep-o would be the oldest. So we have accomplished everything that we need for process details, finding process details and finding process IDs. So let's move on to our next piece, which is disk usage, disk space usage. All right, now it is time for us to go into disk space usage. And the first command that we're going to run in this particular case is going to be the df command, that stands for disk file system. And so when you run that, as you can see, there's a decent output that comes in here for us. And it shows us the file system and where it's mounted, and then how much of it is actually been used or is in use. So we can see that the udev file system is mounted on our dev, which is typically for physical hard devices, hard drives, not hard drive necessarily, but physical devices, for example, printers and scanners and anything along those lines. You have the temporary file system that is mounted on the run directory. We have dev sdc1, which is mounted on our run live medium, and then dev loop temp file system again that is run live overlay. And then you get to see all of these various partitions and where they have been mounted. And you can see that there's a lot of temporary file systems because there's a lot of temporary files that get used or created as you open up new devices, as well as processes, services, so on and so forth. So each one of these things will get its temporary file system just to store any temporary caches or any temporary files. And then when you close that process, or when you close that software, when you close that service, that temporary file system goes away. There is the one at the very bottom right here, which is my actual external hard drive, the Media Kali F7 DC, etc., etc. That's the hard drive that I'm storing all of my recordings to, and that is one of the only partitions in this particular case that is actually connected to something that I am using. We have something that is on our root file system, and everything else is pretty much either in the temporary or in the run processes that are actually running something, and the dev file system, the dev partition as well. So if you refer back to the lecture that we did, there are several primary partitions, and then we have the extensions of the primary partitions, and then from there we have logical partitions. And for the most part, all of these things are logical partitions with the exception of this root partition, which is actually our primary, and then everything else is pretty much an extension. And then this piece right here is also an extension, an extended partition that is mounted onto the media /Kali/ the name of the drive itself. So this is what df does. Just if you run it without any of its options, it'll just start listing its various partitions that are available on this thing. And of course, just like every other thing, there are several options that kind of help us get more out of the disk file system command. So we have the df-h, which essentially prints everything that we just saw, but supposedly this is supposed to be in a human readable format. So I don't really see much of a difference. I think actually there's a lot of the various line items previously that are no longer here. So maybe that's what it means when they say that it's human readable. It's just not as much data that's been printed onto the screen. But apart from that, it looks very similar to the previous command that we ran, which was just df by itself. We have df-T that will give us all of the types of the file systems that we have along with their usages. So these are our file systems, and then it tells us that this is a temporary file system, this is a VFAT temporary file system, so on and so forth. And then this one right here, it's an exFAT type of a partition, an exFAT file system, because I want it to be readable on Mac OS as well as Windows as well as Linux, right? So exFAT is one of the most commonly used when it comes down to external hard drives because it is cross-compatible. But for the most part, you'll see either NTFS, which is for the Windows, it's very not intuitive, but there is a specific word that I'm looking for, but it's specific to Windows. It's dedicated to Windows. And then you have the XFS and then the various other types of file systems that we had when we went through the file system hierarchy and the file system standards in our lecture. You do have to excuse me because it is actually late in the day right now. It's almost 10 o'clock where I am right now at night. And so I'm trying to get the most that I can with these explanations, but I am kind of running on fumes. So I apologize if I run out of the proper words to describe these things, but I promise I'll get the point across for you. So this was the -T that will actually give us all of the types of the file systems, types of the files partitions that we have running. The next one is going to be df-A, which will give us pseudo, duplicate, and inaccessible file systems and anything that has a 0 block that's attached to it. So if we look at the 1K blocks right here, and then you have all of the 0 blocks that are included, which previously we didn't really have. So we have the security file system here that wasn't previously included, the P store as well. A lot of these things that are not actually being used by anything, and they're essentially, I guess we can call them pseudo maybe, so pseudo or duplicate or inaccessible. We can definitely call it an inaccessible file system. And these are all viewable by -A, but it also brings all of the ones that are currently usable and being used as well. So -A, as I mentioned earlier, it kind of shows everything. So it shows all of the file systems that are available, and that includes all of the inaccessible ones and all of the duplicates, etc., etc. Then we have df-I, which will give us the information about the inodes instead of the actual block usage. So we have the file system itself, inodes in this particular case. 1024, etc., etc., etc. I actually have to find out what this means so I can give you a better description of what that actually means. But then there's I used, there's I free, and then I usage percentage, and then where it's actually been mounted upon. So I'm actually curious about this one. So let's see what inodes means. All right, so we are talking to Copilot, which is the Microsoft AI here, and it says inodes are the index nodes, and they're essential data structures in a file system that store metadata about files and directories like their file size, their ownership, permissions, timestamps, number of hard links, so on and so forth. Each file and directory has a unique inode, and the inode number is used to locate the actual data block that contains the file's contents. This system allows the file system to manage files and directories efficiently. When you run DFI, it shows the inode usage and availability for each mounted file system, similar to DF shows disk space usage. The output includes the file system, the inodes, which is the total number of inodes. I use the number of inodes that are used, the number of free inodes, and so on and so forth. So essentially what it does is that it displays the essential data structures, for example, the file size, ownership, permission, timestamps, so on and so forth. And this is for specifically to try to find the metadata that's been stored inside of these various partitions. And metadata typically is not visible and it's not human readable, accessible, unless you actually look for the coding or the source code, so to speak. So metadata is what's going on behind the scenes for every individual file, as well as directory, as well as file system, as we can see in this particular case. So the command is particularly useful for monitoring inode usage, especially on systems with a large number of small files, because running out of inodes can prevent new files from being created, even if there's available disk space. So this is very, as we can see right here, it's very useful for creating new files. So if you're running out of inodes, that means you can't create new files. And essentially an inode, from what I'm understanding, is that it's the number of files that can be generated on any given partition. So if we actually go over here, we can see that there is, 4 million inodes that are available. 596 have been used, which means that there's over 4,080,900 that are available for us to use, meaning that we can potentially create another 4 million files essentially. And this is all what all of these things are attached to. Now, what's interesting in this particular case, my external database, my external file system does not have any of this data. It's only available for the local machine, the USB boot live Kali Linux here. But I know for a fact that I have over 900 gigs of accessible storage on this, no, over 950 gigs probably of accessible storage on this particular drive, because it's a terabyte drive. And I haven't even scratched the surface of this particular thing. When we ran our previous commands, so let's actually run them, right? So if we go to a DFA, for example, when we run the command right here, we can see that we are 1% used on this particular drive, because it has still over 970 gigabytes that is available, 970 gigabytes that's available on this particular drive. So I know for a fact that I can create, millions and millions of files on this particular thing, but in this particular case, it doesn't show it when I run not DFA, but DFI, because DFI nodes seems to be very intuitive or specific to our particular machine itself, the virtual machine itself, and it doesn't count any of the external drives. So that is very interesting to me. So we are going to now move on to our next piece of instruction here, which has to do with the dfht. So now we are combining two formats here. So we are combining the -h, which is supposed to be human readable, and then we're combining the -t, which is presenting the type to us. So you do that, and then now it gives you human readable format, and then it also includes the type. So this is basically just to say that you can combine various options to display multiple views and multiple data points, multiple columns, so to speak, for each one of these tools. So that was HT combination, Then we can have the dash L. We have the df dash L, which is only for the local file systems. So this is what that looks like. And it does not include anything that may be connected to a network, for example, so a network share file system or things like that. Then we can get something that has to do with the totals of our available file systems, and that would be done with dash dash totals. And then so you have, again, the 1K blocks, so 1,000 blocks, meaning that in this particular case, I have 976 gigs available, and the total at the bottom shows me how much is totally available across all of my file systems, and then how much is actually totally available after all of the data that's been used. So in this particular case, we have 1.3 gigabytes in total that has been used across all of our file systems. Is that 1.3 or is it that is actually 13? So there you go. I need commas to be able to know how much data has been used. So that's actually 13 gigabytes that's been used. And then across that, we have over a terabyte of available storage across all of our file systems. And that gives us the DF total. And then we can also, very similar to a lot of the other tools, we can output, customize the output that we want to see what is available or what data we want to see, right? So I can do output equals the source. I can do the FS type, so the file system type, the size, and used, available, and then psent, right? I can do all of these, and then now it's a little bit more clean for us to be able to analyze what's going on over here. And so it shows you what the name of the file systems are. Now, in this particular case, if you don't know what this partition is attached to, you won't really know what that external, if it is an external drive or where it's located, right? What that actual path is. So in that case, I would be very curious to find out the mount point of this as well. But, I digress. I don't want to get too deep into it because there are a lot of other things that we do have to cover. But again, I will say that if you just want to see what is available, we're going to look at the manual of our df command, and it shows you all of the options. So dash A, it is all, as I speculated. So includes everything, including the sudo, duplicate, and inaccessible. We have the dash B, that shows us the block size. We have dash H, human readable, dash capital H, which will be in powers of 1,000. The inos themselves, the K, which will be the block size in kilobytes. Then we have the local, limiting list to the local file systems, no sync, so don't invoke any sync before using them, the output of what you want to see, so on and so forth. So there's a lot of different options that are available, including the dash dash help that will be very similar to what we're looking at inside of this manual. So that is it for our disk file system command, our df command. Our next one is disk usage. My accent kicked in there. Disk usage. So du for disk usage. And du just by itself, you can type that and it'll show you what all of your different partitions are. And then we can see that there's a lot because it's even including the Zoom partitions and everything else that's associated with it. And then the actual usage of every single one of these things. This is going to be a very massive list because if it's showing me everything that's for Zoom and all of the caches for Zoom, I know for a fact that this is going to be a massive, massive output. So what we need to do is use some of the various options that are available for disk usage to get a little bit more user-friendly data. So disk usage dash H. So du dash H will also give you data points as well. So in this particular case, I would say the difference that we see right here that maybe is very useful is that this is du by itself. So this is the output that you see for du by itself. And then if I just do du dash H, then we'll see that the series of numbers that I had previously have now been turned into megabytes, right? So I have 745 megabytes on my root right here. I have 68 kilobytes that's been used on here, 420 megabytes on the Zoom, so on and so forth. So I would say that this is probably a part of the human friendliness of the output that we can see when we do dash H. So that's always a good option to have. So we can just combine that with the rest of these things now, right? So we can do du-sh, that would give us the file or the usage for the specified directory, which in this particular case has been just our root directory, which is what this dot represents. So the dot represents the directory that I'm in right now. So this, if I do ls, this is showing me the home directory for my Kali user in this particular case. So I can do essentially any path that I give it, right? So if I go ahead, and I'm going to kind of get ahead of myself a little bit. So when we do lsblk, it lists block services. We're going to go into this particular command in depth a little bit later on, but I want to find the paths to all of my partitions right now. So when I run du-sh, I can actually search for a path and a partition. So if I do media Kali and then I do f7dc and then dash ff50, hopefully, yeah, it'll show me what the use is on that particular device, which means that 514 megabytes of that particular partition has been used out of my 930 gigabytes that are available on it, right? So you need to give it a path. If you don't give it a path, it'll just take that specific location that you're in, which in this case is going to be the my print working directory. So let me actually clear this up a little bit. So this is my current path. It's the home of my Kali user that includes my desktop documents, so on and so forth. So on this particular location, when I run du-sh, on this location, that's how much has been used. It's been 745 megabytes of that location has been used. Now, if I go to desktop, let's see what that does. So if we do du-sh on my desktop, it says 4 kilobytes has been used on my desktop, which means technically in this entire location, which includes my desktop, I have 745 megabytes that's been used. And when I go into the desktop, only 4 kilobytes has been used because there's literally nothing on my desktop. So if I actually list what's on my desktop, it's just the zoom dash desktop shortcut that I have on my, and that's basically it. That's all I got here. So obviously it's not going to be a lot of memory or a lot of storage that's been used on that particular path. So just to kind of wrap that portion up, we have du-sh, and then you just give it a path. And then for that, it will show you what the various locations, for example, media just by itself has 538 megabytes that has been used, and so on and so forth. So you do need to give it a path when you use dash sh. And then you have du-a, which is very similar to the previous one, which would be everything. It includes all of the partitions, so everything that is the files as well as the directories, so on and so forth. And then we can combine this with the h for the helpful command. So at the very least, we get some kind of a megabyte, kilobyte, etc. that's been associated to those numbers that we see on the right side over here, or on the left side, excuse me. And then we have du-c, which will be the total of the end of the output, which will be this piece right here. And then so again, I'm going to do du-ch to make it human readable, which means that in total, there's been 745 megabytes that has been used in total across all of my file systems. We got du-d, and then I'll add the h to make it human readable. Oh, I see. So now that you can't do that. So I'm just going to do du-d by itself. And it says it requires an argument. So what I need to do is I need to give it the output depth desired. So that's actually what that is. So we have the du-h, and then what we can do in this case, we can say a depth of 1, maybe. So no such file or directory has existed over here. So du-h for the depth. So let's see, we can maybe do 10. Let's see what that does. That doesn't show anything either. So I think it's because my current directory doesn't really have much in it. So let's see if we can do a combination of a few things here. So if I do, let me see, I'm going to try a couple of commands and hopefully I'll get some kind of a good result here. So I know sh will actually take me to a given folder, so media, for example. And if I do d-1, summarizing conflicts with max depth 1, help for more information. I mean, it's supposed to give us the depth, so I'm a little bit confused as to how to craft the command on this. So what I'm going to do is I'm going to refer to our little AI helper and see if we can get any decent information. Okay, so that's what I was missing. I had to provide the path at the end of the command. So for example, the current path that we're on, which is our home for the Kali user, this would be the depth of all of those directories that are available on this particular path that we're on. So if I actually do, let's say du-d2 for that, it would actually give me what's inside of videos in this case, which is what we have over here, and then what we have inside of the cache folder as well. Or what is this? This is a very large portion right here. So it's going to give us, it's going to go into multiple levels if it possibly can to give us what is inside of that individual directory as well as any other directories as well. So if we did du-d and then let's do 5 and then we go into the etc or not even the etc. So let's say media. If we go into media, now we get to see what is all inside of here. So for example, I have media and then I have media Kali and then I have, and then actually we can go from the bottom right here. So we have media, then we have media Kali, then we have media Kali, the partition, and then we have media Kali, the current one that's being recorded right now, which is going to be stored in that particular folder. Then I have the 12.13, 12, so on and so forth. And these are the ones that we just completed. So we are now in the 12.1 section 4. And then these are the other files as well that are hidden, and that's implied by the dot at the beginning of it. These are all hidden files that you're not going to see regularly. And then I have the folder of Linux introduction outline. So if I actually ran that same exact command and I did du-d and then I did 6 and then we did media, it will give us the extras of what's inside of these various locations. So Linux intro outline still doesn't have any other directories in it. This one actually has info. This one has files, expunged, so on and so forth. So it'll give you as many directories as it exists. So if it stops at this particular path right here, that means that this was the last directory. And then inside of this directory, there's going to be a file or a series of files. So it's only going to show you the depth of the directories, right? The depth of the folders. And then so if I did that same exact command, and then let's see if we can do a human readable version of it. There we go. And now we have the 76 megabytes. So this one uses 76 megabytes of storage. This one uses 60, 64, so on and so forth. So we can see the human readable version of this particular command. This is actually fairly useful. So be able to get the depth of the directories in any particular location to see how deep it actually goes. So that was du-d. Now we have the du-s, which will give the total size of each particular location. And I do need to give it a path in this particular case as well. So we just do -s and it gives us the size in. And so this is actually no different than that sh, but what we had previously was it was giving us the human readable format. So -s just gives us the size. So we can do the same thing where we go -s and then we give it the media path, for example, and it'll give us that. And then if we do -sh and then media, it'll give us the human readable format of that. So -s gives you the size of that individual location. And then we have du-x, which will skip directories on different file systems. So let's see if we did it for root, for example. Holy shit. Excuse me. Excuse my French. There's a lot of stuff that's going to be printed out because inside of my root folder, there's a lot of stuff. So that was probably the incorrect location to try to run this for. But it's going to list the usage and then skip the directories that are on different file systems. So anything that would be on a different file system, it would actually skip. So we're just going to work with our media file system, for example, and I'll do media, and it only shows me the various directories inside of this particular file system, and it'll skip anything that would be on any other file system. So it's going to show me only the stuff that's here and then skip everything else, right? So skip directories on different file systems. That's what X explains for us. And let's see, we have du-time, which will be the last modification time for all of these locations. And then we have the modification time that's associated with these items. So the last modification time for Zoom, for example, which was, these are all today's dates because this is the live boot that happened today. So everything is going to be dated today. They're just going to be at different times. But the modification time is actually very useful. So doing the --time will give you the modification time. And then you can just do something as simple as du-exclude. If you want to exclude something in a particular location or anything of the sort. So if I actually did, and this is a pattern type of a thing as well, so I can do the asterisk dash log, meaning exclude anything that is a log file, and it'll give me all of the file systems apart from the ones that have a log in them, for example, which is still a massive amount of results that will be generated with this location. And then we can combine this with the dash H to make it human readable, which will include the measurements, so on and so forth. So you can exclude anything from your results. So let's try another one real quick, just for the sake of our friendliness. So if I do dash zoom and then, or the asterisk zoom and an asterisk, hopefully this will exclude everything that has zoom, and it does actually. Now it shows me everything that has to do with Firefox. So there's a lot of stuff that would be related. So I can now, let me see if I can combine this to get a couple of results here. So if we do exclude zoom, and then I can probably combine this, but let's do exclude as well, and we do Mozilla as well. And let's see what we get. There we go. Now we got a much smaller series of results here. So we can definitely list everything. And that, I mean, I was able to even reach the top of these results because we excluded all of the Zoom caches and the Mozilla Firefox caches. And now we can actually scroll through everything that we got. So that exclude option is actually very useful, especially when you have a massive amount of output, the way that we just saw with our disk usage command. So that was it for disk usage. As always, you can just go to the manual page for disk usage to look at all of the various options that are available for disk usage, the du command. So moving on. Okay, so our last series of commands gave us everything about storage and the amount of storage and availability and how much was used, so on and so forth. Now we're going to be talking about memory storage, which is a different type of storage, or the different type of usage that we would be tracking. And the memory has to do with everything like the RAM available, as well as swap space that is attached to the power, the computing power that we're dealing with. So first and foremost, there's a very, very simple command, and it's called free. So you just type free, press enter, and it will give you the memory usage, including the total memory available, the used memory, the free memory, and swap memory. So we can see it over here. And then of course, as you can see, as you can imagine, probably there's the human readable format. So you have this version up here that says 327 yada yada yada, or it could be 31 gigabytes, right? And then you have the 6.8 gigabytes that's being used, 22 that's free, 2.8 that's being shared, and then you have the 5.4 that's in the buffer, as well as the cache, and then 24 gigabytes is available after it's all said and done. And nothing is being used in my swap space and my swap partitions, mainly because of the fact that the RAM on my PC is actually fairly powerful. So I don't need to use anything on my swap space. Swap space, as we covered in the lecture portion, is mostly dedicated to computers that don't have that much RAM. So usually if you have maybe, let's say, 8 gigabytes or less, which I think 8 gigabytes is still substantial enough to do most computing. So let's say maybe 4 gigabytes or less. If you have 4 gigabytes or less of RAM, which is very little these days, like most computers these days come with a base of 8 gigabytes at least. So if you have 4 gigabytes or less, then swap space is very important. And I'm not going to explain what it is, because we did a deep explanation of what swap space is inside of the lecture portion. So if you wanted to just find what the availability was and how much was being used in your memory usage, you would just use free-h to make it human readable. And then we can do free-h and then do M to display everything in megabytes for ourselves, which in this case is actually still doing the same thing. So let me see if I do free-M by itself, it'll now give it in megabytes. So these are the 31,000 megabytes, for example, which would end up being 32 gigabytes, right? So if I did free-M and then I did -H, maybe that'll work. No, it's still doing it in gigabyte format. So if you do -H, it's going to default to displaying it in gigabyte format, because I think it will just shrink it to its lowest number of characters that are being printed on the screen, which in that case would end up being 31, and then it would just give you the GIB for gigabytes. Then we have free-G, which would be in gigabytes, which is very similar to what we just talked about, except it just doesn't show the GIB at the end of it. So this is, as you can see, it's very similar to the output that we get to free-h, except it's not doing the gigabyte or the GI portion. It's just giving you the number that is resulting. So we can say that this is in gigabytes. So 31 gigabytes is available on our particular series of partitions, or not partitions, but our memory, our gigabyte memory, our RAM memory, excuse me. We can do the same thing with K if you wanted to display it in kilobytes, which is insane. I don't know why anybody would display it in kilobytes because there's just too many numbers to count. Then you can do free-b, which will explain it in bytes, which is even crazier, which is, again, I don't know why anybody would do that, but that you can essentially display things in a variety of different formats. And the most useful, in my opinion, is just free-h, and it'll show you the amount of RAM memory that is available in gigabytes, and it gives you the GI at the end to make it super user friendly. So now what we can do is do free-t that will add a line giving us the totals that are available in this case, and it's defaulting back to those. So if I did th, hopefully, yeah, there you go. Th actually gives it to us in human readable format, and it also has the total that is available at the bottom right there. Now, if there was, swap space being used, so on and so forth, it would alter the total numbers that we get at the bottom. So that part is, in this particular case, is not really applicable because we are not using anything in our swap space as far as my processing memory usage is concerned. And then we have free s in, and then we just give it seconds. And so let's say I'm going to do 3 seconds or 2 seconds. And what it's going to do is it's going to refresh this every 3 seconds, right? And then I would have to break this by doing Control C, because it's just going to keep refreshing and keep giving me an updated amount of when, like, the usage itself is concerned, the memory usage that is being concerned, because again, this has to do with processing power. This doesn't really have to do with storage, right? So this is kind of similar to what we would get with the top command, except we're just dealing specifically with the RAM memory usage. And we can do the same thing by using si, which will give us the sizes as well. So I is an invalid argument. So never mind, that's not even possible for us to do. So let's do man free and see what the various options are, because in my notes I actually have I. So I'm wondering if that was a silly, no, I do have si right here. I think it's supposed to be dash dash si. So it has kilo, mega, giga, etc. power of 1000 instead of kibi, mebi, or gibi, the power of 1024. So that's what it was. I think I was missing an extra dash in my situation. So I do dash dash si. There you go. Now it displays it, which is, I mean, it's not, I think it actually is closer to what I had versus free dash h, or not even free dash h. So if I just do free by itself, we can see that if it's doing to the power of 1000 instead of a power of 1024, because this is being done by the power of 1024, it's estimating less than what I have available, whereas in this case, it's actually estimating closer to the precise amount of RAM availability, memory availability. So if you do SI, it's a little bit closer to the actual thing versus just doing free by itself, or any of the other versions that we had where it was doing to the power of 1024 instead of doing the power of 1000. But again, free just gives us the amount of RAM memory that is being used and how much we have available. And if your swap space is being used, it's going to show you how much of your swap space is available and how much of that is being used. All right, so there are a series of very simple commands that we can run to try to find out who the logged in user is, or who the logged in users are. And the first one is who. And in my particular case, there's literally only one, which is the Kali user. But it would display a list of users that are currently logged into this particular system. And this could be people that you are managing in a virtual environment. And there are a lot of people that are logged into your overall system. They just have different users, and maybe somebody temporarily signed out, but they're actually in kind of like a hibernation mode. So somebody else may be using that terminal, or somebody else may be getting access to your Linux server. And then you just have a variety of users that are logged into your server from different locations in the building, or they're located in different branches across the world, but they're still logged in to the server that you are currently administering, right? So if you just run who, it will show you the list of all of the users that are available. Now I can do who am I, but typically it's actually done as one command. So it would be who am I, and it'll give me the name of the current user that I am in, which is Callie. And if we combine that with hostname, it'll say I am Callie, and then the hostname is Linux, which gives us Callie at Linux is going to be our complete login if we wanted to SSH into this particular machine, for example. And then we would need to typically it's actually not even Callie at Linux. I'm kind of getting a little bit ahead of myself, but if I did ifconfig maybe, and I got the list of the IP addresses that was attached to this, and I already know based on what we did earlier that we actually have this IP address. So it would technically be Callie at this IP address because this IP address is matched up to the Linux user, right? Or the Linux host, excuse me. But again, I digress and I kind of get a little bit ahead of myself, so forgive me for that. So we have who am I, which actually gives us the name of the user that we are that are currently logged in. We can do who-b, that'll give us the date and the time for our specific boot and really the system that we are attached to. So it shows us the date and time when our system was last booted, which in my case, again, was 12/1 at 15:29. So this is the, I think it's called it Army time, because 15:29 would technically be 3:29, right? 3:29 p.m. So that's what who-b does. It gives us the boot information. And then we have who-d, which will list the information about any dead processes that we have in this particular case, which, I mean, I think there's nothing, right? Well, I don't know exactly what the PTS. So let's go look at our AI assistant and see what this output means. Okay, so what it stands for is the pseudo terminal devices, which represent virtual terminal connections. Now, they typically are for remote login sessions, but because I am actually booting from a USB drive, it can actually apply to me as well. So it would create a virtual terminal connection to manage login sessions and processes. So that's what the PTS actually stands for. So PTS1 and PTS0 are the two various terminal sessions that have been generated for me accessing this Callie machine, excuse me, from my USB drive. So that's what PTS and PTS1 and 0 represent in this case, which would be all of our, I guess, our dead processes in the previous session. Then we can do who-h would be the headers that would be added to this whole thing. So it would be the name, line, so on and so forth. So I can actually do this with pretty much everything. I should be able to do it with everything. So I should be able to do it with the -d command, for example, which was the line in this particular case, which was this. These are the lines of the connection, and then the times, and then the PIDs of those connections, and then the comments, so on and so forth. So the -h would actually just add headers to everything, which is actually very useful, especially if you don't know what you're looking at. So we can do, for example, who-l, which will give us the login information for our current session. We can do who-q, which will list the logged in users in our session, and the total number of users that are available for the system that we're logged in on. We have who-r, which will be the current run level, which is the run level 5. So if you remember anything about the boot process and run levels, run level 5 represents the multi-user as well as the graphic user interface for what we have in system D. So run levels are associated with the system D initialization processes. So who-r will give us the run levels for our current user, as well as who-t that will give me the terminal line status of whether it's actually writable or not. Meaning that each user should have the availability. So if I do who-th to give us the headers, it'll say that this particular person should, from what I understand, actually have the availability to have a writable terminal, right? Then finally, we have who-u, which will be the logged in users again. So this will be the same as doing who by itself, and it'll give us the logged in user. So you can do who-h, and it'll give you the name of the person, the line that they're logged in on, the time that they logged in, so on and so forth. So who is essentially the most basic command that you can run to find out the users that are logged in on your server or on your particular machine. And if you wanted to know who your user is, you could just say, who am I? Because sometimes it doesn't say the actual user at the beginning of the command line, and maybe you're actually logged in through SSH, through some kind of a pen testing exercise, and you want to find out who you actually logged in as. So you would run in who am I to try to find out what that is. As always, we can just do man who to look at the manual of everything that is available for the who command so we can see what else we can do with that various command. But who displays the users that are currently logged into the system. That's basically all you need to know about that. So moving on to the next one, the next command in our logged in user series would be the W command by itself. So if you just type in W, it'll send you the list of the people who are logged in and what they're actually running. So what are they doing? And this is what the last piece right here represents. So I have the light DM session, and then I have the shell that I have open, and then systemd, which is obviously our initialization that is currently running. And this is basically what is actually running. So the activity that we have, the system uptime and the load average time, which is available for us over here. So this is the information that we would get if we just did W by itself. Now, if you do W-H, it'll display it, but without the column headers. So this is actually the opposite of being human readable. So I would prefer W by itself because now it actually gives us the column headers, which I think is always more useful to actually have the headers of the column so you know what you're looking at instead of having to kind of guess what you're looking at. Then you have W-S, that will display our logged in users and the activity that they have in a shorter format in this particular case, which is kind of interesting because it doesn't give me the user itself. So in this case, it says user is Kali. In this case, it's just saying the user is the shell, and then we have the segmentation and then fault, so on and so forth. So this is actually very interesting. I prefer W, but W-S is supposed to display everything that we have in a shorter format, and it should essentially be displaying the same thing. I do prefer W by itself though, so just know that W-S will be displaying the logged in user and what they are currently doing, and then it does it in a shorter format. So it does the same exact thing that W by itself does, except now when you do the -S at the end of it, it's supposed to be the shorter format of what the W command does, which is show you logged in users and what they're doing. Then you have W-U, which would be the user activity without trying to match the username to processes. But again, in this particular case, I don't have anybody other than the Kali user, so it'll be a little bit kind of redundant or useless, oxymoronish, so to speak, to try to run that by itself. Then you have W-F, which will be the include of the remote host information for any logged in users, but we don't have any remote hosts, which would just represent our Kali user, but W-F will give you remote hosts if you needed it. And that's basically it. So who will give you the list of the logged in users, and then there's a variety of different options that we can run with who. W by itself will give you who the logged in users are and what they're actually doing. So what services are they running? What is their activity? What software are they using? So on and so forth. So you have those two various commands for getting logged in users. Now, this is very, very different than user administration, right? So we have a full section that's dedicated to creating users, managing users, deleting users, and the same thing with groups and permissions and all that stuff. So this has nothing to do with that. This is just getting system information. All of this that we've been talking about so far has been getting system information, and everything under system and kernel information would be getting the system and kernel, the system uptime, process details, disk space usage, memory usage, and logged in users. All of that stuff falls under the system and kernel information. So now that we have all of that, we can actually move on to the next major section, which is our file and directory management section. So let's jump into that now. Okay, so let's now talk about our file and directory management series. So there are a lot of things that we're going to be talking about in this particular section. This is actually a very, very useful section in my humble opinion. So I hope that you take some good notes and you practice a lot of the stuff in this particular section because they're actually very useful in your everyday life as well as in your job if you ever go and become a Linux or even a Mac OS administrator, because a lot of these commands, I think all of these commands actually directly apply to macOS as well as Linux, because macOS runs on Unix, and then Unix is also the foundation of Linux. So the syntax of the languages when you interact with the shell are very, very similar to each other for those two operating systems. So the very first thing that I want to talk to you about are the operators.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
Operators can come in a variety of shapes and sizes, so to speak. So we have the general operators for, I would call them functional operators. So you have mathematical operators, comparative operators, and then you have functional operators. And functional operators could be something like if I wanted to do echo, let's say hello world. If I wanted to just print that onto the screen, that's what echo does for you, right? Now, if I wanted to echo hello world and then put that inside of a file, I would do that like this with this greater than symbol. And then that would actually be placed inside of a file. Now, instead of actually doing that, I want to start doing this on my desktop, or yeah, desktop is probably a good place. So we'll go into the desktop and then we'll run all of these things inside of the desktop. So we'll do hello world, and then we're going to put this inside of the greetings.txt. Okay, so that'll be our text file. And instead of now printing that onto the screen, we'll see that that hello world is no longer on my screen, but it's been stored inside of that greetings.txt file. And I should have done this earlier, but there was no greetings.txt file on my desktop prior to this. So what happened is that when I ran this, it created a file called greetings.txt, and then it output the result of this specific command inside of this particular file. So what this does right here, it will output the any output of any command. Essentially, I could run a scan, for example, and I don't want to see the results of the scan on my screen, and I want to see that full report inside of a text file. So I could just run the scan and then run it on my text file, or output it onto my text file, which is actually very, very useful. Now, what's interesting is that we can kind of combine a series of commands here. But I can first, I'm just going to verify this one more time, or I'm going to show you a different piece of this one more time. So if I have the greetings.txt and I just do cat of the greetings.txt, it'll show nothing in this particular case, because unfortunately, for whatever reason, the hello world didn't write into my text file. So let's see why it didn't write into my text file. And then let's do the cat greetings one more time. Okay, now it actually shows. I don't know why it didn't show it last time, but it should have shown it the first time around. So that's what happened. Instead of printing echo or printing hello world onto my screen on my terminal, it put it inside of that text file, and then I'll do cat to display the contents of that text file, and then now we see that we have a hello world. Now, what happens is if I do this in a different format, so what's up? Let's say we'll do what's up, and then we'll put that inside of greetings.txt. What that does is that when you run cat again, it has actually replaced the original content. So originally, it was hello world, and that displayed hello world. But then when we did this, and then we used this single greater than symbol right here, it then displayed what's up, because it replaced the contents of this. It replaced that with this. So this is very important to understand. When you use a single greater than symbol and you want to output the results of something into a file, it's going to replace everything that is existing inside of that file. So if you want to add contents to a file, you never use the single greater than symbol. You would use the double. So this is what that looks like. So we already know that the greetings text has what's up in it. So if I wanted to now add hello there human, we'll do the double, and then from there we will go into greetings.txt. And then now if I cat greetings.txt, it'll say, what's up, hello there, human. So it's actually appended this value, meaning it's added it to the end of the file. And now we have both of our entries, right? So if you're creating a backup, for example, or if you're creating a script, that if you run the script every single time, there's going to be new output generated for a log or for really any kind of data, for data processing, for document processing, for data storage, anything of the sort, where you don't want to lose the original data. You just want to keep adding data to that file or to that location, or it may not even be a file, right? It may be being input inside of an external location, inside of a network file share, for example, and you don't want to replace everything that's inside of that file share. What you want to do is you want to just add to it, you want to append to it. Then you use this double greater than symbol to just add to it. And then we can just keep continuing on with this, right? Where it's like, I am not a human. Who are you? Whatever, right? But I'm having like a conversation with this text file. So I have that. And then now I can go and I can cat the greetings.txt file. And then from here, now we have the full list of the commands that we've done. So when you do the double symbol, what it does is that it will append instead of replacing the contents of that file. Okay. Singular, the single command like this, it will replace everything. If you do a double command, it will go ahead and add it to the end of the file. So that's very important to understand. There's another series of operators that are available for our operational operators, and that would be the and then the ampersand, or excuse me, the ampersand singular or the double ampersand, and then they have different uses. So for example, if I do echo who are you, whatever, and I want to add this to my greetings file. If I want this to run in the background, so this is not useful in this particular case because this is such a quick command and this is going to run immediately and I don't need to run it as a background process. But let's say this was a scan, right? So let's say I'm creating this massive scan and that scan is going to take 20 minutes, 30 minutes. And that happens a lot with cybersecurity. If you're doing incident response or something, scans take a very long time to complete. So if you want that to run in the background so that you can continue using your terminal, right? So this piece right here, this terminal, sometimes you only have one terminal depending on the Linux distribution that you're in, and maybe you're inside of a server environment and you can't just click the terminal and then open up another terminal like I did over here. You would actually have to work inside of the same exact terminal. So if that's the case, you add this and at the very end of it, and it will run this entire thing in the background, okay? So that's what the singular ampersand does. And then you add it to the end of your overall command, okay? So singular ampersand does something in the background. Keep that in mind. The double ampersand is very different from the singular. The double ampersand combines commands. So we already know that if we do echo, who is this? Who are you, whatever. If I do this and I add this to my greetings file, I already know that this is going to take this and it's going to add it to the end of my greetings file, right? So what I want to do now, let's say I want to combine this with a display on my screen and the second command. So when I do double ampersand here, I'm combining this command with another one before pressing enter, right? So now I want to say echo, and then we're going to say message added to greetings, right? Wow, there we go. So that is the second command. And then now I'm going to add another one and I'm going to say echo, I don't know who you are. This is like a very random conversation. And then now we have the second command that we are now actually adding to our greetings file. And then we're going to say echo second message added. Okay. So now what's going to happen is that this first command right here is going to add this string to my file. And then I'm going to get a notification on my terminal that says that the message was added to the greetings file. And then I'm going to add this message back to the end of the greetings file again. And then I'm going to print that the second message was added. And I did all of this by stringing together all of these commands. So I'm technically stringing together 4 commands and I'm combining them with the ampersand, double ampersand operator. So now I press enter. and I have two things that are printed onto my screen. So these are the two messages that I've created for myself, which are going to be the notifications that I made that, hey, the first one was done. Cool. Now the second one was done. So now if I actually go and look at my greetings.txt, now we see that, look, who is this? Who are you is actually added to the end of the file. Perfect. And then I don't know who you are has also been added to the end of the file. So now both of these commands have been executed and they're done together. So what you can do is you can combine a lot of these commands together, and you can do this with the double ampersand. And then it obviously it's not limited to just echoing content inside of a text file. As we go on with the rest of our file and directory management structures and everything else that we're going to do, we're going to use this double ampersand in multiple instances, and then you can see how useful this can actually be, and honestly how much easier it makes your life as an administrator. So that's what we had for our operators. Okay, so let me clear this up, and then now what we're going to do is we're going to move into actually dealing with the directories and the contents and the file creation and everything else that's going to come with what we're doing with the file and directory management. So I wanted to teach you those operators first, and then we'll go into the management of the actual file and contents and everything like that. Actually, my bad. So real quick, I actually need to tell you about the comparison operators as well, real quick. So we talked about the operational operators, the functional operators, but now we need the comparison operators. So there's something called less than or greater than. So we already see that we have this as the less than sign, we have that as the greater than sign, and then there's the dash LT, which is standing for less than. You also have dash GT, which is for greater than, and then there's a bunch of different variations to this where you have dash LE, which would be less than or equal to. You have dash GE, which would be greater than or equal to. You have dash EQ, which is equal to, and then NE, which would be not equal to. And so these combined with the less than as well as the greater than, all of these are used for digits, right? So they're used for integers, aka numbers. So all of these operators are used for numbers, and this is more useful when it comes down to the scripting portion that we're going to get to. But I just wanted to introduce them since we're already here at this portion with our operators. So these are our comparison operators, and we have these that are specific to the numbers, the integers that we're going to be dealing with as we go into scripting. But then there needs to be some kind of a comparison operator for strings as well. And for strings, it's actually, this is the equal to, so that's the double equal sign. So you have a singular equal sign and you have a double equal sign. So that means that so-and-so is equal to so-and-so. So a variable is, it's checking, right? So it's, we're going to say if, you know, variable is equal to value, okay, then you do something else. That's essentially what scripting, that's one of the really big things about scripting. This is called the conditional portion of a script, a conditional function or conditional operator. So we're not going to be talking about the nitty gritty of this, but I want to show you what it means when you compare something. So we're looking at the initial portion where it says, if this piece is equal to this, then go do something. Then there's the version where it's like, if this piece is not equal, so that's, and you can see, I love the fact that it actually does this. But what I just did is I put an exclamation mark, and then right after it, I put an equal sign. When you do that, it turns it into a not equal sign, and then that would be value. So then you would say, if the variable does not equal this particular value, then I want you to do something else, right? So there is the iterative, not iterative, excuse me, the conditional statement of if something, then do something else. That's a conditional statement. We're giving it a condition. And the condition in this particular case would be implied with the double equal sign, meaning that if this condition is equal to this value, then I want you to do something. Or if this condition is not equal to this value, then I want you to do something. So these are our comparative operators when it comes down to strings and variables. So we had the less than, and then we had the greater than. And the same thing would be applied when we were scripting, and we would say if the value is less than, or excuse me, if variable, right, is less than value, but in this case, the value would have to actually be a numerical value. It can't be a text value. The variable could still be a text variable, because typically variables are actually stored like this. Actually, if I really want to do this right, variables are stored in this way, where we have the $sign in front of it, and then that's representing a variable. So if that variable is less than the number 5 or number 4, for example, then I want you to do something. If it's less than or equal to 4, I want you to do something, so on and so forth. So you have, these are the comparative operators that we have. So we had our initial functional operators, which were the ands and the double ampersand. And then we had the greater than symbol that would add something and replace all of the contents of the file, and then the double greater than symbol that would add it to the end of the file. And all of these are known as our functional operators. And then we have the other version of the operators, which would be our comparative operators, which would be the equals or the not equals, or the dash less than, dash greater than, dash less than or equal to, dash greater than or equal to, so on and so forth. Equal to by itself or not equal to. All of these are for numbers, right? So the initial two that we have over here are for text and strings, and then these are for integers and numbers. And that all falls under our comparative operators. Now that I got all of that out of the way and I made sure to include all of that in our operator section, now we can move on to our next section, which has to do with the directory management and really just like navigating the file system and finding files and going back and forth between directories and so on and so forth. So we can now move on to that particular section. All right, now we need to talk about the listing of the contents of any given directory, navigating back and forth between the directories inside of your system, and then just finding out what your location is. So this is different than locating something. We're just trying to find out what our location is in any given system. So this is actually one of the, this is my basic set of operations that I run anytime that I remote login into something, especially during some kind of a pen testing exercise, because sometimes you don't know where you have logged into inside of the file system and you're trying to find where you are inside of the file system. So these are just the first series of commands that I always run when I log into a system, especially, for example, when we're on TryHackMe and we're doing the capture the flag exercises, or we're doing any kind of exercise. I want to know where I am first and foremost. I want to know who I am, and I want to know what is located in this machine. So the very first thing that I always run is who am I? And we've already covered this. So it will give us the name of the user that we're logged in as, okay? The next one would be the host name to find the name of the host that we're logged in as. So these commands we've already covered, and you should know what these things are. So the next thing is print working directory. So this means where am I in this entire file system? And you already see that by the name of this thing that's implied at the very, very end right here. It says that we're in the desktop, right? So that's where I currently am, but the full path is my actual working directory, which means I am in the desktop of the Kali user, and that's inside of the home partition, which is one of the primary partitions that exists in the Linux hierarchy, the Linux file system hierarchy. So this is where we are. That's our current working directory. Now, the next thing is to run ls to list what's inside of that directory. And the greetings file is what we just created. The zoom.desktop shortcut is what I have installed on this particular desktop, so I can access the Zoom recording software easily. And so from here, we can now start to navigate, or we can start to look at a variety of different elements for these particular files. So let's just start from the very, very top of our commands, which is the ls command. Now, ls just by itself lists these items in a horizontal view. If I do ls-l, it'll list them in, I guess, a vertical view. So you can see that instead of it showing this just by itself, and then in the next line it would be this, and then I think an easier way to demonstrate this particular thing is that I will change my directory, go back to the previous directory, which if I now do print working directory, we'll see that it is home at Kali. So that's basically a step upwards in our file system hierarchy. Now, if I do ls, we'll see that we actually have many more directories inside of this location. And if I do ls-l, now I can see the vertical view of this. So you can see how this is actually much more useful and a little bit more user-friendly when we do it in the vertical view. And when we do it this way, we actually have a few extra pieces of data that are now present to us. So these first series of characters represent the permissions that are associated with this thing, as well as what it is. So this very first D that you see right here implies that this portion is actually a directory. And then the same thing for this one. That means the documents is a directory, and all of these other ones, these are all directories right here. This very last piece right here is actually a file and is technically an install file. But if it's a file, then it's just represented by this dash at the very, very beginning. So that's our file. And then everything else that has a D at the beginning is the directories that we have in this particular location. And then all of these other pieces are the permissions that are associated with it. And I'm not going to talk about that right now because we have an entire section dedicated to permissions and assigning permissions, changing permissions, so on and so forth. This piece right here would be the user. This is the group that it belongs to. And then there's the date and time that these things were created, which obviously all of these things were created by on December 1st, because that's when I booted this version of Kali Linux on this particular machine. So now we actually have ls-l that gives us everything in a list format that we kind of see, which is vertical. So the next version of this is to do ls-la, which now gives us a few extra pieces. So LA, as you already know, when you do -a, it gives everything, right? So it shows all of the documents, all of the files, the folders, so on and so forth. And what we have over here, everything that has a dot in front of it, these are all hidden. So when we ran ls by itself, none of these things were showing up because these are all of our hidden files. And this is what's important to understand, is that most likely in every single directory that you deal with, there are going to be some kind of a hidden file. And then these two at the very top right here represent our current directory. So the single dot represents the current directory that we're in, and the double dot represents the one level up. So if we had our current, so let me clear this up a little bit. So if I do my print working directory, the dot represents the Kali portion. So that current directory that I'm in, which means that in that directory, we have all of these items, right? And then the double dot represents that home portion, meaning if I did cd ... like this, it will take me inside of the home directory, as you can see right here. And inside of the home directory, there is now going to be just one user, because this is literally the only user that exists on the system, which is us, which is the Kali user, right? So this is what ls for you does. And then you can do lsl or lsa, and it gives you everything that's available. And in this particular situation, there's literally this is the only directory, and then there's the ... that will take us to the very root directory, and then that represents the current directory that we're in. And then, of course, as everything else that we've dealt with, there is the human readable version of this that if we just added H to it, it supposedly would be the human readable version. Let me actually go into the Kali user to make this a little bit clearer. So we have all of the contents that we already know it exists here. So if I now do ls-lh to make it more human readable, really, there's nothing that has changed here compared to everything else that we had. So ls-la is technically all of that. Actually, so let's do the comparison of two different commands. So we have lsl by itself, which is that, and then you have lslh, which is that. And in this case, what do we have? The only thing that has changed is that the value of this piece right here. So it's 200 megabytes, as you can see. And over here, it's just this massive series of numbers that represent 200 megabytes, because this is being counted in bytes, and there's no megabytes or anything like that, but everything else is exactly the same. So the human readable format of this, for the most part, based on what we've noticed so far, is that it just condenses these size values and actually adds a gigabyte or a megabyte at the end of it to make it human friendly, quote unquote, right? So that's what we have, and that's basically it for the ls command. And then, of course, as everything else, if I do man ls, it will give me the manual for ls, and it'll show all the various options that you can run with it, which is a massive amount of options. The ones that I shared with you are the ones that are most relevant, and you need to know these things. So that's very, very important for you to understand. So we can now move on to the next one, which is change directory. The cd command stands for change directory. And if we know that we're already in the home Kali directory, and I know that inside of the home Kali directory, I have this entire list of directories. And let's say I want to go inside of my documents. So I would just do cd and I would do documents, and it will take me inside of the documents directory. And this is a sample machine, so there's literally nothing inside of my documents directory. I think there might be something inside of the downloads folder, so I can do cd dot dot to go back up one location, which will take me back inside of the home of this particular user. So now we can go into downloads and let's see if there's anything there. There's nothing in downloads either. Man, I literally have nothing on this particular location. I think so. If we actually go to the desktop, I know for a fact that there's stuff on the desktop. So there you go. Now I have some content, some pieces that are on our desktop directory. So CD basically stands for change directory. Now what you can do is you can navigate to a few key directories. So I'm going to show you what those key directories are. So this squiggly line that you see right here stands for the absolute root of the system. So if I do that squiggly line, cd to that, it'll take me to this. And I notice how the beginning of the command line has now changed to that. And if I ls inside of this, it's going to give me my root of this particular user, okay? This is very different than this root. So the / root is also now changing the start of our command line. And the contents of this root are very, very different. These are all of the system's partitions. So we have the actual root partition for the root user. We have the mount partition. We have the media partition. We have the home folder, which has the users in it as well as everything else in it. We have our etc. folder that has all of our configuration files. We have the binaries that are located here. We have the system binaries. So this is the base root of the system in general, and that's represented by the /. If you want the root of the user that you're in, that's represented by this squiggly line, and then when you do that ls, it'll bring you everything that belongs to that particular user. So those are our two main directories that we can change to back and forth. Now, there's something else that you can do with the cd command is that you can go to a specific folder inside of a given location. So for example, so if we went to the root, and I know inside of the root there is the home directory, and inside of the home directory, I know that there is the Kali user, and then I can cd to Kali, and now I'm in this location, home Kali. But home Kali is what? The root first, and then home, and then Kali. So if I know that that's the hierarchy of my path right there, I can go back to my root here, and I can actually change to home Kali instead of doing those individual commands. And then now you can see that I am back inside of the print working directory. So let's do that one more time. We're going to do cd / print working directory, and you can see that it just says that you're inside of the root, which is represented by that single /. And then we're going to do cd home Kali, and then I can even go further and say desktop, right? Because I know that the Kali user has a desktop, and now I am inside of the desktop folder directory of that particular user. So we went from this to this location in one command, okay? So the idea here is that you can go to any path by simply changing directory as long as you know the exact breakdown of that path. It is case sensitive, so the desktop actually has to be a capital D, so on and so forth. So all of these things are very, very important, but you can go back and forth between any given directory so long as you know what the path of that directory is. And that's basically it for everything that we need to know for cd. It is the change directory command. And of course, if you wanted to look at the manual for it, you can, oh, there is no manual entry for cd. That's interesting. So there is no manual entry for cd. So maybe we can do cd -- help. There's no help menu for cd either. So aren't you lucky that you have me here at the very least that I can teach you all this stuff. So cd stands for change directory. It's a very simple command. You don't really need to know the full scope of all of the variations to it. You just know that it stands for clear, or excuse me, not stands for clear, it stands for change directory, and then you can do cd, go to one level up, you can do cd, and you can go to the documents folder, for example, and you can just change directories as needed based on your navigation for this. So there is no documents, I think, because I already put the /, so I don't need to do the /. I could just do documents without the /. So that's it. So that's what we have for the cd command. All right, now that we know how to navigate between the directories, we need to learn how to create and remove directories. And these are also a very simple series of commands. These are just very functional. These are very useful. So the first one that we need to talk about is the make directory command. And then the next one is going to be the remove directory command. So let's not get ahead of ourselves. So make directory is, as the name implies, to make a directory. So first, let me go to a location where I want to create directories. So I'll just go into my, let's say, we'll go into our documents folder. And inside of our documents folder, we can start creating some directories. As we can see, there's nothing in here. Even if I run lsla, we can see that this is a completely empty directory. So we can do mkdir. So mkdir stands for make directory. And in this case, you can add essentially the name of the directory that you want to make. So I'll just do files, for example. It will be make directory files. And I'll do ls. Now we have a directory in here called files. And then I can go inside of that directory, and there's nothing in here. So in this particular location, we can do make another directory, and we'll call that letters. So we'll have the letters directory that is inside of the files directory, and I can go inside of the letters directory. And now I have a full string. So you can see right here, we have a full path that is on top of our root for our specific user, which is Kali. So if I do print working directory, you can see the full path here, right? So we've now created multiple directories. So we have home, and then there's Kali, and then for the Kali user, there is the documents folder that belongs to that user. Then we created files, and then we created the letters directory, and now we are sitting inside of the letters directory. So it's that simple to actually create a directory. It's literally mkdir, and that's basically it, right? So what I can do now, I can go back to the documents folder by doing cd .. and I'll do a / and another .. So the first .. will take me from the letters directory to the files directory, and then the second one will take me from files to documents. So instead of doing .. enter and then do cd .. again, I can now just do .. and it'll take me into my documents folder, as you can see right here, and I can ls here, and now we'll see that we have the files directory in here. So it's a very, very easy series of commands that you can do, that you can kind of really go nuts with, because you can just essentially do any kind of file creation, folder creation, and especially when you're even dealing with creating partitions to mount an external drive to, sometimes you'll need to do something like sudo make directory and then create something in the mount partition and then name it whatever you want to name it, and then you can actually use that specific directory for your swap partition or for the mount point for the external drive, so on and so forth. Again, I'm kind of getting ahead of myself, but the make directory command is actually very, very useful when it comes down to file system management and even dealing with partitions. So it's a very, very useful command. Now, again, as anything else is concerned, let's see if we can actually find a manual. And we can actually find a manual for make directory. And so you have the parents, meaning there's no error if there's existing parents, make a parent directory as needed with their file modes, so on and so forth. And then you have the -v, which is verbose. This is typically available for almost everything. And it just makes, it gives you a displayed message on the screen saying that something has actually been done. And then you have the SE Linux security context of each. So we're not going to get to that point because that's completely for a separate section, which is the security section. But SE Linux is very important in security. And then you have the -Z that sets the security context of each created directory to the default type for SE Linux. And then you have the help, of course, and then you have the version, so on and so forth. So these are all the stuff that are available for the make directory. So if I actually wanted to, so let's go to our, what it was, we had letters, right? So was it letters? No, files. So files. If I went into the files directory and then I went into the letters directory, and then for that, let's see if we can actually create another one. So we'll make files letters, and then we'll do make directory notes, And then I want to do -v just so we have the output. So we do that. And now it says create a directory called notes. So that's basically what verbose does for you, is that it creates a note. It just displays a note onto the screen that says, hey, I did this job that you told me to do. And then if there were any errors, it will also print those errors and all of the steps that happened between the command and those errors, and displays everything for you onto the screen in real time. So that's what verbose does with every single command that you run. That's what verbose does. It just displays everything onto the terminal for you as it's working. So now that we have make directory, and now we've also created a notes directory. So if I go into the notes directory, we'll see how this path just gets longer and longer here. So now that we have this, we can now talk about removing the directories, because now I've created way too many directories. So let's go and talk about remove directory. As you have probably guessed, the remove directory removes a directory. It's very, very simple. So we've made a bunch of directories. Now we got to delete some of these directories because I don't like having a bunch of empty directories. So I can go back into my documents folder, and essentially I know that I have this one main directory, which is the files directory, and I want to remove this. Now, typically, from what I understand, if I do remove directory without any extra options and just give it the files command right here, because technically there are some other directories inside of files, I should get an error saying that there's contents inside of this. Do you actually want to delete this? Because you're going to be deleting the stuff that's inside of it as well. So we're going to try that. And it says fail to remove. The directory is not empty. So this is where we would go into our manual for remove directory and see if there's something. There we go. Ignore fail on non-empty. So ignore each failure to remove a non-empty directory. So that would be the full command that we would have to give this to ignore the fact that this particular directory is not empty. So I'm going to actually copy this because this is literally too long of a thing for me to try to remember. So that's going to be the option that I'm going to attach to it. And then everything else is pretty much the same. So verbose and all these things are exactly the same. This is a very simple command, so it doesn't require a bunch of different extra options to it. So what we're going to do is we're going to quit, and then we're going to do, again, rmdir, and I'm going to do files. And then what I'm going to do is I'm going to add this option at the end of it, which is to ignore fail on non-empty. Press enter. I forgot to add verbose so that it will tell us that it did it. But if I run ls, we'll see that, oh, actually files is still there. So it did not work. So let's see if we can go into files and see, yep, that is also still there. So maybe we need to do remove dir and then do ignore on non-empty before we give it the files, and then fail to remove files because there's no such file or directory. Oh, so it did work. It actually did. Oh, excuse me. Whoops. I was in the wrong location. So let's go here. There's the files directory. So we're now going to run this command and then see if that works. And then let's see. It did not work. So I guess the ignore fail on non-empty does not work. So what I have to do now is I have to go and delete these things one by one. So what's fun is that if we actually know that inside of the files there's something called letters, and then inside of letters there's something called notes, I can just, from my current location that I'm at, I can remove those altogether. So I can actually go into files, and then from there we can go, right, I think is that files? Yeah, it is files. So we can do remove dir, and then we'll do files /letters /notes, and I can delete that. And so that should be fine, right? So then if I actually try to cd into files, letters, notes, there should be no such file or directory because we literally just deleted it. Then I can do remove dir and then do files /letters, deleting the letters directory. And actually I could have even done this, which would have been very, very exciting. And I would have been able to combine a bunch of commands. So you know what? Here's what I'm going to do in this particular case. I'm going to make a directory and we're going to call it files letters. So we're going to recreate the files letters directory, and then we're going to make another one, files letters notes. So I'm just going to backtrack and do all of that stuff. So now what I want to do is I want to combine a series of commands for removing. So I will do files letters notes, and then I will combine that with remove dir files letters, and then I'm going to combine that with remove dir files. So now I have 3 commands that are running, and then we're going to do the -v at the very end of this to make it verbose. Press enter, removing directory files. So that should have done everything. So I think it's actually did everything. I should have done -v at the end of all of this stuff. So now there should no longer be a files directory, which means that this actually worked because it's no longer empty, right? So technically this was inside of this. So that was deleted first, then this was deleted, and then finally this directory was deleted at the end. And now we are back to where we were in our original file system, which is we just have an empty documents folder. So that's basically it for removing directories and making directories, which makes this probably the shortest section of our entire series for creating and removing directories. So now what we can do is we can go into creating and removing files and copying files and moving files and deleting files, so on and so forth. So we can go into file management. We did directory management. Now we can go into file management. All right, now we know how to navigate and create and remove directories. So what we're going to do is we're going to create, navigate, manipulate, copy, move, delete files. So what I wanted to do, I'm glad actually that we deleted all of the directories that we had in the previous section, because now it allows us to create files based on paths. So one of the things that we can just basically do is use the command touch. So touch is a very simple command that creates a file. It'll create an empty file, and you can even assign the extension to the file. So if I wanted to do file.txt, it would create a text file. If I wanted to do CSV, it will create a CSV file. If I did py, it would create a Python file. If I did sh, it'll create a shell file, a shell script. So you can assign the extension to essentially any kind of file that you want to create when you use the touch command. So what this does is that in the current directory that I'm in, so this would be our documents folder. In this current directory, it's going to create a file. So the first thing that I can do is I can just run touch, and then I can just do file.txt, and it'll create a file, and I can do ls, and we'll see that we actually have this file inside of our current location. So we can assume that since that's there, we can probably duplicate it, right? So this is very important. Since there's nothing inside of this file, then I need to actually put something inside of the file. So we can just do now this whole thing that we had before. Who is this? Who are you? Would end up being the very first entry of that file.txt. So now we have that, and then we can press enter. And now the empty file that we had before, because all we did was we just created a file, I can now do file.txt, and we can see that that file actually has something inside of it. So now what I can do is I can go ahead and copy this file into another location, or copy it even in the same location that I have. But what I need to do, if it's going to be in the same location, so if I did copy file.txt, I need to give it the new file name. So it would have to be file2.txt, for example. And I'll just do that, press enter, and now I have two files in my current directory. And if I do a cat file2.txt, it should actually have the same exact content as the first file. So very simple. This is how you copy a file in a given location. Now, what we're going to do is we're going to cover the move command. So we already know how to make a directory. So I'll just create a new directory again called files. So now we have the files directory in our current location. And I want to move the file2 into files directory. And now I have, so if I actually go into the files directory and list the contents of it, now we can see that file2 was moved inside of the files directory. And it's very, very simple to be able to do something like this. So what we can do is a very interesting command here is that we can actually use copy, and we can take the first file, which was our original file, and we can assign it to a new location, which would be the files directory. And then from there, let me make sure that this is spelled right. So from here, I can actually give it another file name just to confirm that we've done this. So now what we're going to do is we're going to copy this inside of the files folder and copy it as the files3.txt. And now if I go into the files folder and it listed, and we can see that the third copy is now inside of this as well. So you can actually copy something inside of a directory as long as you have that path, and as long as this files directory has already been created. So if I actually try to copy this file .txt inside of the letters directory, because there is no letters directory in my current directory. And if I try to do that and do file4.txt, then it says that you can't do that because there is no such a file or directory for letters. But if I created a directory, for example, if I created letters and not the letters, so let's say, well, hold on, I'm confused as to what I have in here. So I have ls, because we're inside of the files directory. There is actually no file.txt. That was the issue that this command was giving me because I'm in the wrong location. So I need to go back here and I need to clear this up. So now this is what we have. We have the original file and then we have the files directory. So if I went and created a copy command and I did file.txt and I wanted to move it inside of the notes, for example, and do a file4.txt, it's going to say that you can't because there is no such file or directory as the notes directory because that doesn't exist. So you have to create this directory first before you can transfer anything into it. This is very important to understand. So this is the overall concept, is that you can create a file with touch, you can copy the file with CP, and then you can move the file with MV. Now, what's interesting is that if you needed to rename a file, so I have file.txt here. So if I went inside of my files folder and I have these two files here and I want to rename a file, for example, I can do mv. So I can use the same move command to rename a file. And I can mv move the file2.txt and just turn it into file.txt. And now if I list the contents, we can see that we have the file3 and then file2 was now changed to file.txt. That's been the new name for it. So you can actually use the mv command to rename a file. Okay, so we have touched on touch. So we've created the new files with touch. We've copied files using CP, and then we have moved files with MV, and then we can now cover a few other options with these various locations. So for example, if I wanted to recursively copy the contents of any given directory, meaning that I want to copy the contents of this files folder. I want to take all of that and copy it to a new directory. I will need to do CP and give it the -R flag, the -R option for recursive, and it'll take everything from files, and I'm going to create a new directory here, which is files2. So let's see if that'll actually work. And I think it did. So there you go. So now we actually have a files2 directory as well. So if we go inside of files2, we should have those same exact files. So this is actually kind of a spin-off on the make directory. So we are technically making a directory using the CP command, but what we're doing is that we're copying all of the contents of that original directory and we're putting it inside of the new directory. So you can actually create directories with the CP command as well, as long as you do the -R option to recursively copy all of the contents of that initial folder and then put it inside of the new folder that you're creating. So now that we've done all of this, now what we need to do is do a little bit of house cleaning here, and we need to clean up all of the stuff that we've created. So previously we wanted to remove a directory, right? And we saw that remove dir did not work because the directory was not empty. So there has to be a better way to do it, because you don't want to sit there all day and just remove all of the contents of a directory and then to be able to remove the directory. There has to be a better way to do it. And thankfully there actually is. So the very first one that we're going to do, since we're inside of files2, what we're going to do is we're going to go inside of our main documents folder, which has all of these things. So the first thing I just want to do is I want to remove this file.txt. So there's that. That's been removed. And now I have these two directories that I need to remove. And the way that I can do that is I can do rm-r, so the same thing as cp-r, meaning recursively, right? So you're going to recursively copy a file with cp-r. So what you can do is recursively remove a directory and all of its contents by doing -R. So you can do rm-r files, and then what we'll do is we'll do the -v to give us a verbose output when it's actually done that, and then we'll combine that with the rm-r files2 to remove the second directory as well. Now we're going to press enter, and now it says everything has been removed. How amazing is that? So it's removed the contents of files folder, which is files.txt 3.txt, file.txt, and then it removed the directory, and then it removed the contents of the second folder, and then it removed the folder itself. So now if I run ls, we have nothing inside of our documents folder, which is exactly how we started. So very, very useful series of commands. So you can't recursively remove a directory using rmdir, remove dir. You can't do that, but you can do it with rm and then give it the -r flag, which will recursively remove all of the contents of any given directory and then the folders inside of it. So literally it could remove, if there were multiple folders inside of it, it would remove all of those folders. It would remove all of the files inside of those folders. And then ultimately it would remove the folder itself. So very, very useful tool. So obviously there has to be something better than manually removing all of those things. So that is what we have here. So we had touch, we did cp, we did mv, and then we did rm. And these were the series of commands for basic file creation, copying, moving, and deleting of files. And there are other ways that you can interact with files and manipulate files, and we will definitely get into that in future sections. So these were just some of the most basic, and any decent Linux administrator has to know these things. So that is available for you now, and I really hope that you learn them, because those are honestly one of the most basic. It's as simple as running like pwd. Pwd is such a basic command. ls is such a basic command. So you need to learn how to run these various commands. cd, for example, all of these things are such basic commands, and touch and cp and mv and rm, all of these things are very, very basic. These are the absolute basics. So as we move forward with this training series, what we're going to be doing is we're going to be extrapolating on all of these commands, and you're going to get more additions that will just compound on these commands, and you'll find a variety of different ways that you can use these commands. So it's going to be very, very cool and very useful. The further that we go along, the more advanced that we go, it's just going to become cooler and cooler, because you're going to start doing some really cool things, some really neat things. So that is it for our basic file creation, copying, moving, and deleting. So now what we're going to do is we're going to learn how to search for files and folders. So that should be fun. Let's get into it. All right, now it is time to learn how to search for files. And the way that we're going to do that, first and foremost, is using the find command. So it's very intuitive. This is actually one of my favorite commands. And there's various options that you can run to combine with find. So the very, very first one would be to just give a location that you want to search for, which, let's say, it would be the root location. And then what I know for a fact is that, so okay, on our situation, we have the desktop, and then we have inside of the desktop, we have this one greetings.txt. So let's say I know that I'm searching for greetings.txt, and I know that it's sitting inside of the desktop folder. So hopefully, if I go back to my original location, which is my root, like right here, and even if am not here, let's say I'm inside of a different location in the computer, if I just do find and I give it first the location, which is going to be the root folder, which is represented by that /, as we've already established. So now we want the name to be the option that we're going to search for. And then we're going to give it the actual name of the thing that we're searching for. So greetings.txt. Now I'm going to give you a little cheat sheet over here. So any error message that shows up, so I'll just run this, and then you can see there's a bunch of permission denied stuff that comes onto the screen, which takes up a lot of the output of the results. So now you have to sort through all of this to try to find what you're looking for. So instead of dealing with this, we're going to clear the screen one more time, and then we're going to run this. And what we're going to do is we're going to send the to dev null, okay? And I think I have to actually do a /dev and then /null like that. So what this does is that it'll send all of the error messages that printed into that null folder inside of the dev partition, which basically gets deleted immediately. So none of these things are going to be stored. It just makes our output a little bit cleaner, so that there you go. Now you just get that one result that shows up. And then look, now you only see the locations where this file actually exists, the various paths that this file exists on. And you don't have to worry about all of the freaking error messages that were output onto the screen. So when you use the find command, anytime that you use the find command, you want to forward all of your error messages doing the to and then forwarding them to the dev null folder so that they just get rid of it from the screen, from the display. And then now you only see the actual output that's relevant to you, which is the locations of what you're looking for. So this is one way that you can find something, is by its name. And it always requires that you give it a path to search in. Okay, so this is one of the things that is absolutely a requirement. So when you do find, you need to give it some kind of a path as one of the arguments. And then the next argument that you would give it is the thing that you're looking for. So in this particular case, it would be the name greetings.txt. Now, this actually supports regular expressions. So if I wanted to do find name, and then instead of giving it greetings.txt, let's say I want to find all of the txt files, which is probably going to be a lot of files, even if I send them to the dev null folder. So we'll just do that. So the asterisk is the wildcard character that basically says anything that ends with the .txt extension, I just want you to find for me. So let's see what they're, yeah, this is going to be a lot of results. Even when we sent all of the errors to, I'm just going to stop this from running. Even when we sent all of the errors to our dev null folder, we still get a massive amount of output because there's a lot of freaking text files inside of the system, as is there inside of all the other systems. Because literally just for the Python 3 distribution packages, there's so many freaking text files that exist. So that's just a way to display that you can do wildcard characters in the search parameters that you're inputting into this, because it does support wildcard characters and regular expressions, so on and so forth. So this is the first argument that we're going to work with, which is the name argument. Now there's something else that you can use. So there's a variety of different ways that we can search for items. So the first one was by the name, okay? The next one is going to be by the type. So what you can do is you can look for a type D, meaning type directory, or type F, meaning type file. So let's say I want to look for all of the files, and then I have to give it a different argument as well, because again, if I just do type F and then press enter, even if I send it to the dev null folder, if I just do type F and press enter, there's going to be so much output that's going to come onto the screen. So what's going to happen is that we need to give it a second argument, which in this case, we can say, for example, the size of the file, and it's going to be greater than 1 megabyte. So that's what that represents right here. And then I'm going to do to dev null to send all of my error messages away. And now we're going to search for all files that are greater than 1 megabyte in size. So we do that. There's a bunch of different files. So we're just going to press Control C to clear that out. But you can search for files by size, right? So that's another thing that you can do in this particular case. So we have the path to search for, which was our original root folder, and then the type of the file, and then the size, so on and so forth. And then you can just kind of expand on this even more, right? So that's one of the big things that's available for the find option, because there are a lot of different ways that we can actually search for this. And the big one right here is the permission. So this is one of the big things that is very, very important for penetration testing. So let's say you get secure shell access to a given computer, and you want to find all of the files that have, let's say, read, write, and execute permissions, right? So how do you find those files or folders, which is very, very important. This is again done with the find command, and you would do the /, but again, I could also do / home and then Kali and then desktop, for example, but that would limit my search to that individual desktop folder, which pretty much nothing exists inside of that. So what I'm going to do is just give it the find /, and then we're going to continue on with the rest of our search arguments, which in this case would be the perm. So perm stands for permission. And then when you assign the perm argument, you can give it either numerical permission values, or you can give it the, the sign itself, not numerical, but figurative. I forget the technical term, but essentially when you actually give it the character signs, the permission characters. So in this case, it could be a permission of 777, and the first seven represents the owner of the file or the folder. The second one represents the group, and then the third one represents the others category. So the owner that owns this file, the group that can get access to this file, and then everybody else in every other category, it displays all of those for you. So if you say that you have a level 7 permission, that means you can read, you can write, and you can execute everything that is inside of that folder or that individual file itself. Read stands for the value of 4, write stands for the value of 2, and execute stands for the value of 1. So if you have 7, that means it's read, write, and execute. If there was a value of 5, for example, that means it was only read and execute. So 755, for example, means that the owner can do everything, the group can only read and execute, and everybody else can also read and execute. That's basically what those numerical values stand for. So if I do perm 777, that means I'm looking for something that everybody can read, write, and execute. And then I would have to do to dev null to make sure all the error messages are gone, and you press enter. And these are all of the files. We're just going to close that out. These are all of the files and folders that can be written, read, read, written, and executed by everybody. So that's one way that you can search for it, is by doing perm and then the numerical value. And another way that you can search for it is by doing perm and then the actual symbol value, which in this case, let's say we're looking for the user to have execute permissions, and then we just press that, and then these are all the ones that the user can execute. We gotta stop that as well, because it's just too many results. Because this is a live boot of Kali Linux. I am the only user, which means that I am the root user, the administrator user on this particular instance of Kali Linux, which means literally everything on this particular distribution on this machine, I have permission to read, write, and execute. So being the root user, I have access to everything, which means the output is just going to be massive. So that's what we have for finding. Now, as always, we can just do manual find, so man find, and it'll give you all of the various ways that you can search for something using the find command. What I just shared with you is technically just the kind of like the tip of the iceberg in this particular case, because there are so many different ways that you can search for something. So you can have the max depth level, you can have the minimum depth level, you can have the mount point, so don't descend directories on other file systems. You can have no leaf, meaning don't optimize by assuming that directories contain 2 or fewer subdirectories. Then they're hard links, so leaf references the forest and the tree, and then you have the version, and then so on and so forth. There's so many different options that comes with the find command, and they're all very, very useful just depending on what your use case is. So for example, there's another one that's actually very useful when you're doing system administration and you're trying to do incident response, investigation, so on and so forth. And that is actually the M time, which means modified time. So if you're looking for something that has been modified recently, for example, you would do modified M time, let's say, I'll do 7 just for the hell of it, meaning that you want to display something. Oh, I don't know why I'm doing man M time. I need to do find M time and then do 7. That's what I'm trying to do here. And so what it's going to look for is that inside of the root directory, it's going to look for anything that has been modified over the last 7 days, which is again going to be a massive list of stuff. So you can actually find things that have been modified over a span of time to kind of narrow down the files or the folders that have been modified. So for example, to make this a little bit more, to kind of nail it home a little bit, there's a location that has all of our log files. So it's the var log directory. Inside of the var log directory, if I do M time and then do the number 7, that means I'm actually looking for something inside of my log folder that has been modified over the last 7 days, and press that. Most of these things don't have permission, right? Because I haven't ran it as a sudo user. If I ran this as a sudo user, there would be no permission denied to any of these things because I am the only administrator and I'm the only user. But we can see that the log journal file was modified over the last 7 days, the history log, the termination log, the live boot log, the boot log, all of these things have actually been modified over the last 7 days. So this is very important for us to understand. So if there was something that we were trying to track down in an incident response investigation, we would actually be looking at these various log files because they're very, very important to kind of narrow down what the actual activity was on this particular system. And then you can even narrow it down to the last 1 day, for example. There's a lot of different arguments that can be provided to the modification time argument, and then you can try to narrow down whatever the results are that you're looking for. So you can find items in a variety of locations through a variety of arguments, including their name, their permission, their last time that it was modified, and really kind of anything else that you can think of, any other variable that you can think of, you can try to find those items using the find command. So it's a very, very, very useful command, and I hope that you also kind of get comfortable with it because apart from a certification exam, this is actually another command that's very useful on a day-to-day basis as a Linux administrator. So now we can move on to the locate command, which is kind of like the counterpart of the find command. Now, the locate command doesn't have as many requirements as the find command does. So, for example, we don't need to give it a path to search for. So what I can do now in this case, I can actually just give it the name of the file. So for example, I'll do greetings.txt and press enter. Now in this case, it actually can't find it. So let me see, maybe I don't need to give it the individual. No, it still can't find it. So that's actually kind of useless in this case because I know that there's a greetings.txt file that exists. So maybe we can do, let's see, if we do the case insensitive option and give it the greetings.txt, still can't find it. So let's pull up the manual for locate and see if we can find anything. And then if I can't find anything over here, then I'll just go to our very handy dandy AI assistant and see if there's a way that we should be running this. Okay, so there we go. I think the issue was that I didn't have an updated database for my locate command. So the command that I ran was sudo updated b. So update db, update database is basically what that stands for. And first I ran that and it updated the database for my locate command. And then when I ran the locate greetings, it was actually able to find the greetings.txt file. So the command itself should actually work because that's literally, it's one of the simplest commands that exists on Linux. And the main reason, in a lot of cases, the main reason why something won't work, especially if it's a command that actually is installed on your machine, the main reason why it won't work is because there is some kind of an update that's missing. And that's exactly what was going on in this particular situation. So first I had to update the database for locate, and we did that with sudo update db. And then from there, I was able to run the locate command for the greetings.txt file, and I was able to find it. So this is one of the simpler commands that is available, and there's a lot of different ways that you can run this as well, as you saw from the manual page that we had. And I also just consulted with our Microsoft Copilot AI just to confirm, and that was indeed the case. So I needed to make sure that was the update because there was nothing wrong with the syntax and there was nothing wrong with the way that we were running it. So there's another thing that we can run with locate, which is the regular expressions patterns that exist. So, for example, I can actually do the asterisks as well, and then look for log files, for example. And then I know that this is just going to be a massive series of logs that are going to come up, but that's basically it, right? So I just looked for anything that had the extension of log, and then we can see that we have all of these log files that show up, and they're log files that are inherent and intuitive or embedded. They come as a part of the Linux system. And then there are log files that belong to individual services like Apache, for example. So there's a lot of different ways that you can use either find or locate to search for a variety of items as long as you know just the basics of regular expressions. For example, the fact that an asterisk represents a wildcard character, and with that asterisk, there's going to be anything that will come in its place as long as it ends with the .log extension. So that was it for the locate command. I do request that you check out the manual for locate if you're trying to find something, or if you're trying to learn all the different ways that you can run this specific command. So it's a very, very useful command, and find and locate both can be used interchangeably to find or locate things on your machine. So if you ever run across it in a question, or if you see a sample command that includes find or locate, now you know what they actually do and how to break down the various elements of these two very useful commands. So let us now move on to creating links. All right, to create a link, first we need to understand what links actually are and what is the difference between a hard link and a symbolic link or a soft link. And we did cover this inside of the lecture portion, so I'm not going to go too deep into it. But because of the fact that the commands are so simple, I do want to just kind of do a review real quick for you, just so you understand what the difference is. So a hard link is a direct reference to something. So essentially, you are making an exact copy of the thing. It'll have the same inode number. There will be no redirection, meaning because of the fact that they're pointing directly to the same data. If the original file was deleted, the hard link will still point to the same data because essentially you made a copy of it. That's how I like to think about hard links. You're making an actual copy of the original source item, and it just needs to be on the same file system. And they're very useful because if you wanted to save disk space and create backups without if you don't have to worry about if the original file is removed or deleted, this is what a hard link would be for. And you can technically use a copy command to copy something and to make another version of it, essentially, without doing a soft reference to it or a shortcut to it, right? So that's what a hard link is. You're just making an exact duplicate copy of something. The symbolic soft link is a shortcut. It's literally the shortcut to that original item. So think of it as a shortcut on your desktop that points to an application. And if you deleted the application from your list of installs or list of applications, that shortcut on your desktop won't work anymore because it's actually just pointing to the original application. It's being a redirection, right? So if the original file is deleted, the symbolic link becomes a broken link, and then it no longer exists because the path of the original file doesn't exist, or the path of the original software doesn't exist, so it's no longer useful, right? So symbolic links are useful for creating shortcuts, for example, directories and files that may be moved to a different file system. So you can actually do this with files as well as directories if you don't want to copy the contents of it and take up more space on your disk. You can just create a symbolic link or a soft link that'll point to that directory, and you can still access the original files so long as the original files aren't deleted. So now, how do you do it? And you do that simply with the ln command. So what we're going to do is we're going to work with that original desktop document, which was our greetings document. So just to remind you from the early section, we just had this random series of strings because I wanted to demonstrate how to use the functional operators that we had. And so this is the greetings document, okay? So what we're going to do is we're going to create a hard link first of that greetings document. So what you do is you do ln, you give it the source file, the source location. It could be a folder as well. You give it the original, which is the greetings.txt, and then you give it the link greetings.txt, and that'll end up being the hard link document. And so if I run my ls command, you'll see that there's actually a copy of the greetings file. And so if I do cat greetings.txt, I'll have that. If I do cat link greetings.txt, I'll also have that. So now keep this in mind. Okay, so what we're going to do here is we're going to remove greetings.txt. So now that doesn't exist anymore. And if I try to cat link greetings.txt, it'll still work because I created a hard link. I created an actual duplicate copy of this thing. Okay, so just keep this in mind. So Now, what we're going to do is we're going to create a soft link of that link greetings.txt. So we will do ln-s, which will be the soft link or symbolic link of link greetings.txt. And then what we're going to do is we're going to do soft link.txt. Press enter. So now we have the soft link. Notice how it's not the same color anymore. It's actually a different color because now this is a shortcut that exists on our desktop. So if I go ahead and remove the link greetings.txt, I still have the soft link, but all of a sudden it doesn't work anymore. And if I try to cat the soft link.txt, let's spell that right, no such file or directory because the original file was actually deleted, right? So that's what the difference is between the hard link and the symbolic link. The hard link is an actual copy that you're making of the original document or software or folder or anything of the sort. And the symbolic link, the soft link, is simply just making a shortcut to that content. So if you lose that original piece of information, if you lose that original content, then what happens is that the shortcut no longer works, as you can see on our screen over here. So what I'm going to do now is I'm just going to remove this softlink.txt because it is now useless and there's no other purpose that it serves. And so that's it. That's all we have for the ln command to create links. So obviously, if you do a manual of this, you can actually see the manual of the ln command, and you can make a backup of each existing destination file. You can do the -b, very much like backup, but you don't have to have the argument, which is in this case, there's a control argument that is fed into backup. And then you have the -d and the -f, which represent directories or folders. So it does have to be a -F in this case. If you do a -f, it's going to force it, meaning it's going to remove the existing destination files by force. There's the interactive version. So to prompt whether to remove destinations, it's just going to give you a prompt of whether or not you want to do something instead of just running it by providing all of the arguments yourself. You have the -L. Yeah, so I'm not going to go through all of these options. There's a long series of options. But essentially what you need to know is that the ln command is going to make links between files. And if you have ln with the -s option, you are making a symbolic link and not a hard link. So that's very important. So if you see a sample ln command and it actually has the -s option, and sometimes what they'll do is they'll do -s and then they'll do -r inside of it. So they'll do -sr. So you'll see that there's two options attached to each other. And if you see that, then you need to know that at the very least, if there's an s, a lowercase s, that's been included in the series of arguments for the ln command, that means you're creating a symbolic link, which means you're creating a shortcut. And then as long as the lowercase s is not included, that means you're making a hard link, which essentially means you're making a copy of the original source asset. And that's basically it. So as long as you understand the variation of those two pieces, then everything else kind of is just filler that adds to the functionality of it. But the main difference is that you're making either hard links with the ln command or you're making soft links with the ln command, also known as making symbolic links with the ln command. And that is it that we got for the ln command, and actually everything that we got for the creating links section.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, we have now arrived at our text processing and editing portion, and the first subsection is to view the file contents. So one of the very first commands that we've actually ran multiple times by now is the cat command, the concatenation command. And the cat command essentially displays the content of anything onto your screen for you. So let's go ahead and create another file. And in this particular case, I'm just going to echo just a random series of text and letters. So this will be the message, and we're going to send it into our message.txt. And now we have message.txt on our screen or in our particular desktop location. So I can now do message.txt, and now we can concatenate it and display it onto the screen. So that's what concatenate or cat does. And you're going to be using this a lot because you don't want to necessarily open up the file itself with a text editor. You just want to see what's inside of it real quick. So what you can do is you can actually concatenate multiple files onto the screen. So one of them, for example, so let's create another one. We'll create, this is another message, and this is going to go into message2.txt. And then now we have two message files over here. So what we can do is we can do cat message.txt, and then you can do message2.txt. And now you can display both of these onto the screen. So you can actually combine the cat command and add multiple messages for displaying onto your screen, or multiple text files, or maybe even multiple log files, so on and so forth. Log files are typically really massive, so I wouldn't recommend displaying multiple files onto the screen, especially when you're dealing with logs or something like that. But if it's a text file in this particular case, or if you just want to kind of see what the combination of these various files might look like, there's a variety of different reasons why you would combine the output of two text files. But this is a very simple usage that you can have of the cat command. You could display one file, you can display multiple files, and then if you want to see what the actual number of the file are. So that's a really bad sentence. If you want to see what the number of lines are inside of the file, that would be done with the n command. So if I do n and then I do message.txt, we'll see that there's literally only one line in this. So if there were multiple lines, then we would be able to see those multiple lines. So let me actually do that real quick. So we'll do this real quick, line 2. And then we'll do this to the message.txt, and then we're going to echo line 3, and then we're going to also add that to message.txt, and now we should technically have 3 lines. So if I do a cat message.txt, now we have 3 lines of text that belongs inside of this various or inside of this specific text file. So the cat n command, the n option, will actually display the number of lines that exist on something, because a lot of times you need to know what line a specific portion of the content exists on so that you can refer to it in a script, for example, or if you just want to tell a different command where to look for something, or if you want to tell somebody, like a human being, that it's on line such and such of this particular document, you can go ahead and outline it that way, especially if it's just a regular text file. So if it's a regular text file, and again, I'm getting ahead of myself. So if I open this text file with Nano, which is a basic text editor, you can see that there are no lines or numerical values to each of these lines. So if this is a really long file, sometimes you just don't know where something exists and you need to be able to find it. And the way that you can do that is by using the n option, so the -n option with the cat command. And as always, we can just do manual, so man cat, and then we'll be able to see the various options that are available for this very useful command. So as we already used, the n command will number all the output lines. The S command will suppress any repeated empty output lines, and so on and so forth. So there's a lot of good, useful information over here. And we can kind of move on to the next piece, because you don't need to know too much about the various options. You just need to know that cat by itself will display the contents of any given file onto your screen. The next series of commands would be the less and more commands. And the less and more commands, as the names imply, essentially just display certain portions or certain views of the same file. They just make it a little bit easier to read. So for example, to be able to display this a little bit easier, what I'm going to do is I'm going to go into our var log location. And here we have a bunch of different types of logs. And so log files are typically really big. So let's see if we do for example, the dpackage log. So dpkg.log. If I display this, we can see that there's a bunch of line items over here. and it's a fairly large file, and there's a lot of data that's available inside of this file. And when we get to the very top, actually, we were able to get, but it's a lot of files, right? Or it's a lot of line items, right? So to be able to kind of make sense of this a little bit, what we can do is we can use the less command. So the less command will be done using, or it'll essentially be the same exact thing. So dpkg.log. But what it's going to do is now you can see kind of at the bottom right here that it's stopped. And what I can do is I can scroll up and down with this, and I'm going to get pages. So it's pagination basically. I can just click down on my keyboard and it'll take me to the next page or the next line item and the next line item. So I can view it a little bit easier doing the less file or the less command. So it'll give me pagination, and then I can even right click or click on the right arrow and it'll take me to the end of the command. I can take down and it's a little bit more easier to manage when you are actually using the less command. It doesn't output everything directly onto the screen. And then you can just do Q to end it, or I think, let me see, I think it's Control C to end it. So let's see how we can get out of this view here. So yeah, it is Q to actually end it. You can press space to page down or scroll down, excuse me. You can do the B to scroll up, or you can use your arrow keys to go back and forth with that. And then we can also jump to the end of a file depending on how massive it is by just doing the G command. So this is one of the many options that comes with less. So if you do capital G, it'll take you to the very end of the file. So in this particular case, we do know that it's a large log file and we just want to see the most recent entries. So it'll take us to the very, very end of the file, as is implied by this very small piece down here in the orange that says end. So that's how we can kind of skip to the end, because typically in log files, the last entries in the file are the most recent entries of the file. And that's how you can make sure that you view the most recent entries, is by just doing the dash capital G option, and it'll just take you there. So we're going to press Q and we're going to get out of that. And then of course, if you wanted to do a manual for less, you can as well do that. And you can get the various options that are available for S, or how to even navigate while you're looking inside of it and how to work with the content. So less is a way to paginate, so to display something in pages for any type of text document or log document or anything basically that displays text. Now there's something called more. So less is more, less and more, right? So the counterpart to less would be the more command, but now it actually gives you fewer navigation options. So if I do the dpkg.log again, now in this particular case, I can still look at the file, but you would have to, again, now I'm just actually going page by page instead of doing line item by line item. I can't do right or left on my keyboard to go to the end of a line item. For example, if these are like super long items or super long lines, you won't be able to skip to the end of the line. You can only do up or down, and you're essentially updating page by page. As you can see at the bottom, it's giving you the percentage sign, meaning technically I'm at the 58% mark of this document, and it just keeps going until I get to the very end of the document, and that's basically it. So more is, it offers less navigation options, but it's still a very easy, it's a more convenient way to view the contents of a file instead of cat, for example, where you concatenate the contents onto the screen and now you have to scroll back and forth and try to find what you're looking for. It's a little bit easier to navigate with less and more. And that's basically it for viewing file contents. And then we can move on to displaying the beginning or end of file contents. All right, so now we have the head and tail commands, which, as the names imply, they're going to display the head or tail portion of a file. So just working with our specific dpkg log file here, if I just do head dpkg, you can see that it only displays the top 10 lines of the log file. So literally the very first 10 lines. Now you can actually display only 5 lines or 15 lines by giving it the option, which is the N option in this particular case. We can do the head, and then we do -n, and then we do the 5, and then we do dpkg, and it'll only display the top 5 lines of the dpackage log. And then we can, of course, combine the outputs. We can display the top 5 lines of multiple files. So let me find another log here. So we have the boot log, and then we have the dpackage log. So if I went and concatenated the boot log here, oh, it's denied. So I don't want to run sudo here. So let's see, what can we do? Let's see alternatives. Let's see if we can look at the alternatives log. And there we go. So we have the alternatives logs on our screen. So now that we can access these two various logs without entering into our root sudo mode, what I can do is I can use the head command. I will look at the first 5 lines of dpkg.log and alternatives log, and I'll get the two log entries, as you can see here, and it's actually very nicely split apart. So you have the dpackage portion at the top, and then you have the alternatives portion at the bottom. And this is obviously a much longer line that you can see because each entry just takes up more space on the screen. But these are actually the first 5 lines of these two documents. So you can actually do that with the head N5 as well as the portions of the second, which is the alternatives as well. So you have the dpackage as well as the alternatives logs that are both then displayed onto the screen. If we do the Q command, without repeating any of the headers, it'll show you the two different log files. So for example, if you have 2 instances of the alternatives logs, which happens a lot, so you have, because of the fact that certain log files get so massive, you can get a lot of entries in the log. So what the system does is that it creates another file. So there is nothing in this particular, actually, there we go. So what we have over here is the Zorg log file in this particular case. So let's see if we can look at the Zorg log file and without getting into sudo. So there we go. We have the Zorg log file, and then we have at the very top, let me see if I can see the headers here, or instead of doing that. So let's just do head, and then we'll do the Zorg.0.log, and then we have the top 5 lines here. And then we can see that we have a certain header, I feel like, in this particular case. So what I can do is I can ls one more time. And now what I'm going to do is I'm going to do head, and then I want to count the top 5 lines of the Zorg.0.log as well as the Zorg.1.log. And then we're going to display those two. So now you see that, and you have the headers as well. So we're going to now clear this, and then we're going to add the one other option in this particular case, which is going to be the -q, that should remove the header portion for us. And you can see that it has actually removed the header portion. So it doesn't say Zorg.0 or Zorg.1. It actually removed those headers from the output that we have over here. So now it's essentially as if you're looking at one log's entries, but we obviously know that we're looking at the log entries from these two separate log files. So I actually like the headers. So I don't know why somebody would want to remove the headers, because it seems very useful when you're looking at the items and you know which one belongs to which file. So in my mind, in my reference, I would say that it's better to keep the headers inside of your display as you break down various files and things like that. So that's what it looks like with head. So you look at the top 5 lines in this particular case of these two log files. And then what we can do is we can use less to look at the bottom portion of it. So if I just do less by itself and then do dpkg, and then it gives me the bottom portion of the, or excuse me, not less, my bad, because we already covered less, tail, sorry. So it's tail dpkg, and then it gives me the end of the log file with the last 10 lines. And most of the rules pretty much apply to this as well. So if I do tail-n5, it'll give me the last 5 lines of the dpackage log like that. And then I can also combine the file entries to display multiple files. So we can do 5 of the dpkg, and then we can also do 5 of the alternatives.log, and then we can see that it's split for us like that. And if you do the -q with this as well, it will go ahead and remove the headers for you. And then there's the following the output of an individual file that can be combined with tail, especially if the log file is being updated in real time. So this is for incident response and just security analysis. If you want to look at something in real time, that would be done with the -f command. So if you do, or the -f option. So if you do tail, and then if you do -f, and then look at any given file, what it's going to do is it's going to format it so it actually follows. So F would stand for follow. It follows the output of that in real time, meaning that you can look at essentially all of the events that are happening in a syslog, for example, or any service that has a lot of traffic or a lot of people using it, and you just want to analyze what happens with that specific log file. You would be able to use it with the -f command. The -f command is actually, I would say, in the context of the tail command, the -f option is specific to logs, because you can also look at text files and Python code and a variety of other file formats using the head and tail commands. But the -f option of tail, because the tail is looking at the end of the file, which is the most recent items, and then when you add -f to it, that's in real-time update. That's very specific to log files. You can do it with a variety of other file types again, but there's no other file type that typically is being updated in real time unless you have like multiple people that are making edits in real time to this one particular file. So for the most part, the only thing that is being updated in real time is a log file. So if you do tail -f, then you're going to look at the most recent entries of the log file, and it's going to be updated in real time, so you can kind of see what the activity is like within that log. And that's basically it. That's what we got for viewing the file contents and displaying the beginnings and ends of files. Now what we can do is we can move on to searching within the text, looking for substitutions, pattern matching, and of course the various text editors that are available for us as Linux administrators. So let's move on to that. All right, so now we need to talk about searching for text inside of documents and log files, for example, and from there being able to either match for patterns, substitutions of the text, sorting through the text, counting the occurrences of the text, and maybe finding any unique approaches or variations of what shows up inside of the text. So there's a lot of different things that you can actually do with this. And what we're going to do is we're going to start from the very, very top so that you can understand what the very base command that kind of starts this whole thing is. And the very base command for all of this is going to be the grep command, which is the command that is used to search for a variety of different items. So let's start with grep. Now, since I am inside of the log directory right here, and what we're going to do is we're going to work with alternatives. We'll just work with the alternatives log, and let's see what actually shows up in here frequently. So we have desktop grub that shows up here fairly frequently. We also have desktop login background and a variety of different things that work with the word desktop. So what we're going to do is we're going to use that as our search phrase, as our search term. So we're going to grep search for desktop, and then we're going to search for that phrase inside of our alternatives log. And then as you can see is that it basically just highlights all of the different instances of the word desktop inside of this massive log. But what happens is that, you know, if it's a really large file, you don't exactly know what you're specifically looking for. You just want to, there's a lot of different ways that you want to kind of manipulate this particular piece of data. So there are different things that you can do, or different additions, I guess, that you can make to look for a specific instance or the number of instances that shows up for this thing. We can do the search for this very particular item. So for example, the desktop item, we can search for it without worrying about the case. So case sensitivity, you can worry about or not worry about it, meaning insensitive basically. So you can do an insensitive search by doing the -i option that comes with grep. So you can do -i and then again do this thing for desktop and then go through the alternatives log. And again, it will pretty much highlight the same exact thing because the first time I didn't have the desktop. So we'll do the first time I didn't have any kind of caps lock or anything like that. So if I did grep and I caps locked it, so if I did desktop, for example, in all caps, and then I looked for it inside of the alternatives log, nothing will show up, right? So if I do grep and then do -i and then do it in capital right here, and then go back to the alternatives log, now everything will show up. So -i will be case insensitive and it won't consider the case. So, and this could be for if the items inside of the actual log were capitalized and you are searching for it in lowercase and you just want all of those things to show up. For example, you would use the -i to be insensitive for it. And then there's the recursive search because you can also search for a file or a term even recursively. And this is a little bit, the results can be, of course, massive. So if I search for desktop and then just do it recursively, and I will do it inside of the var log location, you can see that there's going to be a lot of different entries. So we have the dpackage log that has desktop showing up in it. We have the actual, what is this, inet sim, the journal, the private, the apt term log. There's so many different logs that would have the term desktop sitting in them. So you can actually search for the phrase inside of an individual file, or you can search for the phrase inside of a directory to see how many different instances it shows up and where that thing shows up. And you would do that with the -r for recursive search of the word desktop inside of the given directory. Okay. So that's what we have. These are like some of the base commands that we have to combine with grep. Now, what you can do to kind of make your life a little bit easier, or maybe you're just looking for something else. So for example, if I'm looking for a given IP address, for example, I can do grep and I can search for the IP address, whatever the IP address would be. And then I can actually do count. So the -c would be a count of that. Now, in this particular case, I want to actually just look for the word desktop, and then we're just going to do a -c, and then we're going to count for it inside of the alternatives log to see how many times it shows up. And 117 times is when the word desktop shows up just inside of the alternatives log. So in that case, you can search for anything, the instances of something. So this is very useful for trying to find the instances of the word error inside of the authentication log, for example, or a given IP address. If you think that an IP address is a malicious IP address, you can search for it inside of your net logs or your connectivity logs to see your DNS logs, maybe to see how many times that given IP address has shown up, and you would do that with the -c command. Now, if you wanted to be insensitive, right, so that would again be considered with the -i. So you could still do the same exact thing that we did previously, just add the -c to it as well as the -i to make it case insensitive and then count the number of occurrences that would show up in any given file, okay? So that's what we have for the few different options that are very useful for our grep command. Now, what you can do is you can combine grep with a variety of different sorting types of options. So for example, the actual command sort would sort the contents of any given output or just even the contents of a file. So this would be something that we could actually kind of combine with grep, or we can just use by itself. So we can, we'll actually do it by itself. So let's just do sort by itself. So mostly because of the fact that I don't want to mess with any of my log files, what I'm going to do is I'm going to go back to my original directory, which was my users directory. And we're going to go back to our desktop folder. And in here we have the message documents. And I mean, they're not really that big. So what I'm going to do is I'm going to create a new document, and then we'll just call it the sort document. So we'll do nano and we'll do sort.txt. And then inside of this, I'm going to just put a bunch of words that we can potentially sort. Okay, so here we go. Okay, so these are going to be our entries. So we're just going to save this document and we're going to close it out. So now we have the sort document that's on our desktop. So now what I can do is I can actually sort it. So I can do sort and then sort.txt, and then you can see that it'll display the contents for you. But in this particular case, it's displaying it in alphabetical order. If I want to look at this in reverse order, I can just do the sort command with the -r option, and then that will go ahead and sort it for me in reverse order, so descending order. And the same thing can actually apply with the numbers. So if there's a bunch of numbers inside of this and you want to sort them, so for example, IP addresses, right? So if you're trying to sort IP addresses, so you're grepping for any given numbers of IP addresses, and then you want to sort them from ascending or descending, or if you want to look at essentially sort any kind of data, you would be able to do it with sort. If you don't add the -r, it'll do it in ascending. If you add the -r, it'll do it in descending. Now, if you want to sort the lines numerically, you would do it with -n. So let's try that. So if we do -n and then we go through the sort.txt, it'll still run it, but there are no numbers here. So the -n is kind of irrelevant in this particular case. But if you wanted to sort a numbers document, so let me actually create a numbers document. Okay, so this is going to be our numbers document. I'm going to press enter, close it out. So now we want to sort the num document, and then we can see that we'll sort it. And it actually even counted the empty line that I had over there because there were a couple of empty lines at the very end and in the middle of the document. So it sorted for us in ascending in this particular case. So if you wanted to sort it in descending, we would also need to do the -r and then do the txt, and then it would sort it for us in descending order as well. So the sort option is actually very useful. And what you can do with it is that you can combine it. So this is one of the things that it starts making it really, really cool. So you can actually combine things based on the output of any given command. For example, the output of grep, right? So if we go back here and we'll create another document. And then with this one, we'll have some multiples that are going on, as well as the variations of the items, so that we can combine a few things. Because I want to use a few following commands, which would be the word count, the line count, and then of course finding unique instances of something. So I'm going to create another document, and then we're going to add some other items in this one. That should be good enough, and we'll write that. We'll close that out. So now what we can do in this particular case, we can combine sort as well as unique as well as word count to try to see what we can get out of all of our little combinations of things. So first and foremost, before we actually try to find the uniques and these different variations, let's try to just count the number of instances, or not even that, the number of lines, for example, that shows up inside of our file. So if I go and do wc for word count, and then I give it the L option, and then I do doc.txt, it'll give me the number of lines that are inside of that document. So for example, I have 31 lines inside of the doc.txt. Now, if I want to clear this, and then I want to look at the number of words inside of that same document, it would be 30. So there are 30 words inside of that given document, because there's probably one of the lines was an empty line, so it still counted it as a line, which would be 31 lines, but then there were 30 actual words that are inside of the document. Now, if I want to count the number of characters inside of the document, we would do the -c option, and then we would do doc.txt. Now we have 179 total characters across all of the words that exist inside of this particular document. So you have the word count, but then what you can do is you can count the number of lines, you can count the number of words, and you can count the number of characters that exists inside any given document by using the word count. So that's going to help us, again, as we get into combining some of these sorting mechanisms. So we have sort that we've gone through so far, we have grep that we've gone through so far, and then we have the word count that we've gone through. So now what we're going to do is we're going to kind of combine all of these things to get us a little bit more useful results, especially when we add the unique portion of this. And then the unique one, again, it comes in very handy when you're doing incident response investigations and you're sorting through log files to try to find for example, an IP address that shows up, or how many unique IP addresses show up, how many instances does one IP address show up. So like how many times does that one IP address show up? So we can combine a lot of these things to try to find that information. So let's do grep, and then what we're going to do is I'm going to go for, I think phone actually showed up a few times, so I can do phone and then do doc.txt, and then we can see that earphones shows up, and then the various instances of phone themselves show up. So I can now do grep phone and then do doc.txt, and then when we do this singular line, this vertical line, and this is typically above any keyboard, above the enter button, there is a backslash, and then when you hold down shift and then you press that button, you give this pipe, and then when we put this pipe, we take the output of this command right here, and then we take the output of this command and we pipe it into our next command. So for example, if I do output of this and then I sort it in reverse order and press enter, phone shows up first and then earphones shows up at the very end because we're sorting it in descending order. And then that would be, of course, the letter P would show up and then the letter E would show up, right? So we can do sort, and then we can also do, for example, the word count, right? So actually not even that. So let's do unique. So if I wanted to do a unique output of something, so you would do the sort of the file, and then you would get all of the unique instances of it. Press that, and then you only get phone and earphones. You see, so instead of showing all of the different phones that showed up, it will only show you the singular phone. So even though there were, I think, 4 or 5 lines of the word phone, it only gives me that one phone, and then it gives me that earphone, and that's pretty much it. Now I need to actually see what all the other things were because I forgot. So we have dog in here, we have pattern, we have address, we have mouse, and so those were the only repeating ones, right? So we can kind of mess around with those a little bit by going through sort as well as counting the unique instances of something, right? So if I actually go to, for example, we'll do actually this. So we'll do sort of the doc.txt, and then what we're going to do is we're going to use unique, and I want to count the number of instances of everything that shows up. So an empty line would show up 1 time. The word Adam showed up twice, address showed up twice, apple once, cat once, dog showed up 4 times, mouse showed up 3, pattern 2, phone 5, so on and so forth. So it'll actually show you the uniques, but it will say that this one showed up 4 times and this one showed up 3 times, so on and so forth. So this is how once you start chaining these things together, that's how useful all of these things will become. And the last item for our search tools is going to be the awk item, or the awk command. And the awk command is actually very useful because you can search for patterns and print individual columns of certain files, so on and so forth. And just to kind of display that for you, we can look for example, let's say we want to print the first column. So I need to do this correctly. So I will have to do print, and then you do the $1, and that implies that you want to print the first column, and then you put that inside of these quotations, excuse me. So let me actually close that out because I didn't print that correctly. So we would do the awk again, and then so we will do print and then $1, which implies we want the first column, and then you close that off with the single quote over there. And then from there, you're printing the first column of any given file, right? So in this particular case, let's say we want to print the alternatives file, the first column of it. And then you get to see that's the actual first column of the alternatives file. If I wanted to print the second column, for example, I would do $2, and then we'll print the second column, which in this case is going to be our timestamp, and then so on and so forth. Now, what happens is that when you're looking at something like the alternatives file, so let's say, let me spell this right. We have the alternatives file, and then we have the various commands. So you have, this is the first column, this would be the second column, and it's separated by a space. So the time would be the third, and then separated by a space. This would be link, and then this would be so on and so forth. So I would say all of these things, being that they're separated by space, it would require that from here on, so this would be space 1, space 2, space 3, space 4, and so on. So if you wanted to print everything and from space 4, you would need to dedicate the $4 and then everything after the fact. And we're going to find out exactly how to print that. So let's go and find that out. All right, so to be able to print everything from column 4 and on, we do have to do a little bit of a tricky tactic here. So what we're going to do is we're going to assign the column 1, column 2, and column 3 to the empty space that we have over here. And then what we're going to do is separate that and print, let's do this, and then we're going to print 0 and on. So what this does is that it's going to display, and this is kind of beyond the scope of the education that we want to cover for Linux Plus. But again, I just want you to get really good at this stuff. So what we do is that we're going to print, we're going to dedicate a 0 value, an empty value to the first 3 columns, even though we know that there are stuff inside of the first 3 columns. So when we do this, it skips these 3 columns, and then it goes from column 4 and on. When you do the $0, it'll just say everything after this will start as the first one, and then from there it will just start printing everything from there. So the file name in this particular case is going to be our alternatives.log, and then it'll print everything from column 4 and on, which you can see is where the commands are. So it starts running all of the printing all of the stuff that came after that timestamp, right? So this particular case is kind of redundant and it's a little bit useless for us, but the overall command is actually very useful. So if you just wanted to print a specific column, you would do it with assigning the $sign and then the number of the column that would be associated with it. If you want to print from one location onward, you would have to take the first. So let's say you want to print everything after column 5 or column 6. You would take the column 1, 2, 3, 4, and 5. You would dedicate a 0 space, an empty space to them, and then those would be nullified. And then after that, you would get the print 0, and then it would give you everything from that last column onward, and it would just print that for you. So that's what the awk command is actually very useful for. It'll print something from a specific location of the line onward, which is actually just very, very useful. So that's one thing that we can do. That's one way that we can use awk. There's another way that we can use awk is to search for any given pattern. So in our particular case, just going back to what we had with our desktop, for example, or I forget what it was, desktop something. So let me actually do the cat alternatives log one more time. It's desktop grub. That's what it was. So what we're going to do is we're going to search for desktop grub, which would be our pattern. And then inside of this location, what we're going to do is we're going to print again. So print and then give me the $0 and then close that off. And then that's going to be our search. And then what we're going to do is we're going to search for that inside of the log file. And let me see. I feel like that has actually done incorrectly. I think I need to actually put the pattern inside of the / because that's going to be implying that we're going to use the regular expressions. So there you go. Now you do it that way, and it actually shows everything, every single line that has the desktop grub. So what this does is that you're allowed to, now you can put regx inside of the search command. So with grep, it wasn't easy to do because I actually didn't use regular expressions as the search parameter or the search option. And you can actually even look for search regular expressions inside of grep. You just need to signify, you need to declare that you're looking for regular expressions, and you do that with the capital E. So I didn't do that correctly the first time around, and that was my bad. So if I actually do capital E and then I do desktop grub, and then hold on, let's actually do this portion as well. So we do this, and then we do desktop grub, and then we do this again. So now we have this dedicated to this, and then we're going to go alternatives.log, and then from here we can start sorting, and then we can start looking for uniques, for example, and counting them, so on and so forth. And then you'll see that all of those instances show up. If you remember when we actually ran that through grep the first time around and I tried to use the asterisks as my wildcard characters, that actually didn't work. It didn't show up. So it's because I wasn't using the dash capital E to signify that we were using a regular expression. So if you don't want to use grep, for example, and you just want to use awk awk to search for patterns, you don't need to signify with any kind of a flag that you're looking for a pattern. You just need to actually put in the pattern. And the way that that looks in regular expressions is that the pattern is enclosed inside of these forward slashes. And then anything, again, inside of these forward slashes would actually print for you, and it would be signified as the pattern. I'm not going to teach you regular expressions because there's an entire video that I did for regular expressions. So you can learn how to write regular expressions. And then when you have that pattern, you can just put it inside of the two forward slashes, and then awk will search for that for you and then just print every single line that matches that pattern, which is actually very, very useful. Then what you can do is you can print the first field of each line in any given password using a delimiter. So one of the things that we had previously is that the space was the delimiter. So if you want to just declare a delimiter, so for example, when we looked at the, so let's go and concatenate our alternatives file one more time. If we look at this file, the space here is the delimiter, okay? And what that means is that each one of these columns is being separated by a space until you get to this very last portion, which includes this last line, and this last line is the full field value. So for whatever reason, let's say that the space was not the separator, the delimiter between each line. Maybe the comma was the separator. So there's something called a comma separated value file. So a CSV file, which turns into a spreadsheet ultimately, is comma separated value. So your delimiter in those files would be a comma instead of a space. And so in that case, anything between the commas, so this could, for example, be one whole field because it's separated by commas. These two portions right here could be commas. So if that was the case, then you could assign a delimiter using awk. And in this case, unfortunately, it's not going to work because there are spaces that are our delimiters in this case. But you would do it with the F, the capital F, and then from there you would assign the delimiter. So it would be capital F comma, for example, or capital F colon, for example. And if I did this because I know that in the alternatives file, there actually is something, there is like the timestamp that's separated by colons. So we can actually do it this way. And then what it's going to do is going to print the first field of each line using the colon as the separator. And so I will do pretty much the same command that we had. So we're going to do the number 1 to imply that we want to print the first field. And I actually need to put this inside of quotes. So my bad. Let's do this one more time. Print number 1 and then put that inside of the quotes. So now we have that. And then we're going to just look at our alternatives.log here. And it's going to print everything up until that first comma. So notice that, or the first colon. You see this? So this is being considered as the first field. It's no longer counting the spaces as the separator, as the delimiter. It's actually counting the colon that comes after the 15, because the 15, so let's do this one more time. We'll do head, and then we'll do n5 alternatives.log so we can actually see the top 5 lines. So we can see that everything up until this first colon is actually being counted as the first field, right? So we're looking for the first field up until the delimiter, which in this case is the colon. So now it's no longer separating by spaces, it's actually separating by colons, which means all of this is considered the first field. So that's how you separate by a specific delimiter. You actually assign your delimiter to the awk command by using the capital F command, and then right after it, you just give the delimiter. So for example, colon or comma, etc., yada, yada, yada. So you get the idea here. Okay, so this is going to be a really quick section because we've already used a few of, or at least one of these tools. And one of the tools is going to be the Nano tool. And you've seen me create multiple documents with it. And Nano is the kind of like the most popular text editor, I would say. Some other people like Vim as well. So we have Nano and Vim, which are both text editors inside of Linux. I personally just like Nano because it's very user friendly. It's very simple to use. It doesn't require all the extra options that Vim requires for you to edit a document. So for example, we have the ls command, for example, that shows us everything that's inside of this particular desktop folder that we're in. And so I already know that we have the doc folder. So first things first is that we can actually create a file using Nano. So I can just do Nano and then file.txt. So I don't even know if I have a file.txt. I don't. So I can do Nano file.txt and it'll create an empty file. It'll open up an empty file for me. It'll name it file.txt. And all I have to do is just fill it with content and then save it. And once I've saved it, it'll actually save this particular file. What I'm going to do is I'm going to do Control X and it's going to say, do you want to save the buffer? I'm going to say no, or just press N, and we won't save that particular file because it's kind of, I have too many sample files on this desktop right now. So one of the big things that Nano is used for or useful for is that you can essentially go through any text document and modify it. And you can use Nano to write code. You know what I mean? It's like a very, very powerful text editor. You can create Python scripts. So for example, name something with the extension of .py or name something with the extension of .sh to turn it into a shell script. And then from there, you can actually write code inside of it. And usually when you work with Nano, the big thing that a lot of people didn't like before was that in order to create a tab, because in a lot of cases, when you're writing chunks of code inside of Python. So for example, if I'm creating a function or if I'm creating some kind of an iterative statement or a conditional statement, I would have to press tab to move and create the body of it, right? In this particular case, previously, you weren't able to do it. You would have to do space, 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 space to create the tab. And in this version of Nano that I'm running, it actually can do it for you by just pressing tab. So it's very, very useful. And that was as far as I'm concerned, that was the only thing that Vim had that Nano did not have. But, you know, Nano 8.1, which is the version that I'm using right now, clearly has it because I could just press tab or I could backspace like that and I could remove the tab that's been created. So that part was literally the only thing that I thought of that Vim had that Nano did not have. And so now that I know that it has it, as far as to have the right version, then I don't think I'm ever going to use Vim. I just want you to know about it because you're most likely going to see it as one of the tools or the resources, and you just need to know how to interact with it. So Nano just opens up a file for you just like we did right now. We can make any modifications to it that we wanted to. And then from there, you would do Control W to search for something. So for example, if I wanted to search for mouse, I can do Control W and press enter, and then it will show me the first instance of mouse. I can do Control W, and you'll see at the bottom that it actually has mouse already filled in, and I just press enter again. It'll show me the second instance of mouse, and so on and so forth. If I wanted to change what I'm looking for, I could just change it with the new search term, and it'll search for that specific line that has that item. So Control W will actually search for something for you. You can cut and paste using the Control K. So Control K in that case will actually take that entire line as you just saw, and then it'll cut it for me. If I do Control U, it'll paste it on that line for me. So it actually takes the entire line and cuts it. And then there's a variety of different options as well that are available that we don't really need to go to, but you can see all the options at the bottom of the screen, or you can just look for the manual of Nano and then you'll be able to see all those options. What's important is that you need to save something. So if you need to save something, you're going to do Control O to write it out. And then you're going to press enter. So it'll actually write it. It's going to save it. And then you can do Control X and then it'll exit it. And that's basically the usage that you have with Nano. We can always do man Nano to pull up the manual for Nano. And of course, go through all the options that are available for Nano to make sure that you have everything that you need. but it's very, very intuitive. It's very useful. I love Nano. I use it very frequently. You can use it to create a file by just saying Nano and then the file name. And then from there, give it an SH extension. If you do give it an SH extension, when we get into shell scripting, I'm going to show you what other requirements you need to actually make it function as a shell script. But you just need to know that you can actually do the SH to create a script with shell, or PY to create a script with Python, or really any other extension to create any other kind of a script. And you can just open it up with Nano and it'll open it up as such. And then you can start writing your Python script or your shell script, so on and so forth. So very, very useful little text editor. And it is one of my absolute favorites. Now, the next thing that we want to cover is Vim, which is the other text editor. And if you just type Vim and press enter, you'll see this nice little nifty little menu, right? So it says that you can get help by doing :help. Oops, I actually pressed the wrong button and now I am out of this thing. So I have to do :Q to exit that. So if I do press Vim, I can't click on anything with my mouse apparently. So you need to do the : and then the word help to be able to actually go to the help menu. You need to do : the letter Q to be able to quit, and then so on and so forth. So the : is actually very important inside of Vim because it kind of signifies that you're entering one of these other commands for Vim to function. Now, when I run Vim like this, if I just do Vim as I did right now, it'll just open it up and then I would need to enter it in interactive mode, and I would press I for that. And then now you see at the bottom it says insert, and then now we're inside of interactive mode and we can start writing code and text, so on and so forth, right? So this is how you would do it. And now if I wanted to exit interactive mode, I would press escape on my keyboard and now I'm out of interactive mode. And if I wanted to save it, then I would need to do the and W, which shows up at the very, very bottom. So it's really hard to see, but it's in the bottom left corner that it says :W. And then I would write the contents of that. And then it's going to ask me, how do you want to save it as, so on and so forth. So I don't want to save this. I'm going to do :Q for quit. And since I don't want to save it, I'm going to add an exclamation mark at the end of it because I want to quit without saving. And then we're going to press enter and then we'll be able to exit Vim. So as you can see, it's a little bit more sophisticated of a text editor than Nano is. But for the most part, you can also open up the doc, you can open up any text editor or any document with Vim. You can also create documents with Vim in the same way that you would with Nano by dedicating the file name as well as the extension of it. And then now that I'm inside of my text right here, I need to actually press I to go into insert mode, and then I can add more text here and then do that. And then now let's say I want to actually save this one. So I will do :W, press enter. And actually, no, I'm sorry. I need to do escape first so I can get out of insert mode. Then I do :W, press enter. And now it's been written. And now I can do :Q and quit. And now we're good. And now we've saved our doc.text and we've saved this particular line at the very end of it that we just added with Vim. So Vim is a very useful text editor. A lot of people prefer it because they want to be fancy. I think that's really that's one of the only reasons. I can't think of anything that Vim can do that Nano can't do. And that's the piece that I'm like, okay, well, I don't know. I think it's a matter of preference for most people. I just like Nano. The reason why I wanted to share it with you, because at the very least, I want you to know how to interact with it, right? So you can open up a file using Vim by doing Vim and then the file name, or you can just create a file. So if I do Vim and then file.txt, because I know we don't have one, so I can do Vim file.txt and now it'll open up something and it's new, as you can see at the bottom that it says it's a new file. And then I can just press I to go into interactive mode, and this will be the content of the file. And then I can press escape to get out of interactive mode. And I'm going to do :W to write it, and it'll be written. I can do :Q to exit out of it, quit out of it. And that's what we got. Now, if you want to add a file or add a line or delete a line, copy a line, for example. So again, we'll go into insert mode and then we'll go into our next line over here. And then we will do let's say I want to actually delete this line. So I'll escape out of this. I'll do DD and I'll delete that line. So double D, it'll delete the line that we had previously. And then I'll have to recreate it now. So I can just do I, and then I'll do this is a line, another one, and another. And these will be our different lines that we have over here. So let's say now we want to cut and paste, or we want to copy and paste, right? So we will have to exit the interactive mode. That's very important. The insert mode, you have to exit it before you can run any of these other options. So I'll press escape and I'll get out of insert mode, and then I want to copy a line. So I'll do YY, and now this line has been copied, and I'll just go down one item and I'll just do P, and it'll paste it for me. So YY will copy, P will paste, and then I can, it's called yanking a line. So when you do YY, you're yanking a line, technically copying a line, and then from there you can start pasting the line, right? So that's basically how the copy paste works inside of Vim. And then now if I wanted to delete this, I'll just do DD and it'll delete that. DD, it'll delete that empty line. And now I only have these lines right here. These little blue squigglies that you see are not empty lines. These are essentially, these are the only 4 lines that we can see over here. So if I actually do the write and then quit, and then we do our nifty little word count and count the lines inside of file.txt, there will only be 4 lines, right? Because all of those squigglies are not being counted as lines. They're not even present, right? If I wanted to actually create those lines as empty lines, then I would go into insert mode, and then I would go into the end of this, press enter, 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 enter. Now I have these empty lines that are actually going to be counted as lines. And I could even delete these individual lines by getting out of my insert mode, do DD, that's deleted, 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 and now I'm back to 4 lines. So I mean, it's fairly intuitive once you get used to it, and when you kind of get a hang of the various options that it has. And it can be, I would say it can be beneficial to learn about both of them, because you never know what you're going to be presented with as you go into your practical examination and what they are going to limit you to. So they may say that you can only use the Vim text editor to create a file and to modify the file, so on and so forth. So it's useful to know both of these tools. Nano doesn't require you to do any of that stuff. You can just get into it and start editing. Vim requires just a few of these little options, for example, going into insert mode and then coming out of insert mode to be able to save it, so on and so forth. So they're different, but I think they serve the same functions. And depending on your style and your preference, you can use one or the other. I just prefer Nano because it's easier, and it's kind of, you just jump into it and you start typing away. So that's what it is. That's all we have for our wonderful text editors. And now we can actually move on to a completely new section on file permissions.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, so let's talk about file permissions and ownership, which is very, very important. Now we're really getting into the security portion of this training series, as well as just system administration and managing permissions of groups and users and all of the stuff that falls under that. So there are a few key commands. So this is actually not very complicated. It's just very important. Okay. So that's like the big kind of notice that I have to give you, the big asterisk or caveat that I have to give you. This is not a complicated process what we're going to go through. It's just very important. And you need to really, really understand how the whole thing works. So first and foremost, let's talk about changing file permissions. To be able to change file permissions, you're going to be using the chmod command. The chmod command stands for change mode. And essentially, you can change the permissions of a file or directory and all of the contents of that directory with either numerically or symbolically. So what we're going to do is first we're going to look at the permissions that we have on these various files over here. So we have the doc.txt file that is basically on the very first portion. We're going to analyze what these things actually mean and then how we can change them. So first, the very first item right here is representing whether or not this is a file or a directory. So let me actually create a directory and we'll call this directory. And we'll look at there we go, that's where it is. So ls.l now gives us the directory, and we can see that the first character here is represented by a D, which stands for directory. Everything else is considered a file. So it's either a file or a directory. That's basically all it is. The first three letters on the left right here are representing the permissions of the owner, the person that created the file. It may not necessarily be the person that created the file. In a lot of cases, it is the person that created the file. You can also change the ownership of a file or a folder, and we'll talk about how to do that in, I think, the very next command, actually. But essentially, whoever the owner is, the first three characters represent the permissions of the owner. And then we have the next three characters, which represent the permissions of the group that owns this file, or the group that has been assigned to this particular file or directory. And then finally, we have everybody else, which falls in the others category. So for example, if this person is the root owner or the administrator or Adam, whatever, John, and then this group would be the group that John actually belongs to, his primary group, which would be the IT group, right? That would be the permissions of the IT group. And then this portion right here represents everybody. So people in marketing or people in sales or people in whatever, human resources, right? So it's like everybody else, and it could even include guests that may kind of somehow be logged on to that particular computer. So this is how it breaks down. You have these three different portions of permissions, okay? Once you understand this, you can kind of look at the nuances of this. So R stands for reading the file. W stands for writing to the file or modifying the file, and X stands for executing the file. Typically, when you have a directory, these permissions typically apply to every item inside of the directory. If that's not indeed the case and individual items inside the directory have different permissions, then that's something else. But for the most part, the stuff that's inside of a directory, for the most part, inherits the permissions of the directory. Okay, so this is what we know about these permissions. Now, something that you need to know is that there's the symbolic, which is the RWX. That's the symbolic version of a permission. And then there is the numerical. So if somebody has RWX, all three of those permissions, it's going to be a 7 value. R represents 4, W represents 2, and then X represents 1. So if they have all three of them, that is a 7 value. So if we were looking at this again, and we see this particular portion, and we have, this is the directory, so that's fine. This represents a 7, so RWX, complete 7. This represents another 7, so the group also has rewrite and execute permissions. This one right here doesn't have write permissions, so it would be a 4 plus a 1, which would be a 5. So if we were to look at this permission for this particular directory, numerically, this permission would represent a 775. That's what the permission for that is. Now, if this directory actually had the full read, write, and execute for the others group, it would be a 777. So if you have a 777 permission on something, that means everybody, the owner, the group, as well as everybody else, the others category, can all read, write, and execute on that particular file. Okay, so hopefully that actually makes sense for you. Now, if we have kind of wrapped our head around that, what we can do now is we can start changing permissions to these various items. And we would do this with the chmod command. So chmod command can be done with either the numeric value or it can be done with the symbolic value. So let's do lsl one more time so we can see what the permissions of these things are. So in this particular case, let's say we have this specific directory that we want to mess with a little bit. And let's say we want to remove the execute portion of that, and we only want to give them read permission. They shouldn't have permission to execute anything inside of that directory. So what we do is we would do chmod, and then just the permission itself numerically would be what? 7, and if we're removing execute, we're removing one value, so it would be 774. And then for that, we would just say directory, press enter, and now if we run lsl one more time, we can see that that final little X that was over here for that directory is now gone. So they only have read permission in this particular case. Okay, that's how you do it numerically. So if I wanted to actually add that permission to them, or let's say I want to give them read and write, but no execute permission. So we would do 7 and then turn that into a 6 because the write permission has a value of 2 and this has a value of 4. And the final thing has a value of 1, right? So if we have that, we can then do that. And now if we do LSL, we can see that the write permission has been assigned to this. Okay, so this is how you do it numerically. If I wanted to give you one more example here, if I wanted to do a change, so let's actually clear the screen here. If I wanted to do a change and make everybody other than the owner just have read permissions, we would do 744 and nobody else would be able to write or execute to it. And then we would do directory. And now if we do LSL, we can see that the group only has read permission and the others category also has read permission. The only person that can read, write, and execute would be the owner in this particular case, also referred to as the user. So this is the user level, this is the group level, and then this is the others category, the others level, okay? So that's how you do it numerically. Now let's talk about how you do it symbolically. Symbolically is a little bit different. So we have to actually have either the user or the group or the others category. So that's what they're represented by, U, G, or others, okay? So if we wanted to, for example, for our directory, so we know that it's at a, what is it? I think it's a 744, right? So it's, yeah, so the group and the others category only have read permissions. So let's say we want to give them both write permissions. So I can do chmod and I can do G, and what I'm going to do is I'm going to give it a plus and I'm going to give it a W, so write. So I'm doing a write permission added to the group category, and I'm doing it for the directory. And now if I run LSL, we can see that the group right here actually has the write permission that previously they did not have over here. Okay, so that's what that looks like. You would do a plus if you want to give them permission to something. And I can do the same thing. I can do again chmod and I can do G plus execute, and I can give them the access to the directory, and now they have execute permissions on the directory, as we can see over here, read, write, and execute. And then the others group still has only read permissions in this directory, okay? So that's how you do it symbolically if you wanted to add something. So if I wanted to remove something, so let's say now we don't want anybody other than the owner or the user and the group to be able to access it, meaning that we don't want the others category to even be able to read the contents of that directory. So what we do is chmod, and then we would do other minus R, meaning we're taking the read permission away from them. And then we're going to just simply go over here, do that. And then now we're going to do LSL, and we can see that the others group has absolutely 0 permissions. They don't have permission to read, write, or execute, okay? It's very simple. You either do G plus or G minus or U plus or U minus or O plus O minus. That's basically what it is to do it symbolically, okay? So that is how you remove permissions or add permissions to either a file or a directory. So for example, let's start messing around with this doc file that we have over here. And let's say we want to give permission to the user to actually be able to execute that file. So I'm going to do chmod, and then I'm going to do U plus X, and then I'm going to do doc.txt. And now I'm going to list the permissions of that, and now we can see that the user has actually been given execute permissions as well, and then the group or the others portion have 0 permissions, and over here the others portion also still has 0 permissions. Okay, so this is how we can establish or add or subtract permissions for any of those categories: the user, the group, or the others group, the others category. Okay. So that's what we have symbolically and numerically as far as adding or removing permissions. Now, here's what becomes a little bit interesting and kind of useful. So let's say we want to actually give the documents and the files inside of this directory the same exact permissions of this directory. Okay, so I'm going to go in here. I'm going to go into the directory itself. And then what I'm going to do is we're going to touch a file and we'll call it whatever file.txt because it is actually empty. So we'll go here and we're going to go into the directory and we're going to, what do you mean? There's actually a directory. Oh, I'm already inside the directory. My bad. So inside of the directory, we can actually see that there is a file. And then if we look at it, we see that the permissions of the file are not the permissions of the directory. So if I actually do the LSL of the actual directory itself. So if I do LSL of, sorry, not this contents, excuse me. So if we go back one, and then if we do LSL of this particular location, then we can see that the directory has read write execute and read write execute, as well as nothing for the others category. So I want the file that's inside of that. So if I do LSL and then directory, we can see that the file inside of it has read write, no execute on the group either. And then the others category actually has read permissions. So what we want to do is we want to make a recursive permission assignment to all of the contents inside of the directory. And we want that recursive permission assignment to be exactly what we see here. So what we can do is we can actually do this numerically very easily because we already now know what the numeric representation of these permissions are. So what I'm going to do is I'm going to do chmod. I'm going to do let me actually clear the screen to make it easier for you. We'll do chmod. We're going to do dash capital R for recursive, and then we're going to give the permissions that we want. So we want 77 and then 0, which is going to represent nothing for the last portion. And then for those, we're just going to say directory. And then now we have a recursive permission of everything in that directory. So if I do LSL, we see that the directory itself is still untouched. But now, if we actually go inside of that directory, and here's fingers crossed here. So if we go inside the directory and we do LSL, we see that the file itself has also been modified to take recursive permissions from the directory. So this is how you make sure that every file or folder inside of any other given folder actually has the permissions of that folder. And this is how you control permissions for a group, for example. So if it's the developers group or the IT group, and the IT group actually has permission to view the contents of this directory, to modify the contents, so on and so forth, but you don't want anybody else to have permissions over the contents of this directory. So it could be literally very sensitive documents, things that store people's usernames and passwords, and a variety of other documents that are just very sensitive. They have a lot of sensitive information in them that could damage the company, or if somebody got access to them, like a malicious actor got a username and password for somebody in the marketing department, because marketing doesn't give a fuck about security. And then from there, you go ahead and give the marketing somebody in the others category, right? So this would be the IT group, for example, that has read write permissions. But in this group, they should not have any read or write or anything like that that's available for this directory, because it's housing all of the usernames and passwords for everybody in the company. And the marketing guy didn't care enough to have a strong password, and now he got hacked. So if that guy had access to this particular directory because of a misconfiguration on your end as the security guy or the system administrator, if that group had access to this file, now the entire company is at risk, right? So this is how you make sure that all of the permissions inside of this directory apply to every file that is created in that directory. So let's try to create a new file now, and let's see if it automatically applies to it, right? So let's go and we'll do another file. So we'll do file2.txt, and then now we have that, and we're going to do lsl, and we see that file2.txt did not inherit those permissions, which means that we need to go back and then we need to run our previous chmod command for that directory one more time and do it that way. And now if we go into the directory and do lsl, we can see that the new file has run this as well. So there's something that you can do in the scripting portion, and we're unfortunately, because of the fact that this is a little bit more advanced than the scope of this tutorial, I'm not going to be covering it, but you can look into it and you can actually check routinely. You can have a scheduled check of any given directory where every hour, for example, it'll check to see if any modifications have been made to that directory, meaning any additions have been made to that directory. And if there have been any additions made to that directory, the system will just run this command to make sure that all of those new additions inside of that directory have these permissions. So then you can automate this, because you don't want to be sitting there all day changing permissions to a given directory just because the fact that it's very high use and it gets a lot of traffic and there's a lot of files that are generated inside of it, so on and so forth. So it's important to learn how to automate these things. We will go through scripting later on in this tutorial, but we're not going to go through massive operation. Maybe I will. I don't know how I'll feel in that moment. Right now, I'm kind of tired because it's 3 in the morning. So maybe right now, the way that I feel, I don't want to create that script. But just for the hell of it, I've been known to do a lot of useful stuff for people. So I might just create that script in the end portion of this tutorial so that you know how to write that script for yourself, so that you can track the activity of any given directory. And if that change is made, if any new file has been added to that directory, you can just go ahead and modify the permissions recursively to make sure all the files inside that directory inherit the permissions of that directory. So that is it for chmod. And now we can move into our next portion, which is to change ownership. So you can change permissions, but you know that you can also change ownership. So how do you do that? Right, so now that we have talked about changing file permissions, what we need to talk about is another security and administrative hotspot, or a hot topic, and that is the changing of the ownership of a file, as well as the group that can access a file or a directory. So we're currently in our desktop folder, and these are all of the files that we have here. So if we do the lsla command, we can see that this directory belongs to the Kali user inside of the Kali group. And this is just a group that was created for this particular user. So I've done this thing in advance where I've actually created a new user for the purpose of this exercise, and I've created a new group for the purpose of the exercise. So what we need to do first and foremost is we need to check out who the new user is, so we can find all of our users inside of the etc password file. And so if we just concatenate that, if we cat that onto the screen, we can see at the bottom right here that we have the Hank user, and then we have the Kali user. So the Kali user is basically the user that came pre-configured with this live boot of Kali Linux, and then Hank is the person that I just added. And then this is the home directory for Hank, and then this is the shell path for Hank. And that's basically it. And this is the ID that's been assigned to him, and then the group that's been assigned to him, so on and so forth. So that is what we got for Hank. This X represents a password. Now, in this particular case, I haven't even assigned a password to this user because I don't plan on logging in with this user, or at least not yet. But we will go into modifying users and the user adding and all of that stuff in the next section. So I don't want to jump too far ahead for myself, but I'll show you how to add a new user and how to modify their password and do a variety of other very useful tasks with the user. So what we're trying to do is first we need to find out what the name of the user is, which we already established. And then the next thing that we want to find out is the name of the group. So the new group that we've done. And you can do that by going into the etc group file. And inside of that, you'll get a list of all of the groups that are available. And these are all a variety of different groups that exist. It's basically this first item right here that are all of the groups that exist. Now, the ones that we have are the Hank group, because every time that you create a new user, a group is made for that user, and that ends up becoming their primary group. Again, I'm kind of getting ahead of myself, but there's the Hank group, so there's the Kali group, right? So when we just ran the LSLA and we saw that the directory that we were looking at belongs to the Kali user inside of the Kali group, that's what that means. Each user will get their own group ultimately. And then there's the developers group, which is the one that I just created. So now we have two developers, or excuse me, we have two items. We have the actual user that was created as well as the group that was created. So we have the developers group, and then of course there's Hank's individual group as well. So that's what we have. So what we need to do is now we need to change the ownership of the files that we have here. So we're just going to keep working with this directory folder, and then inside of the directory folder we also have a couple of files that we created in the last exercise. So we know that that is the one that we want to change the owner for, as well as changing the group assignment of. So what I'm going to do is I'm going to actually start with that command now, which is chown. Chown stands for change ownership, and it's actually a fairly easy command to run. So the first argument that we need to give it is the name of the user that will become the new owner. So in this case, it's going to be Hank. And then we need to give it the name of the file or folder that will end up becoming the property of this particular person, which is going to be directory. And so then changing the ownership, oh, I see. I need to actually do sudo. So to give it a administrator permission. So then we're going to do Hank, and then we're going to do directory. And then there we go. So now we've actually been able to accomplish it. So chown, just like the change of the group, as well as adding a new user and all of these things, these are actually all sudo commands, and they require sudo permissions, meaning they need root privileges or administrator privileges to be able to run them. So we just changed that ownership. So now let's actually see if it's changed. And we do see that the directory has now been changed to the owner of Hank. So now Hank is the person that has read, write, and execute permissions on this particular directory. So the next thing that we need to do is we need to assign the developers group to be the group that owns or has access to this particular location. So that's the next main line item. But there are a few other commands that I want to make sure that I give just to kind of cover everything that we have with chown, and then change ownership, and then we'll go into changing of the group. So first thing that we ran was just the regular chown command, and that was able to change the ownership of that directory. So the next thing that we want to do is run another example of this particular command, because what we did right now, so if I actually go into the directory folder and list all of these items, we can see that the files in this particular case actually still belong to the Kali user. So the next version of this command would be to recursively change the ownership of a directory so that all of the contents within that directory also belong to the new owner that we've assigned. So recursive changes, you got to keep this in mind. If you're changing the ownership of the permissions or anything like this of a directory, and you want to make sure that everything inside of that directory also belongs to that user, or also has the permissions that you want to assign to it, you need to keep in mind that recursive is the option that you need to use, because by default, it doesn't assign that option. It doesn't use the recursive option to change the ownership of everything inside of that directory. So we're going to go back here, and then now we're going to do sudo chown, and then what we're going to do is add the capital R, so dash capital R. And then we're going to say Hank is going to be the person that's going to have the ownership. And then we just say directory in this case. And again, we just run it and everything's all good. So we have the, so we have the actual ownership of the directory that is now Hank. And then so if we went inside of this directory and looked at what was in here, we can also see that the files in here also belong to the user Hank. The Kali user is the overall owner of this directory. So that's what this stands for right here, is that this directory, which is the desktop directory, still belongs to the Kali user because I didn't change that. And then our current directory that we're in, which is represented by this single dot, this location, now belongs to the Hank user, as well as all of the contents of this directory now belong to the Hank user. So that's how you recursively change the ownership of a directory as well as all of the files inside of that directory. So now what we want to do, we can also just kind of combine a few of these things to the very next command will actually work with adding the ownership. So sudo chown, we can actually add the ownership as well as the group assignment, or developers, I think was the name of the group. So we can do this entirely and we can say, okay, so now this particular command, this very next location is going to belong to Hank, and then it's going to also belong to the developers group. And then I'll just do the same thing that I've been doing this entire time. So directory, so it says no such file, or because I'm inside of the directory, so we need to go out real quick and then just run this command one more time. And then now we have changed the group assignment of this directory as well, right? So there's actually a command to change the group by itself, but then when you combine that last command that we did right here, where you have the user, the new user that's going to be the owner, separated by a colon, and then you have the group that you want to be the group assignment of that location as well. When you do this, you can just use the chown command to actually change the group assignment or the group ownership of that location as well. But because of the fact that we did not do it recursively, so if I went inside of this directory now, and oh, see, I can't even get access to it because I just changed the permissions of it. Now I have no access to it. So the Kali user has no permission access for that directory. That's actually hilarious. I forgot that I gave nobody other than the developers group or the prime user. So I wonder if now I can actually change myself back to this. So if I do recursive and then I do Kali, let's see if we can change the permissions back. And let's see if now I can go into the directory. And I can. Okay, because I'm a root administrator, but that's hilarious. I totally forgot that I removed permissions from everybody else to be able to access this particular directory. So the first thing that I'm going to do, just to make this a little bit easier for us to manage, is I'm going to change these last permissions right here so that everybody who's not in the developers group, because the Kali user is not in the developers group yet, I'll probably add them to the developers group as well, or add me to the developers, whatever. Because of the fact that the Kali user was not inside of the developers group, we no longer have access to any of these things because the read, write, execute, and this is the user permission, so meaning the owner permission, which in this particular case, again, is Kali, but previously was Hank. And then the developers group, so I was no longer Hank because I changed the ownership of it, and I also changed the group assignment, and I'm not in the developers group. So first thing, what I want to do is I want to go ahead and I don't know if I should change the permissions or if I should just add myself to the group. So if I wanted to add myself to the group location, that might be an interesting thing. Da 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 da. We'll change the permission and I won't skip ahead because that would make me skip ahead in my command list. So I'm first just going to change the permission, and then from there we'll go to the portion where we actually add users to a group and then remove users from a group and so on and so forth. So that is what we're going to do right now, is we're just going to do the sudo chmod, and then instead of doing so instead of the symbolic, I'm just going to do the 777 because it covers everything, and then we will do directory. And now if I do lsla, we can see that also everybody who's not in the developers group or everybody who's not the owner of this particular location is going to be able to have access to all of those documents, because still I don't think I did recursive. Let's see if we did. I'm now kind of just running amok here. I did do recursive. So I did do a recursive assignment of the user to all of the files inside of this location as well. So now what we can do is we can, again, give the permission to this particular person, which would be Hank. And then we're going to give them permission to everything. No such file, because, again, I'm inside of the directory. Goodness gracious. Sudo chown. There we go. Now, the Hank user, again, is the owner of the directory, and then the developers group is the group assignment of the directory. So that's basically what you can do, right? So chown is for changing of the ownership, and then you can individually either change the owner by just doing chown, the name of the user, and then the location that you want them to own. So it could be a file, right? I could literally do the same exact thing that we just did. I could do chown, and then I could just say Hank, and then give that ownership to the doc.txt. And now if I go ahead and do LSLA again, we can see that Hank is now the owner of doc.txt. So you can do it with individual files as well as directories, and it's pretty much the same exact command. So you can do that by just changing the ownership of any given asset by just for the user, or you can combine it and do the sudo chown and then Hank and then developers like so. So you can combine this command and actually assign the group permission as well by using the change ownership. But instead of just relying on that, I also want you to learn the change group command. That is the standalone command for changing the group assignment of any given file or directory. So change group is another one of those commands that has to be a sudo command. So you do chgrp for changing of the group. And then what we can do is we can now change, for example, the group, because we also have a group named Hank that was created for the Hank user. So we can now change the group of the, let's say, the directory asset. And then now we've changed it to the Hank user. So instead of being the developers group, now we can look at it and it should say that the ownership group of this particular directory is now Hank as well. So Hank is the owner, and then Hank is the group assignment as well. Because if you remember, when we looked at the group folder, there was also a group named Hank. So we also have a group named Callie, right? Because every user also gets their own group essentially created inside of the group document or the group folder. So now what we've done is very simply, we've done the change ownership of the directory for that. But again, I didn't do a recursive command. So when we look at inside of it, we can see that the group assignment is still for the Kali group instead of the developers group or everything of that sort. Because the very last command that we did was a recursive change of the ownership of everything for this particular directory to the Kali. So what I can do now is I can go back again, and then we're going to do sudo change group Hank, and then we're going to say actually, I need to do the -r first, and then we're going to say Hank, and then we're going to do directory. And then, so now if we actually go into the directory and list everything, we can see that the group assignment, the group owner of these files, as well as the Hank group. So this could be in a variety of different ways. So just to kind of make it a little bit easier to understand, so what we can do is sudo chgroup and then do the recursive and then go to the developers group instead of the Hank group, just so you can kind of see the difference here. And then we'll do directory. And so recursive change has been made to all of the contents of the directory as well as the directory itself. And the owner or the group ownership of this directory is now developers. And then if we go into the directory and look at the contents of the directory, we can see that the files inside of the directory also belong to the developers group. So that's how you change groups. It's actually very, very simple. It's like a really kind of straightforward command. So it's a sudo command that requires the administrator privilege, and then you can just do group name and change it individually, or you can do a recursive change if it is on a specific file, right? So again, I can just go back and just to kind of give you another example of this, I can go and change the developers group for the doc.txt file. And then we can list that, and we can see that this individual file also has the developers group changed, or their group assignment has been changed to the developer. So that is essentially the combination of the change ownership and the change group commands. So this is what the commands look like. And of course, you can always just do a change own manual just to go and look at what's available inside of this thing. And there's a lot of different options. And the variety of these different flags, I think it's important for you to understand the flags. I think it's very important to know what the detailed reference of all these different flags can be and what all these different options are. But the most important thing is that if you saw a command that looks like this, where you have change ownership Hank director, if you saw this command, you should know that, oh, okay, we're changing the ownership of this directory to the Hank user, right? If you saw the the -r, you should know that, oh, okay, we're changing the recursive ownership of this entire directory to the Hank user. And then you have the change group command. And so if you see this, then you know that they're changing the group assignment of any given asset to whatever the group name is. And the first argument is always going to be the name of the group, which is in this case the developers, and then you're going to give it the asset itself, which is going to be the directory or the doc and so on and so forth. So it is very, very simple. Both of these things require sudo permission, even if you're logged in as a root user, which I am logged in as a root user, but I didn't open my terminal as an admin. So if I right click on here, I can actually, well, actually, I don't think you can even do it in the way that we were able to do it with Windows, because in Windows, you can just right click on something and open it as an administrator. So I wonder if we can do that. Open as root. So you can see that you can actually do it as a root open as well. So you should be able to do it. I just don't think I can do it from the shortcut that I have over here. I probably have to go over here, click on terminal, and then I can't open it as root. So maybe that's just one of the safeguards that's available here, or maybe I just don't know how to do it. So if you know how to do it, I'm just gonna skip asking the AI in this case. If you know how to do it, let me know. But for me, it seems like I don't know how to do it in this case, which is, I think it's actually very important because it's a really key element here. Because if we open it as a root user, then you don't have to do the sudo command or the sudo portion of the command. And then what happens is that that safeguard, that extra level of safeguard is no longer there. So somebody could accidentally just do a change group or something that is very, very sensitive to the system, and they can do a permanent change and they're not aware that they just did a permanent change because they didn't have to verify themselves by simply writing the sudo command. So when you do something like change group and then go to the command itself and you get this notification, it reminds you that it's like, oh, okay, this is actually an admin or a root user type of a command that I should be running, and I need to be very careful about what I'm doing. So this is very, very important. So the operation not permitted means that you don't have a permission to do this unless you actually designate yourself as a sudo user, unless you identify yourself as a sudo user. So that was it for changing of the ownership as well as changing the group assignment to any given file or directory. And you can always just go and look at the manuals of these various commands just to kind of familiarize yourself with the variety of different options that are available. And for the most part, as long as you know what chown and chgrp stand for, you should be good. So let us move on to now the default permissions and how to assign those or configure those. All right, so setting default permissions is actually a strategy for making life a little bit more convenient for you, especially if you're working in a high traffic environment with a lot of users that are being, new employees being hired, so on and so forth, new users coming into the system. So that is convenient, but again, you also have to be careful because if you have not confirmed what it is that you're doing, and you assign default permissions across the board to all the users that come in, for example, or the people that go into any given groups, you are technically just giving them the whatever the default permission is. And in my opinion, the lower the default permission, the better. So it's kind of like the zero trust policy where I'm not going to give everybody read, write, execute permission across all of the assets. You know what I'm saying? So we give them the lowest permission possible as the default permissions, and then just based on what their role is and the groups that they belong to, we may elevate their permissions accordingly. So that way, instead of starting with everybody getting the most permission and then having to lower them, which is rare, you start with everybody getting the lowest permission and then increasing the permissions of some people, which tends to be the more common case. So just use this sparingly, I should say. Like, be wary as you go about using the umask utility and command. So to be able to assign the default permissions, we're simply just going to say umask, and then we're going to give the permission, for example, that we want to assign. So in this particular case, what we're going to do is, so let's say you want to do the umask of 022. So let's say the first thing that you want to do is you just want to see what the permissions are, right? So you just press umask, which is this is our current value for all of the default permissions. And the current value in this particular case means 002. And so essentially what you're doing in this case is that you are subtracting 77 or 002. You're subtracting 002 from 777. So for example, let's say I have these files so we can touch and create a new file. So let's say we'll do touch file2, whatever, txt. And then we can go ahead and look at the permissions of file2. And in this case, the default value is subtracting the 002 from 666. So I think that's actually the default here. So this is 6. So you have 4 for read, 2 for write, which would be 6. And then this has not been assigned. So you're subtracting the 002 from 666. And then since you're subtracting, so this is kind of the easier way to display it for you. So if the default permission for everything is 666, meaning it does not include the execute permission. Okay, so the umask is only assigned to read and write, and it's not going to work with the execute portion. So in this case, if you have 666, that means both the owner, the group, and the others category all get read and write permissions. So if you subtract 666, or if you subtract 002 from 666, what's going to happen? Let me see if it actually does it for me. So it doesn't do it for me. But so if we subtracted 666 from, I keep saying that, if we subtracted 002 from 666, then our answer would be 664, right? So if we looked at 664 as the symmetrical or the numerical symbolic, the symbolic breakdown, then it would be read write and then read write and then read, because read has a value of 4, write has a value of 2. So in this case, this ownership, which would be the owner, this particular owner has a value of 6 for their permissions. The group assignment also has a value of 6, and then the read permission, or excuse me, the others category only has read permissions, which means that they have a value of R and then no permission to write and no permission to execute. So that's what that would look like. So if the umask is 002, that means you're subtracting that from 666, right? So that's essentially what the umask value means, and that's how you can determine what the actual umask permission, the default permissions are, okay? So to be able to assign something, so for example, now we say umask and we say 022, and that means that we want to give the group level, we want to remove their write permission, and we only want the owner to have the read and write, and then the group level is only going to have read, and then the others category is only going to have read. So if I just did that and I pressed enter, so we can do a new creation, so file3 txt, and then if we run that, we can see that file3 in this particular case no longer has the write permission assigned to the group. Okay, so again, just to clarify, just to kind of drive this point home, if you have a 022, so let me run this again. So now my umask, my default permission is 022. If I have a 022, that means I'm taking the overall value. So it doesn't work with 777 because 7, that final number, is the execute permission, and the execute permission is never assigned by default. Only read and write are assigned by default. So if we have just the default availability would be read and write for everybody, the owner, the group, as well as the others category. If you subtract 022 from it, then what happens is that the owner will have a read write, the group will only have a read permission, and then the others category will also only have a read permission, which breaks down to 644, which again is the user, the owner will technically, so it'll be read write. Well, actually, it's either a directory or a file, right? So it would either be this read write execute like that, or it would just be that representing just a file. So that would be read write and then no execution. That would be for the owner. And then we have read, no writing, and no executing for the group. And then we have read, no writing, and no executing for the others category. So this is what the permission would actually look like. And if we actually went and looked at our specific command here, we can see that the file3 that we created exactly has that. So the user, the owner, has read write. So me as the administrator, by default, I have read write, and then the execute permission has not been assigned. And then there is read, and then no write or execute permissions for the group that's been assigned to it, and then read and no write or execute permissions for the others category that's been assigned. And that's basically it. That's how umask works. So you can assign this by just saying umask to whatever it is, or you can assign it temporarily in a session. For a permanent change, you would have to go to the shell profile to modify the actual bash RC file. So if you wanted to make that permanent change, you would go into the bash RC file and assign this umask value that we just did. But what I just did right now is going to be applicable to this particular shell session. So just to display what that means, right? So I'm going to say that this is 022 for this particular shell that we're in, and I'm going to close this shell, and I'm going to open up a new one. So we'll just open up this new shell that we have over here. And then this is technically a new shell that I have over here. And so for this particular shell, that's kind of, I would say it's too big, right? So let's see. I feel like I've gone too crazy with the zooming in. If I do umask in this case, now we can see that in this instance, we have 002 instead of 022, which was assigned to our other shell, to our previous shell. So if I close this one, now I'm inside of the shell that has a umask of 022, and then I can just change this back to 002 to reset everything back to what it was default. And that's it. That's all we got for the umask value. So it's important to understand what it actually means and how to calculate what the default permission is. When you say 002, that, I mean, it doesn't make sense. It's like, what do you mean? So the user doesn't have read, write, or executes, you know what I mean? So it's like what you're doing is you're subtracting that value from the 666 value, which represents read, write, and nothing else. So 666 looks exactly like this. You have read, write, and then nothing, and then read, write, nothing, and then read, write, nothing. That's the full 666 representation symbolically. Now, if you have a mask of 002, then what you're doing is doing 666 minus 002, which would equate to 664, right? That's would be the representation of that. And then that in symbolic value would be read write like this, and then you would have read write like that, and then you would have read, and then that would be it. So that would be the symbolic representation of the permissions when you have a umask of this in this case. So any file or directory would be created with this type of a permission. The directory actually, so the directory permission is 777. So I'm glad I caught myself. So these are the permissions, the default permissions that are assigned to a file that starts with 666. When the default permission is set to whatever and you're creating a new directory, it's actually 777. So this is, I'm so glad I caught this. So the 666 only applies to files. I apologize. I should have said that at the very, very top of this. If I create a new directory, and we have, so let's do this one more time and do umask. So we have the umask 002. That's our current default setting. If I make a new directory and we'll call it dir2, and then we do an LSLA to look at the dir2 permission, we can see that read, write, and execute is assigned, meaning that's the 7. So read, write, execute has a numeric value of 7, read, write, execute another numeric value of 7, and then read is 4, execute is 1, so the value for the others group is actually 5. So this would be 775, the numeric representation of the directory. And so if you do, if we wanted to do the calculation for the directory, it would be that the overall permission would be 777. And if you have a umask of 002, which is our current umask, then what is going to be end up with is 775. That would be the numeric representation. So if we're looking at a directory that has a 775, the first would be D to represent that as a directory, then it would be read, write, execute, and then read, write, execute to represent the second 7, and then you read, dash for the right, and then execute, that would represent the 5 at the end. So if I change the umask to 022 again, so let's do that, right? So we do umask, and right now it's 022 or 002. Now we do umask. Let's do 022 to just remove the right, and we can actually even go a little bit further, right? Let's say 033. That would be our new umask, which means you take 777 and you minus 033, which would only give the overall user. So here we go. That's what it is. Make dir and then dir3. And now we can clear the screen and do lsla. And we can see the third directory that's been created, only the owner has 7. The permission in the middle was 7 minus 3, which is left with 4, meaning that there's only a write permission, or excuse me, a read permission on that directory. And then same thing, minus another 3. So 7 minus 3 would be left with 4, which would be a read permission for the others category. So that's how that works. So I think hopefully by now you understand what that actually means and how this whole thing works out. So I'm going to change my umask back to 002 just to default it to this particular session being what it was normally. And that's basically what it is. So for files is 666 minus the umask value. And then for directories, it would be 777 minus the umask value. And then that's how you can determine what the default permissions are for any file or folder being created. So it's very, very useful command. You just use it, cautiously to make sure that you don't give people the maximum amount of permissions on new files or folders that are being generated, so that you approach this whole thing cautiously. Zero trust is one of the common approaches to cybersecurity in general and security in general. So it's like the least amount of trust, and then trust is upgraded and privileges are upgraded according to a person's seniority and their management level, administrative level, so on and so forth. So that's what we have for umask. All right, one last line item here, and that is the command to view file permissions. Now, this we've done so many times throughout this particular training series in a lot of different contexts, and I just wanted to kind of dedicate a specific short little section to show you how to view file permissions if you haven't already caught on by now. So when you do the ls command, it lists the items inside of the current directory. When you do the ls-l command, it will list them with their permissions assigned at the very end right here. And then when you do the ls-la, A represents all, of course, so it will list all of the hidden directories and files as well. So in this particular case, on my desktop, I don't have anything hidden other than the command to go up a directory, or the command for the current directory, which is represented by these dots over here. But ls-l, for the most part, as far as you know, is the command that will display the permissions of any given file or directory. And you can apply this to everywhere. So if we went to the desktop root, for example, or if we went to our system root and we have all of these portions, if I just do lsl, we can see that there's a variety of different permissions that are available for all of these people as well. So for example, my bin, my binary location, very, very dangerous here to actually have read, write, and execute for the system binaries for the owner, as well as the group that's been assigned, as well as everybody else. So it's like, okay, root owner, sure. The root group, sure. But everybody else, do they have read, write, execute permissions on the binary? No, they probably shouldn't have read, write, execute permissions on the binary. Same thing on the system binary, where it's like, okay, well, the system binary is the most sensitive location, because the fact that this is what the system actually depends on. If one of these binaries stops working, the operating system stops working. So I feel like people who are not developers, or people who don't know what they're doing, which is technically everybody outside of the root or the let's say the developers group or something like that, IT or something like that, nobody else should have access to the write and execute. Maybe they have access to read, but not to write and execute the system binary permissions. Actually, no, you know what? I stand corrected. So the execute, they should be able to run system binaries. They should be able to do that. They should also be able to run binaries. So for example, the ls command is actually a binary. The system binary is more relevant to the system operating. So systemctl, for example, that would be a system binary. But for somebody to be able to run cd to change a directory or to run ls, those are regular binaries, and they should be able to do that. They should be able to execute that. I don't know if I want to give them permission to write or modify those binaries, but they should definitely be able to execute them. And then similar to the system binaries, I feel like everybody should be able to, for the most part, run the system binaries, but they shouldn't be able to write or modify the system binary files, which is very, very important. So this is just how you view permissions, right? You just do ls_l, and it gives you the permissions of the contents of the directory that you are in, and that's basically it. So very, very simple, and hopefully that actually makes sense to you because we've done it so many times throughout this training series so far. So now we can actually move on to our official next segment, which is the user and group management portion.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, so now we can get into the user management portion of this, user and group management, which is the adding, modifying, deleting users using the user add, usermod, and userdel commands. So this is another one of those items that ends up being a common approach for somebody who's going to be a system administrator. And if you want to add a new user, the basic syntax is going to be a sudo because it is an admin command. So you're going to do user add or add user. It just depends on the distribution of Linux that you're running on. So it's either user add or add user. And then you would essentially just give the name. So for example, I could do John just by itself, and now I've added the user John. And by default, the system will create a group for John, which would be named John as well. So every single user gets their own user group, which is essentially the name of the user. And that ends up being their primary group. But a lot of times you want to change that primary group for that specific user and assign it to whatever their primary group needs to be. Or for example, home folder you would want to assign, or you want to add a comment, or so on and so forth. There's a lot of different things that you would want to do with a new user, and you can string together all of the options for that individual user by just creating that first initial command and then adding all the options that you want. So some of the most common options, for example, would be a C-C to add a comment. So in a lot of cases, it won't be, Hank Hackerson as the person's full name. It'll be Hank H or H Hackerson or something like that. So that will end up being the person's username. But what you want is to know their full name. So typically you would put their full name inside of the comment section, and maybe you'll even put the departments that they belong to inside of the comment section. So -C, and then you would put everything inside of a string value inside of quotations, and that would end up being the comment. -D would be their home directory. So in a lot of cases, the system will typically just create their home directory on the /home and then / the name of the user. But if you want that home directory to be different, you would designate that with -D for the home directory. The defaults would be essentially, if you change the default values, you can assign exactly what you want the defaults to be. But if you just do a capital D, then it'll do everything for the defaults that has been previously assigned. And we won't get into how to change the defaults, but there is a subsection called changing the default values that you can go through to be able to change all the defaults, so that whenever you just add a new user, you can just say user add and then do -D, and it will add them with all of the defaults that you previously designated. The expiration date, so if it's a temporary user, like for example, a vendor who's coming in to work with you and you don't want to worry about whether or not this person is going to have permanent access to your system. As soon as you create it, you know that the guy is going to be there for a week. So you set the expiration date to be 7 days from the date that you've created the user. And then so within 7 days, that user is going to be expired and no longer available. So it's going to be a disabled account as soon as those 7 days are done. If you want to make that person inactive, you would just do the dash F command. If you wanted to add any kind of sub IDs for the system, you would do the capital F. The G ID, the group ID, which is one of the common ones that's added. So if you want to do a lowercase g, that's the primary group. So the primary group's assignment for that user will be done with a lowercase g, which is very common. This is one of the common commands that's used as well. The capital G is for all of these supplementary groups that you want to add to this person to, which is another one of those things that's very common. So for example, let's say bank teller as well as the Beverly Hills location. So let's say you have these two groups, and so you want the primary group of the person to be a bank teller, and then the secondary group would be Beverly Hills, and that would be the secondary group or a supplementary group. And then you can just have multiple supplementary groups. So for example, if that person becomes a supervisor, they should have all of the access that tellers have, but then now you want to add them to the supervisors group as well. So you can do their primary group would end up being supervisor, and then their secondary supplementary groups would also be tellers as well as the Beverly Hills location. So you can assign essentially as many supplementary groups as you want, but there's only, of course, one primary group. So lowercase g is for primary group, capital G, uppercase G is all of the supplementary groups. And then just a few other commands that are actually fairly useful in this particular case. The dash M ends up being the create home. So it'll create a home folder for this particular user. If you do a capital M, it will not create a home. If you do a capital N, there will not be a user group. Then what else do we have? Password. So dash P is another one of those things that you want to set an initial password for this particular person. So, and this requires an argument to be fed into it. So if you do dash P, you need to actually, in the very next couple of characters, you would need to put the password inside of quotations so that you assign that temporary password for this user, and so on and so forth. I think for the most part, dash S is also good to give them the shell, the path to their actual login shell, which for the most part is also just set by the default of the system, and they end up being able to use just a default shell of the system. And that's it. So those are the most useful options that comes with the user add command. And so what we're going to do now is we're going to create a couple of versions of this. As we mentioned, the capital D is for defaults. So we're not going to do the defaults because I do want to kind of teach you how to do these things manually for yourself, and then you can kind of mess around with changing the default values. The changing of the default values are right here in the subsection that is assigned as changing the default values. So for example, the dash B would be the base directory. So instead of doing a dash D for their dedicated directory, you can just do a dash B and then assign the variable for the base directory that will be applied to everybody, and then the expiration date, and then the inactive mode, so on and so forth. So these are all of the things that you can have as your default values, and you can see that they're not a lot. So there's the dash capital D essentially will do the shell, the group ID, the inactive value, the expiration date, and then their base directory. Those are typically the only values that are available that you can modify when you do your default configurations. Apart from that, everything else does have to be manually changed or added. Now, what happens in this case is that because of the fact that in some environments you have to create a lot of users, a lot of this is done with scripting. And I actually did create a script. My version of the script is not a shell script, it's a Python script. So we're going to create a version of this script when we go into the shell scripting portion of this training series, so that you can actually have something for yourself. So whenever you do go into the system administration and you become the system admin and you're creating users and groups and so on and so forth, you have a script that'll do it for you that will do essentially a lot of these options, and then it'll prompt you to provide the values, and it'll become like an interactive session, and you won't have to run a bunch of different commands. And then on top of that, you can actually just tell somebody who you're training, hey, just simply run this script, and the script is going to ask you what the values are that you want to assign, and then from there you know assign the username and their password and all of these other pieces and like a comment and all of that stuff to just make it user friendly for a new system admin or like a junior admin to come in and to be able to create users without you being present, because the shell script pretty much does that for you. So that is all of the options that we have for user add. So let's actually kind of go through it a little bit and create some modification, or just a new user. We'll create a new user and then we'll modify all the various parameters of this particular user using all of the options that we just covered. So let's get into it. So user add is the command that we're going to be messing with for this particular section. And one of the things that I wanted to show you, so if we go up one level and if we run an ls command, we'll see that for our Hank user, there actually has been a home directory that's already created. So typically you don't have to do that. And the Hank user is the only person that can actually have access to their home unless you do a sudo cd of Hank. And now I can go in and you can't even do that actually as the sudo root. So cd is not a command that can be ran with sudo. And typically, because the fact that Hank is the only person that can access their root folder, I can't even go into Hank's folder, which is actually very interesting. So I can only go into my Kali folder, which is what's been assigned to me in particular. Now, what I can do actually is I can go over here and do lsl and run it, and we can see that, okay, only Hank is the person that's allowed to read, write, and execute. And let's see if we can actually change the permissions of that. So let's say we can do 777, for example, and then do Hank. And then let's clear this and then see if we can actually, now we can go into Hank's. There we go. Ha. Now I can go into Hank's directory. And if we go inside of his directory, we can see that there's literally nothing inside of his directory because it hasn't been fully designed yet. So what we're going to do is the new user that we're about to create, we're going to do the the M command allows us, as the M option allows us, it'll create their home directory and hopefully actually populate their home directory to give them their documents and everything else so far and so forth. So let's first run the very first user add. So it's going to be sudo user add, and then we're just going to do -m to give them their home space. And then from there, we're going to do John. And then from there, we're going to press enter. So if I go back one, we'll see that now we have a John directory that's been assigned to the John user. And then if I actually do the cat etc password file, I should see that there's a new user at the bottom that's been created that is John. And now their home directory is home John, and then the bash directory, their shell, has been assigned to bin shell, which is typically what that's like. The binary shell is what everybody kind of gets access to, unless you want to just duplicate it and give them their own shell. And then in their shell, they have certain permissions that they can run or they can't run. So for the most part, this is what we have so far. So we created this John person, and John has their home directory, right? So the next thing that we want to do, if we wanted to change it, we could just do it with the sudo user add and then do -d, and then we can change their home directory. But in this particular case, I actually like John's home directory, and we'll just leave it at that. So the next thing that we want to do is look at kind of the other options that we can assign to John specifically for this user. So I am curious, if we run user add and then we want to add the comment for John, if we can actually do that. So I wonder if we do it with the user mod or the user add. So we're going to do user add John Smith, and then we're going to give the John user, and it says John already exists. So I can't actually add a comment to John because John already exists. So if I do sudo userdel, and then I'll do John, I can actually delete the John user, but now I need to make sure that I delete their folder as well. So I need to go ahead and wipe that whole thing. So I can do remove dir, or I could just do remove and then just do it R, for example, to be a recursive, and then just remove John. So we can't, so okay, sudo remove -r John. And now I should be able to, okay, so we've removed that. And the group deletion also needs to take place because we created a group. So if I go to the cat group folder, we can see, actually, no, because we deleted the user, it also deleted his group that was assigned to it. So that's all good. But sometimes that doesn't happen, and any other group that was created, especially if it's not their primary group. So if I change their primary group from John, because when that happens, they get their primary group assigned to the actual username. If his primary group was developers and then his secondary group, his supplementary group was John, once I delete him, I need to actually also delete that supplementary group named John. But in this particular case, we didn't have that. So as soon as we deleted the user, their primary group was also deleted, which was the John. So now we only have the Hank user as well as the Callie user. And just to, I guess, let's kind of go into the overall, just kind of start from the very beginning, right? So let's do userdel, and then we'll delete the Hank user as well. And then we still have his folder, so we need to do remove dir or remove and then recursively delete everything inside of that. So now we only have the Callie home folder. And so if we just check the Etsy group, there should be no Hank. There we go. We only had the developers group that we created earlier. And then if we check the Etsy password file, there should also no be Hank. There should not be a Hank at the bottom, which there isn't. So we are at base level. So we're at the very beginning. So now what we can do is we can create a brand new user and kind of modify a few of these things. So as we covered earlier, we have these various options that were available for us inside of the user add command, right? So the -m will do the home directory if we don't want the home directory to be something else. If we want it to just be their actual username that's inside of our home partition, we would be able to do that. If we want to change the path to their home, then we would do -d, and then we would give the dedicated path to their home directory. And again, it wouldn't be /home/username, whatever their username is. So these two we're not going to mess with. I'll just do -m to actually assign their home and create a directory for them. The next one is going to be the -s command. And because it's the bin bash or bin zsh for us, I'm not going to mess with this either because I just want it to be the same exact shell that they get access to. So we don't need the s command for our command. The comment, I'll actually add a comment and I'll give the full name for the new user. So we will have -m and -c so far that we're going to be using. -u would be the user's ID. Typically, the system will just increment by 1 for every new user that comes in. So you don't need to change this if you don't want to. And for the most part, I think most people don't change it because the system just increments by 1. So the user after this would be 1002, and then after that, and so on and so forth. And it just keeps going up until whatever, I don't know, infinity, I guess. But it'll just keep incrementing each user by 1, and then that UID would change by the increment of 1. The group is something that is very important. So if we want to find or if we want to dedicate the initial group for the user, we can dedicate the primary group to be changed for this particular person. So the lowercase g will assign their primary group. Now, in our case, I'm not going to do that because it's going to create more work for us in the back end, but I will do the capital G, where I will assign our person to the developers group. So I'm going to create the new user and I'm going to do a capital G, and then I'm going to assign them to the developers group so that it can be the supplemental group, the additional group for the new user. And then we're going to add their password. So in this particular case, this is an encrypted password command right here. So you can do the OpenSSL password -1 and then give it a password. And in this case, the password itself would be the plain text, and then OpenSSL is going to encrypt that password for the user. So this is a useful command to have in our particular case. And if you wanted to kind of keep note of this, I would pause this and I would copy and paste this for myself if I was you. You don't have to if you don't want to, but I would if I was you. What I'm going to do in this case is I'm going to do a -p, and then I'm just going to use an unencrypted password, which is just going to be the plain text that we're going to put onto the screen. And then that's going to be the case. And then what happens is that in the aftermath, once the new user logs in, and I'll show you again how to do this, once the new user logs in, they will be prompted to change their password. The expiration date, I'm not going to change because we're just going to manually delete this person. And then -F would mean that there would be inactive. So if the number of days after a password expires until the account is disabled, that's what the inactivity period would be in this particular case. So if the password has not been changed after 30 days, then this particular user is going to be marked as inactive. So if this is an employee that went on an extended vacation and then they came back after 30 days and they needed to activate their account, that's because the inactivity period was already set for them. So after 30 days of them being inactive and not changing their password. So this doesn't mean that if they haven't logged in for 30 days, if they haven't changed their password after it's expired for 30 days, then their account becomes disabled, and then the system admin will need to reactivate their account. So re-enable their account, okay? So this is all of the most relevant options that we have. So what I'm going to do is I'm just going to use the -P to assign a password, -G to assign them to their supplementary group, and then we're going to do a -C to give them a comment, to give them their full name, and then the rest of it is going to stay the same. I'm just going to do -M to make sure that they actually get a home folder as well. So we have -M, -C for the comment, -G for their supplementary group, and -P to assign their password. So here we go. We are going to do a sudo user add. And let's see, we are going to do a specific user that we have not done before. So we'll do Jill in this case. So we've never added a Jill before. So sudo user add Jill is going to be the person. We're going to do -M to give them, or maybe I should do all of these things in advance. So we'll do -M to give her a home. We'll do -G to assign a group for her, which is going to be the developers group. We're going to do the -C, which is going to be her name, which is the comment. And then what was the other one? -P. So we got to give her a password as well. And the password is just going to be password in this case. And then the username, which is Jill. Press enter, and that's done. So now we've created the new user. We've given them a home. We've added them to the developers group. We have Jill Smith as their comment, -P for their password, and then we have the new user Jill. So if I do ls, because I'm already inside of the home partition here, if I do ls, I should see there we go. That's her home. And that's all good. So now what we need to do is we need to go ahead and check the other variables that we have. So we need to check if she's actually been added to the developers group. And then I need to check to see if the comment is also available for her username. So let's go and check all of those various parameters. All right, first and foremost, just to see some of the parameters of this particular person, we can always try to go into the etc password file because there are some, essentially all of the contents that are assigned to the user, for example, the comment. So Jill Smith would be the comment that's assigned to it because that was the full name that we assigned. This is the home folder that we have over here. So we can get the comment for her just by looking at the etc password file. There's also a command called get.ent that will show us the contents of, or entries. So getting the entries of the password file, and then we just get Jill's entries, and then now we can display only that person's entries on this particular case. So if I did get ent password file, and then I did Jill and then Callie, I don't get both of them. So I only get one individual user at a time. So the get entries command is a very useful command that will look at the password file, and then it'll look at Jill, and it'll pull the entries for Jill. In this case, it's going to be her username, the group her UID, the group ID, and then of course the comment, her home location, and then the shell location that she has. The password, as you can see, this actually represents the password. The X here represents what her password would be. So we'll never see the actual hash value of the password because that's stored in a different file. So if I actually did get ent shadow, because there's a shadow file that stores all of our passwords, and then did Jill, it actually won't show it to me because that's a very sensitive file. So I shouldn't be able to do it. So maybe if I run it as the sudo, let's see if that'll show it to us. And it does. So her password in this particular case is the word password because we never encrypted it. Okay, so keep that in mind. So if I actually go into the cat Etsy password file, or excuse me, cat shadow, if I go into the Etsy shadow, because it's permission denied, if I do the cat Etsy shadow as a pseudo user, we can see that, so if we go at the very, very top right here, we can see that the shadow file does not display the password of these users because of the fact that either they're encrypted or we've been forbidden from seeing it, or they're just essentially placeholder. So there's no new password that's been assigned, so it's the default password that was assigned to the system. The Kali password in this particular case, this is the hash value of the Kali user. So the root user doesn't show me anything. The Kali user actually shows me the hash value of their password over here, which means that that actually has been encrypted, because I know for a fact that that's not the password that I use to log into the system. It's the default password for Kali, which is Kali. So when you just start up a very brand new version of Kali Linux and you log into it for the very first time and you don't do any configurations, the password is Kali. That's the default password for Kali Linux. So the user will be Kali, password will be Kali, but the hashed version of Kali as a password is what this looks like right here. And in this right here, as you can see, Jill password, this is the plain text password that we assigned to Jill, and that's a very big no-no. So when you actually do assign these passwords, what you want to do is you want to make sure that they're encrypted, and then they obviously change their password the first time that they log in and they get assigned a new password. So that part is really, really important to understand. But for the most part, this is where we can see their password. And then when we look at the cat Etsy password file is where we can see the comment and everything that's been assigned to them. So now what we need to do is we need to see if she's actually been assigned to the group that we want her to be assigned to. So we need to see her group assignments. And it's a different, there's actually, I think, 2 commands that we can run to be able to check to see what has been assigned to her as her group. There are 2 ways that we can do that. So we can actually just do the groups command, and then we can give the user, so groups Jill, and in this case we have her primary group, which is Jill, that was assigned or created when we created her, and then the developers group, which is the supplementary group that I assigned her to. So that's one way that we can do it, is we can just run the groups command and then give it the username, and now we can see what group she belongs to. The second way that we can do it is with the get entries command that we ran earlier, and then we're going to look for the group file, and inside of that we're going to pull the entries for Jill, and then it's going to give us essentially the group ID that she belongs to, which in this particular case is her primary group, which is Jill. So because that was the UID that was assigned to her user, so the group ID for her is also going to be the 1001, which is the group ID that was assigned to her primary group, which is Jill. It's not going to give us everything like the developer. So if you actually wanted to see all of the groups that she's been assigned to, you would do the groups command and then the username, and then it will show you all the groups that that particular user has been assigned to. We can actually get the entries of the group developers, which is what we had, and then pull that, and then we can see that Jill is the user that's been assigned to that. So if we pull this particular portion, what we're doing, and this is again my bad on the explanation on that, when you do the get entries of the group file, it's actually looking at the group named Jill. So because we have the Jill group that was created when we created the Jill user, we actually are looking at the entries inside of the Jill group when we do this command right here. So if I wanted to verify who's inside of the developers group, then what I can do is I can go ahead and get the entries of the developers group, and then now we can see that developers group has actually the Jill user that's assigned to it. That's why over here there's nothing at the end, and I completely misread that, so that I apologize. I left that in here because I wanted you to learn from the mistake that I made, and I didn't want to kind of just delete that portion. But when you do the get entry group Jill, you're actually getting the entries of the Jill group. So if I have the developers group, that means that my particular user that I'm looking for will be inside of the developers group. So let's actually go ahead and add the Kali user that we have over here to the developers group. And then what we can do is recheck the developers group to see if we have the Kali user inside of it. And this is actually the perfect segue to go into the usermod command. So we're going to be modifying our current user, which is Callie, and then we're going to add them to the supplementary group, which is going to be the developers group. So this is another sudo command that we need to run. So it's going to be usermod, and then we are going to append or add to the supplementary group, which is going to be a capital G. So we're going to add the supplementary, we're going to add this particular user to the supplementary group. And then we need to actually give the group name, which is going to be developers. And then we need to give the username, which is going to be Callie, and we're going to press enter. Now what I can do is I can go ahead and again do a get ent of the group of developers, and hopefully we'll see that Callie has also been added to the list of the users that is inside of the developers group. So this is how you modify a user. So this there's a lot of different ways that we can modify a user. This is just one of the commands that we can run, which is add them to a supplementary group, and then you give them the following argument after that is going to be the actual name of the group that they're going to be assigned to, and then you would provide the username, and then boom, they're assigned to that group that you want them to be as their supplementary group. So that is the very first portion of what we can do with a user modification. Now, what we can do is we can technically just change somebody's username as well. So let's say I want to change the username for Jill. So I can do sudo usermod and then do the -l command or the -l option. And the new name was going to be J Smith, right? So Jill Smith. And then the current username that we're changing is going to be Jill. And I press enter. And now we should see that if we did the get nt group developers, there should actually be a new change here, which is J Smith. So J Smith instead of Jill is now the user that has been assigned to the developers group. So user mod with the L flag, with the L option, will change the username of the person. And so the very first thing that you do is the new username that you want them to have, and then the name of the user that you are changing. And then we can do this essentially with every other option that was available when we were creating the username, right? So if we do the, and I'm just going to change this for now, but if I did the usermod, so sudo usermod -d, and then I wanted to change, because if you remember, -d is their dedicated home folder, their home directory. So if I wanted to change their directory, I would do it with the usermod command. I would do -d, and then I would provide the path to the directory, and then this has to exist. So if this directory doesn't exist, it's going to give you an error. So this directory, the new directory, has to exist first before you assign that to the new user. And then I would say that I'm changing the user, so which is J Smith here. I'm modifying her directory here to this particular location, and we do that with the -d option with usermod. And that's one of the main, those are like some of the main things that you can do with this particular command. And of course, if we just do the usermod manual, we can look at all of the other stuff. So append is something that you can combine with something else. So you can append them to the group. So if we go to the capital G right here, this is the list of the supplementary group. So I can append them to the supplementary group. If I change their actual group itself, I can do it with the lowercase g. So if I wanted to modify their primary group, I would do it with the lowercase g. And then now I've changed their primary group. Now that is not going to be an append command. So it's not going to be a capital G it's not going to be a lowercase g. So it's going to be -g, and then you change their primary group to whatever the group name is going to be that you're going to designate after the fact. -d would be changing their home directory, as we saw. -c would be changing the comment that's to her name. So let's actually go ahead and do that, right? So we can go ahead and do sudo usermod and then -c, and then we're going to say Jill Smith developers, right? And then we're going to now say J Smith. And there we go. So we modified her comment. So if we go ahead and do a get entry of the password group, and then we get J Smith, we should now see that she has a new comment here. And of course, even in the password file, her username has been changed. And so Jill Smith, developers. That's going to be the comment that's been assigned to Jill Smith because we just immediately modified it using the usermod command. So it's very, very useful. It's a very useful command, as you can see. So we can go and look at some of the other options that we can over here. So the home directory we can change. I don't want to do it, but you can do it by doing -d and then just the name of the directory, the path to the directory. We can inactive her, so we can say the number of days after the password exceeded is the maximum age during which the user may still log in by immediately replacing the password. So this grace period before the account becomes inactive is stored in our password file, which would be, for most people, it's going to be 7 days. So you'll give them 7 days after their password has expired. And if they don't change their password in 7 days, their account becomes inactive, and then they have to go contact the system administrator, and the system administrator is going to give them a lecture, so on and so forth. But for the most part, in every single company, they give you a grace period of 7 days after your password has expired before your account becomes inactive. So you need to make sure that you actually change your password after your password is expired. And it actually pops up, there's like a little pop-up that comes up to the screen that your password has expired, you need to change it. You don't change it, the next day you log in, your password has expired, you have 6 days to change it. Again, you don't do it. Now you have 5 days to change it, 4 days to change it, and then all of a sudden your account becomes inactive. So the inactive flag is also very, very useful. And you can just do that, right? Usermod -f and then the number 7, and then it'll set their inactive period to 7 days. The lowercase g would be their primary group, so you don't need to do an A lowercase g. You could just do lowercase g. A capital G would be the appending to the groups, the supplementary groups. Their login is what we changed when we took it from Jill and made it J Smith. So we're creating the new user login by doing the -l. Dash lowercase, or excuse me, dash capital L. This is a very useful one. Dash capital L will lock the user's account. So it'll lock their password because essentially, for whatever reason, so let's say we have a script set up that says if they have 3 wrong password tries, and this is something that you can do in configurations for the management of your user. So you put that inside of your configurations folder, and you have this script that says if any user has 3 wrong password attempts, I want their account to be locked. And you can also obviously manually do this. So if somebody gets fired and they have access to sensitive information usually, and you don't want them to have access anymore, as soon as you get the fired notice, you immediately lock their account so that they're no longer able to log into their computer, and then they can't access sensitive information and steal it from the company, so on and so forth. So you can either set up a script that will lock their account automatically if they have multiple incorrect password entries, or you can just manually lock the account by doing usermod -capital L and then providing the username, and then it will change and make their account locked. -M will move the content of their home directory to a new location. So this would be if you wanted to change their home directory and you want to modify transfer all of the contents of their home directory to the new location. This is, I mean, it's kind of weird in my opinion, because this shouldn't happen unless like you're doing a complete system reboot or revamping of your infrastructure. You should not need to do this. If you are, again, like if you are, for example, taking all of the users' home directories from the /home/username, if you're taking all of them from that, and then now you have a new section in your file system that all of the users' home directories are going to be stored, in that case, you would need to transfer everybody, and then that needs to have its own script because it's going to be super tedious to manually transfer every single person to that location. So that's one of the things that this shouldn't really be needed unless you're actually doing a revamp of your entire file system hierarchy, which is a pain in the ass unless you actually know how to script. The password, the lowercase p, is going to be the definition of a new password. So if we wanted to change their password, we can do it with the lowercase p. And then there's something that you can do to expire their password. I wonder if I passed it already. I don't think I have, because this is in capital, or it's in alphabetical order. So let's see if we can go find the expiration date. The last user account will be disabled. The password expiration is actually what I'm interested in. I think we actually do that with the password command. So I don't think we do it with the usermod command. We can expire their password, meaning if we assign a temporary password to them, we can expire we can expire their password immediately after we've assigned a temporary password, and then the next time that they log into the system, they'll have to reset their password. So I'll show you how to do that in a minute. So the lowercase p is just to assign the new password, and then we would use the password command to expire their password so that they can go ahead and work with it. The lowercase r will remove them from any supplementary groups. The capital R will actually change the chroot directory. Oh, whoops. What did I do? Where did I go? Oh my gosh. Okay, I have made some kind of a mistake. So let's see if we can get out of this. That's interesting. I think I actually clicked on something that I should not have clicked on. And I think like some of these things are actually clickable inside of the manual, and I may have clicked on something that I should not have clicked on. So let's go down to where we were with the root. So I think it's the chroot something over here that I clicked on, and then it opened up the chroot file. Maybe that's what happened, because that was very weird. I've never actually seen that before. But as the capital R would apply the changes in the chroot directory and use the configuration files from that directory, and only absolute paths will be supported. So their root directory will be changed. Capital P will be for the prefix. The S we already established, because we can do that also with the user add. So you're changing their shell, the system shell that they can get access to. U will be their UID. Capital U will unlock them. So capital L will lock them. Capital U will unlock the user. Sub UIDs could be done with lowercase v. Deleting of the sub UIDs can be done with the capital V. W would be adding any more sub GIDs, group IDs if you wanted to. So lowercase w will be adding the subgroup IDs to them. And capital W will be deleting the subgroup IDs. And then the capital Z will be adding them to the Linux, the secure and Linux application, which is actually very, very useful. So the Linux range, these are, again, this is kind of beyond the scope of this particular training. You're more than welcome to get into the depths of this particular command by looking at it. The only reason why I'm showing you all of this is because these are actually very, very important commands. And the user add and the user mod and the user delete and then the group add, group modification, group delete, all these things are very, very important commands that you're going to run into. So I don't want to skim over any of this stuff. I want to actually show you what these commands are and what all the available options are. And the ones that I showed you within the actual command line itself, for example, appending them to a new supplementary group, that's something that you will actually have to do, and it's something that you need to learn how to run inside of the command line. Most of these things I don't want to do because the cleanup of this entire exercise is going to be a big pain in the butt. But we can actually change their home directory. I mean, I'm just kind of beating a dead horse here, but there's a lot of things that you can do with the usermod command. And if you want to get a lot of applications for this particular command or the user add command or anything like that, you can always consult with the various AIs that we have so that they can give you a bunch of sample exam, not exam commands, but sample commands that you can use throughout your activities, and it'll just make your life, like the practice portion of this is so useful. And you're not going to become a master by just watching this tutorial and then applying these commands a few times. You're going to become a master by going through all of those options in a controlled environment. So for example, a system that can be booted from a USB drive like I have right now, and then just creating these users and creating the groups and deleting the users and just going back and forth and doing everything that you can to really get this stuff to kind of hit home for you. And the more you practice, the better you will be. That's basically all I'm going to say. I don't think you're going to become a master by just watching this video once and doing these series of commands that we've already ran. So now that we have covered the user mod, the final thing that we're going to cover in this case is going to be userdel, which is to delete the users, of course. So let's go into userdel. I already actually showed you how to use this command because we already went to the etc password file and we deleted our John user and we deleted the Hank user. So you already are very familiar on how to use this. But finally, what we're going to do is we're just going to delete our JSmith, our Jill Smith user. So it is a sudo command as well, and you're going to do userdel, and then you're going to just delete JSmith. And just like that, JSmith is gone. Now, the folder that she had is still here. So this is very important to understand. It's not going to delete that if you just use userdel by itself without any of its extra options, it's not going to delete them. So if we wanted to remove their home directory and all the files and everything, we would use the -r command as well, right? So it would be the same thing, userdel, and then we would do -r and then jsmith, but she's already gone, so there's no going to be a user that exists for that. But if you do a -r, so if you do sudo userdel -r and then give the name of the user, the -r, the recursive version of that, is going to delete everything, meaning it will also delete their home folder. So you don't have to come over here and then do a remove -r of Jill, right? And then delete that freaking location as well. So in a lot of cases, in every single case, in my opinion, if you're using the user delete and you're deleting user, you should always do the -r command so that you can recursively delete the user as well as everything that is sitting inside of their home directory. So that is it for userdel. This one is actually probably the easiest one to go over, and then you can go look at the manual for userdel to look at everything else that they got. So for example, force the deletion if you're getting some issues. -r would be the remove. So it stands for remove, but I've associated -r to recursive, but -r would be to remove everything inside of their home directory. Capital R would be the ch root changes that were previously done. Capital P would be in the prefix directory that was previously done. And then capital Z would remove them from Selinux if they were in Selinux previously. And that's basically it. That's all we got for the user add, usermod, and userdel commands. All right, so changing passwords is going to be a quick section, and it's one command that we're going to learn, which is the password command. And the password command has a variety of different options, obviously. I've already kind of mentioned a few of them, but just starting from the top. So if you wanted to change the password of your user that you're logged in as, so for example, me wanting to change the password of the Kali user that I'm logged in as, I would just type passwd and I press enter. And it's going to say, okay, you're changing the password for Kali, and then enter your current password. And then let's say I'll do that, and then new password, and then you would give it the new password, and then it would ask you to verify the password again. So let's do this, and then retype it. And now the password for that has been changed. So password updated successfully. And if I wanted to do it again, I'll do this now. And there we go. You must choose a longer password. That's hilarious. So the initial password that they provided to us is such a weak password that it doesn't even meet the password requirements. So Kali no longer works. So I have officially changed the password for this particular user, which is going to be very, very useful. So let's, I guess, change it again because it won't let me leave this thing. So there we go. So password updated successfully. So if you want to update the password of your current user that you logged in, you just do password and then boom, you can change your password. So that is the first version of this command. Now what we can do, I mean, because of the fact that I literally, I feel like I changed my users so many times. Yeah, I literally don't have any more users to change. So I have to actually do a user add command. And in this particular case, we're going to create another user. So we will call this particular user Bill. So Bill is going to be our new user, and we've added this person. And so now we need to change Bill's password. So we would do sudo password and then give the user Bill. And Bill now needs to get a password because he didn't have one assigned to him previously. So I'm actually assigning the new password for Bill. And we're going to assign the password, and boom, we have officially updated the password for Bill. If I wanted to change Bill's password, I would do the same thing. I would just do sudo password Bill and now say new password. I mean, I've already done it, so I don't know why it's doing this, but there we go. So password updated successfully. So that is, we changed the password technically. That's kind of what we did. That is really how you just assign a password or create a new password for your own user or creating a password for another user. You would just do the sudo and then password and then the name of the user, and then you would be able to change their password. There is a couple of options that becomes very useful in this particular case, very similar to what we did with the usermod command. So for example, if I did the password -l and then I put in Bill, then I will actually lock Bill's account, preventing them from actually logging in. If I wanted to unlock them, I would just do a -u, and these are lowercase letters, so just keep that in mind. Previously, when we were doing the user mod, we were doing a capital L to lock them and capital U to unlock them. But when you're using the password command, it's a lowercase l or lowercase u to lock or unlock. So if I wanted to lock Bill, I do that. Password has to be done with sudo, so we would do lock Bill, and Bill's password has actually been changed. So if I do sudo password -u and then unlock Bill, and password has been changed again for Bill, right? So it's very important to understand this is a lowercase l and a lowercase u. So I do need to look at the Etsy shadow file to see what the new password for Bill is. Oh, the new password for Bill has now been this super encrypted version of a password. How crazy is that? So when you don't assign one, the system will wonderfully go ahead and completely encrypt your password, which I love the fact that it's doing this automatically. And that looks like a massive, I think it's probably a SHA-256 encryption or something like that. So I love the fact that it does that. So anytime that you don't assign a password. So you remember how we did when we did the user add command, and then I just typed in password. And then when we looked at the shadow file, it was showing me the clear text value of the password that we had created. When you use the password command and you change the password for a given person, then what it does is that it actually goes ahead and encrypts it for you, which I love the fact that it actually does that. So we're going to do password, and in this particular case, we're going to change Bill's password one more time just so I know what the hell I'm doing here. And now I'm going to say, what is going to be? We will do this. That'll be the new password, and that'll be the new password that we changed for Bill. So you do the -l and the -u to lock and unlock. And then what I wanted to actually find was how to expire. I think it's -e is how you expire their, yeah, there we go. Immediately expire the account's password. This in effect can force a user to change their password at the user's next login. This is one of the more important ones. So when you create a new user and you give them a default password, you immediately want to expire that password so that the first time that they log in, or the next time that they log in, which would technically be the first time that they log in, when you do that, it's going to prompt them to say, hey, your password's been expired. You need to assign yourself a new password. And that's how you can ensure that the user will create their own password instead of just running around with the default password that you assign them, which is like a big security risk anyways. So the -a is the something that's combined with the capital S, which would, in our case, again, I don't know what I did here. I think it actually just happens when you kind of just scroll on something and then it takes you to the bottom of the screen. So now I realize what I did previously. So -a is something that's used with the capital S that causes the status of all of the users that you would need to get. And then the -d, lowercase d, deletes their password. -e expires it. H would be the help. I would be inactive, so it disables the account after the password has been expired for a number of days. So it's very similar to the usermod command that we set them to inactivity, but we give them the -f inside of usermod instead of -i inside of the password that would inactivate them, and then -l to lock them, -key or K to keep the tokens. N would be the minimum number of days between password changes. So a value of 0 for this field indicates that the user may change their password at any time, which is, I think it's the best option, because just in case they get compromised or they think they've been compromised, they should have the option to change their password at any time. Q would be in quiet mode, that it would run everything in the background essentially. R would be the repository, so the changing the password in our repository. -R would be the chroot modifications. P would be the prefix modifications. Capital S is the status of the account. -U, lowercase u, would unlock the account. Warn days, so the number of days warning before password change is required. This is another one of those really important ones. So you give them like a 7-day warning before their password expires. So you would do -W and then the number 7, and then you give them a 7-day warning so that they understand that in 7 days their password is going to expire. And then you would do a -I in this case, right? If you're going to use the password command, you would do a -I that would say disable the account as where the password has been expired for a number of days. So you would do -N7, give them a warning for 7 days, and then, or not n, excuse me, the w, excuse me, you're going to do a -w to give them the warning of 7 days prior to the password expiring, and then -i, and then the number 7 to give them 7 days after this password has expired so that they have to change it, otherwise the account becomes inactive. And then the X is one that you would end up setting. So the M was the minimum number of days, meaning that you just leave it at 0 and they can change their password at any time that they want. The X is the maximum number of days, meaning that you give them 90 days, and after 90 days, they should change their password again. That's kind of like the maximum number of days for a decent environment, that every 90 days they're forced to change their password, which is very, very important for them to do. And then the lowercase s is to indicate that the password should be read or should read the new password from standard input, which can be a pipe. And this specifically can be done when you're creating the new user and then you want to pipe the output of a echo command, for example, to create the password in this particular case, which is kind of beyond the scope of this particular thing. I don't think it's even applicable in a lot of cases, as long as you know that the password command, the PASSWD, that command is what is used to change the user's password. And you can change your current user's password. You can set the minimum number of days, the maximum number of days. You can set the inactivity protocol or parameter. You can set a variety of other options, as you just saw, that you can use to interact with the password command. So very, very cool command, very useful command. And that pretty much covers it for interacting with users and modifying them and changing their password. So now what we can do is we can actually move into the modification of groups, adding, modifying, and deleting groups, and then dealing with the manipulations or how you can interact with those entities. So let's go to groups. There's actually two other quick commands that I wanted to run by you before we moved into group management. And these are the commands. We've actually covered one of them already at the very, very beginning when we were trying to get system information. But these are the commands that will check the current user's information. So you can actually just run ID, press enter, and it will give all of the IDs related to the current user. So for example, in my case, it would be the Kali user. And the Kali user has a variety of different IDs that are associated with it. And then these are the individual connections that it has to these groups. So for example, the actual user's ID is 1,000. The group user ID for Kali is also 1,000. And then the group user ID for Kali again right here. So you have the GID as well as the group portion. And then you have all of these other groups that they are associated with that has some kind of an ID that's associated with it. So for example, the Wireshark ID for this user is 124. The audio ID is 29. The pseudo ID is 27, so on and so forth. So if you just run ID, it'll give you the IDs of this particular user. Now, in this case, we also have the Bill user that we've created. So we can do ID Bill. And then now we can see that since my user was the first user, it was at 1,000. So Bill's user is going to be incremented by 1, and his group, because we've actually created multiple groups, because his group technically happened after the fact of the variety of other groups that we had, is now going to be 1,003, and then so on and so forth. So we have, if we actually go ahead and check out our Etsy group file to see what we have, we still have the Jill group that's over here, and then we need the Bill group. So we need to actually delete the Jill group, and then we'll do that when we go into the group delete section of this training series. But so the ID command, you can do ID just by itself to get your own IDs, and then you can do ID and then give the username, and then it will give you the associated IDs for that specific user. So that's what we had for the ID command to check the user information. Now the next one would be the who am I command, and we've already ran this at the very, very beginning, so I just wanted to review this with you. Who am I basically gives you the username that you are right now. And so if I was logged in as Bill, for example, so I can do the su command. I'm kind of getting ahead of myself. I can do the switch user command, and then I can switch myself to Bill, and it's going to say, okay, well, what's the Bill password? And I would press enter, type in his password and press enter. And oh no, I forgot what his password is. What did I set his password to? Oh, I think, okay, I remember. Okay. Now I'm like, what did I set his password to? There we go. Now I'm logged in as Bill. So you can see that the entry of my command line has actually changed. So if I do who am I, now I am the Bill user, as you can see. So the switch user command has now made me the Bill user, as we have over here. So I can do sudo or switch user Kali, press enter. Now it's going to ask me for the Kali password, and now I'm back into being the Kali user. So who am I? Just displays who you are as the user, and then you can switch back and forth using the su command, which is, again, I've kind of got a little bit ahead of myself, but now at least you know if you wanted to switch user, you just do su and then the name of the user, and as long as you have the password of that user, you can log in as that particular user. So we had the ID command and the who am I command, and that is basically it. That's all I needed to share with you before we move into the management of groups, creating, managing, and deleting groups. All right, we have now finally arrived to our group addition section. First, I keep pressing S instead of D. We have arrived to the group add section, group add, and we have group mod, and then we have group del. Very similar to what we did with the user, except now we're just replacing user with group. So if you wanted to add a new group, you can use the group add command and then add the group, and that's it. That's very simple. So you do the name of the group, and then if you wanted to, for example, change the group ID, let's say, so the GID, you would do it with the -G. So I know for a fact, so let's go do this and we'll go look at the group file that we had. So I know that the Kali group, right? So there was the developers group that had the 1002. Kali has the group ID of 1000. Jill has 1001, and then Bill has 1003. So we actually have these three groups that we've developed over here. And then from here, we can essentially delete them or modify them or assign various IDs to them. So I actually thought that we didn't have something that was at 1002 because I saw the skip from 1001 to 1003, and I was like, oh, I wonder what happened there. But we actually do have something that has been assigned at 1002. So I can just not worry about even changing the marketing group's GID because I was going to change it to 1002. Essentially, if you just do this by itself, you just group add marketing. I think I do need to do this as a sudo command. So let's just verify if we do need to run it as sudo. Yeah, permission denied. So sudo group add marketing. And there we go. Now we've created a marketing group, which is going to be inside of our etc group file. And then we can see that it's been incremented by 1. And now it has the GID of 1004. And of course, as anything else, we also have all of these various options that can be done. So you can force the creation of a new group. You can assign the GID to it. You can get the help menu. -K will override the etc login defaults. Multiple K options can be specified. So example, K minimum GID group ID would be at 100, and then maximum group ID would be 499. Technically, you can do that. And you can even do multiple entries, but you just can't separate them by a comma. In this particular case, it needs to be separated by a space. It says it doesn't work yet, so I guess they're working on changing that. But you can just separate it by a space, and you can say -K, the minimum, and then -K, the maximum. And now you have the minimum and maximum set group IDs for this particular case. -O would be non-unique, so it creates a group with an already used numerical ID. So for example, multiple GIDs, if I wanted to do 1002, for example, to duplicate the group ID for developers, I could do the -O, which would provide me to do a non-unique UID, but then I would also need to do the -G to assign the group ID. So you do -O for non-unique, and then -G to assign the actual group ID, and then you would give it the 1002 group ID. -P would be an initial password for the group account. So it's actually expected to be encrypted as returned by a crypt. Without this option, the group account will be locked with no password defined, a single exclamation mark in the respective field of the system account, which makes it that inaccessible. So this is not recommended because the password or encrypted password will be visible by users listing the processes. So you should make sure the password respects the system's password policy. So it's actually very interesting that this is most likely going to be blocked off. So you can't get access to the group itself. You can be in the group. Somebody could assign you to be inside of that group. The roots would obviously be able to get access to that particular group, but everybody else should not be able to get access to the group because then they would technically be able to modify it or do whatever else or get information from it and see who other people are in it. So it should actually technically be locked out to everybody other than the the system administrator and the root users, but people can be added to the groups and they can get access to the assets that are available to that group as long as they're inside of the group, but they can't get access to the group itself specifically. So that's very, very important. So there's an initial password that you can designate to it if you wanted to. Otherwise, there is no password and it's just locked out. -R would be creating a system group. So this is actually very interesting. The system group is something that, again, would only be accessible by the root user, and it's something that would typically store system binaries or system information that's very, very for example, the login would actually kind of be associated only with the system group. It wouldn't be associated with a regular group like marketing or something like that. It would only be limited to a very, very small group of users because it is holding very sensitive information. Capital R is for the ch root, capital P is for the prefix, and then capital U is the list of the usernames that you can add as members of the group. So by default, you can actually just do capital U, and then while you're combining it with the group add, you can create the new group and then add multiple users to it. So I think I already created the marketing group, so it's a little bit late to modify it. But if we went and let's just kind of mess around with this a little bit. So we're going to do groupdel and then we're going to delete marketing. So now if I actually go and cat the Etsy group folder, we can see that we have marketing has been deleted from here. So now what we can do is in this case, we have Bill and Jill, right? So, or actually not even Bill and Jill, because we deleted Jill, we just still have the Jill group. And I need to, since I'm already here, I'm just going to do groupdel and I'm going to delete the Jill group. So I don't have to worry about it because now I only have Bill and I have Callie as my users. And then if I verify that, I can go to the Etsy password file to verify my users. And I only have Callie and Bill as my users at the bottom here. So we can rest assured that we only have those two users. So what we want to do in this particular case, we can say group add, and then we can add a new group, which is going to be marketing, and we'll do a capital U, and then we'll say Callie and Bill are going to be added to that group. And now I can go ahead and get the entries for that group. So if you remember, we're going to do sudo get ent, and then we're going to do group marketing. And then we can see that Callie and Bill have both been added to the marketing group with this simple command. As soon as we created the group, we were able to add these users to the group. So you can actually add users through the group add command, or you can modify the members of the group by doing the sudo groupmod command and then kind of mess around with it as well. So that was it for group add, and then you can see all of the other options, obviously, if you just go to the manual page. So let's now talk about the groupmod command. So one of the many things that you can do with the groupmod command is you can modify the name of a group. So let's say I can do groupmod-n, and then I will take the new group name. So if I have marketing, I guess I can do market, whatever. We'll just do market as the name. And then we're going to change the group of the marketing, then marketing group, we're going to change it to market. And then if I go ahead and cat the Etsy group and look at it, we can see that the marketing group has now been changed to market. So you can very easily change the name of a group by just doing groupmod with the -n for new group name, and then you can assign a new group name to it. You can do -g to assign the GID of the group name to something else. So -g seems to be kind of be across the board, with the exception of when you do the user add and you do -g, you're actually changing their primary group. So that part, but for the user, for the group modification, group add, so on and so forth, or even the user mod, all of that stuff. Actually, no, even in user mod, I think -g also stands for the group that's been assigned to it. So the group itself, the -g would be assigning the GID. So any of the group modification, group add, group modification, all that, all of those commands, when you do -g, then you're going to actually modify the group ID for that specific group. And that's very important. So in example, if I actually go and look at the group ID for the market group, it's 1004. So let's actually go ahead and do a group mod command and change the UID. So we'll take it from 1004 and we'll do it to 2004, for example. That'll be the group ID for that. And then we'll just do the group name, which is market. And now if I go ahead and cat the Etsy group, we can see that the group ID has been changed to 2004. So it's pretty, I mean, a lot of these things are pretty intuitive. They're very useful and easy to work with. And of course, as always, we can just go to the manual page for group modification and work with a bunch of different things. So if group members are specified with the dash U, the dash capital U, we can append them to the existing member list rather than replacing them. So we can do a and then append, right? So append to the user list, right? So you would do dash A and then capital U to append this series of users that we're going to assign to that user list. So for example, it would look like this: sudo groupmod A and then U, and then I would say whatever, Jill, Bill, Hill, whatever. And then these people would be added to the market group, for example. And that's how you can append the user list to the group that we have designated. We have the G, which we already messed with, that will change the group ID. We have the H, which would be helpful. Lowercase n, which is for changing the name, which we've already done. Lowercase o, which is non-unique group ID, if I wanted to change the group ID to a non-unique value. So for example, let's go and mess with that a little bit. So if we have the cat etc group command again, so we'll see that the developers group has 1002 and then market group has 2004. So what I want to do is I want to change the group ID of our market group to 1002 to match the developers. And I'm just going to do a dash O here and I'll do market. And now if I do cat of the etc group, the market group also has 1002 and developers group also has 1002, and they have the same exact group ID. So you can make sure that it's a non-unique ID by just doing a dash O, which is very, very simple to use as well. And then let's go and mess around some more with the rest of these. I think that's pretty much it for the rest of these options because the rest of them are very similar. So dash P would be the modification of the password. So if you want to change the password, you would just go ahead and do that by using the groupmod dash P and then assigning the new password to it. Capital R would be the chroot, capital P would be the prefix, and then capital U would be the list of usernames that you're going to add. You have to combine this with the append user, so just keep that in mind. If you don't combine it with the append user, so if you don't do a U and then you just do U by itself, it will replace the previous list of users. So this is actually very important. So let's kind of look at this one more time. So if we're going to do the sudo get ent of the group of marketing, which is now Callie and Bill. So let's say if I don't do the sudo group mod with the AU, if I just do U, and then I will go ahead and give the Callie user and then the group name, which is going to be market, and then press enter. Now I have replaced it. So I haven't added the, for example, if there was another user, let's say Jill, I wouldn't have added Jill at the end of it. Now I've replaced these entries right here with this one entry, which would be the Callie user. So I would do cat etc group, and then we can verify that, and we can see the market group only has the Callie user. So if you want to append somebody, if you want to do group mod and then you want to add a user list, you would do A and then U, and then now you're appending, you're adding the users, and then we would be Jill or whatever, all these people, and then at the very end of it, you would give the market or the group name, and then now you're appending those people to that group so that you don't have to replace the current list of the people, which is a very, very important thing to understand. So you want to append, right? So that is essentially it for everything that we have for the group modification. And finally, we can actually talk about group deletion, which because we've already created a few groups here that are now kind of taking up our system place. So we need to get rid of the build group, we need to get rid of the market group, and we need to get rid of the developers group. And since we're already here, I need to also make sure that I get rid of the bill user. So if I actually go into the cat etc password file, I can pretty much rest assured that I have also a bill user at the bottom here. So I need to get rid of the bill user, and I need to get rid of all of the other groups that we have as well, including Bill's group. So the first foremost, we're going to do the userdel command. We're going to do the R to remove everything that's inside of his directory, and we're going to remove Bill. So bill is currently used by process 854297. Isn't that interesting? So we need to actually kill the processes that is being used. So if I actually go to my process list and find 854297, and then we can kill that process. So let's go and do that. And hopefully this actually works. So pkill stands for process kill. And then this was the process ID 854297. So pkill 854297 should have killed that process. So if I actually go ahead and run the userdel command now, and it's still being used by Bill. Isn't that interesting? So I need to make sure that Bill, the user Bill, is no longer using that specific process to make sure that we can actually delete Bill. So this is a nice little extra piece of information that you're getting right now. All right, so we got to do a few things to figure out what is going on. So all the processes that are being by the user bill, which in this particular, it is the shell command that was previously being used. So because we logged in as user bill, so when we did the switch user to bill, it's technically saying that bill is technically still logged into the user. So what I can do is I'm going to try this. I'm going to do sudo, we're going to do pkill, and then we're going to do everything for the user bill. And let's to make sure that we actually have that. So now what we can do again is going to list the processes by bill, and it's still using it. So I feel like it's because I'm in this shell currently that I can't delete bill. So what I'm going to do is I'm going to close out the shell, or I'm going to start a new shell. How about that? So we'll start a new shell, and then let's zoom in here a little bit, and then see if we can actually delete bill in this shell particular. So I have to actually delete the other shell. So let me go and delete the first one, which is this one. We'll close this particular shell, and let's see if we can do psu bill. And in this particular shell, bill doesn't even exist. So now if I wanted to go ahead and user delete bill, I should be able to do it because that previous shell no longer is open. So that's actually very useful to know. So as soon as you close the shell, the process technically ends and bill is no longer logged into that process. So now we were able to delete the user bill, and we can do cat etc password to make sure that the bill user is no longer here, which they are not here. So that is perfect. And now we need to delete those groups that we have. So for sure, we need to delete the group of bill. So sudo group bill. Oh, because we deleted bill, his group is already deleted. Perfect. So I need to group delete market because I know that was there. And we need to group delete developers. I know that was there as well. So we can now clear and we can go and look at the group list, and we are done. We're all good. So none of the groups that I have created are here anymore, and we were able to do that with the group delete option. So that was it. I mean, it's fairly intuitive. It's like fairly straightforward. And you now have a really good understanding of how to create users, create groups, modify users, modify groups, delete users and delete groups. And you even know how to use the password command to change the password of any given user. And then you even know how to assign a password to a group, although we have been notified on multiple manual pages that it's not a good idea to assign a password to a group because it'll automatically just lock everything out. And I mean, as far as the users inside of your environment are concerned, as long as they belong to a given group and then that group has permissions of the assets that they need, which we already talked about with changing of the ownership and changing of the group and then changing of the permissions using chmod, as long as you've done all of that stuff correctly, then it doesn't matter. They don't need to get access to the contents of the actual developers group, for example. They only need to get access to the assets that that group has permission to access. So that is pretty much it. So we are good for user and group management. And now we can actually move on to disk and file system management, which is, there was a big learning curve before I started this particular recording session for the practicals. I had to deal with my file system on this Kali Linux boot from the USB because I didn't realize that I was kind of getting myself in a little bit of like a complex situation by booting from the USB. I thought it would actually be easier to boot from the USB, but it ended up being a little bit more complicated because I had to start creating some partitions and assign those partitions to my external drive so that I can actually store the video recordings and so on and so forth. So there was a handful of things that was actually very interesting that I went through, and I would love to share them with you. And all of that is going to be under the file system and disk management that we are about to get into. So pretty excited about that. Let's jump into it.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, so we have come to the point where we're going to talk about disks and partitions, and this was a pain in the butt for me before I even started this recording, mainly because of the fact that I was booting my Linux instance from a USB drive, so it was a live boot from the USB drive. And I don't know if you just heard my dog sneezing in the background. So I was booting my Linux from a live USB, and then I had to deal with the partitions and the disk and all these things because I needed to save all of these video recordings to an external drive that was not the USB that Kali was being booted from. So it was like this whole ordeal to try to even figure this out. And ultimately, I was able to figure it out. So I think it made me a better administrator because I had to actually work through that problem to even be able to teach it to you right now. So the first part, what we're going to do right now is we're going to first learn how we're going to list our disks, meaning listing the different disks that are available on the computer and on our external drives, and then what the partitions are on those disks. And then from there, how we can actually create a new partition using these various tools. So what you can probably see in the background right here is I have my notes. So steps to creating a new partition. I don't know if you can actually see it because it's behind this window right here. But, that's what I'm going to be doing with fdisk when we actually get to that point. And it's very important to kind of do these things in order because they can definitely be a pain in the ass if you don't do them in order, and then you're going to have to backtrack and try to fix whatever error you may have caused and then start everything from the beginning again. And I'm literally speaking from experience because I had to go through this so many freaking times. So, okay, very, very, very first thing. What we want to do is we want to list all of our block devices. In this particular case, we're going to do lsblk. lsblk will list your block devices in a very nice human readable format, which is called, I guess, the tree format. I think this is what we're looking at here. So this is the loop block device, which is irrelevant to us. This means nothing to us. If we can't use it in any way, can't do anything with it. The size of it is very small, 3.8 gigabytes. That is not important. This is the computer that is actually running as my type 2 hypervisor, so to speak. So this is my actual Windows computer that's running in the background. And we have the disk association with it. So it's the first disk in my system, so SDA. And then inside of it, there are these 4 partitions that already exist. And then from there, we have SDB, which is my external drive that all of my recordings are being saved to. And then we have XDC, which is the little thumb drive that is booting Kali Linux for me. So these are my actual block devices, and they're broken down into A, B, and C. And then inside of them, you have 1, 2, 3, 4 for the various partitions, and then 1 and then 1. So this is one way to list the partition, and this is actually my favorite one. There's another command that comes with lsblk, which is the -f flag. And what it does is it also gives you the file system type that's associated with each one of them. So for example, inside of the Windows machine, we have, let me go back here. Inside of the Windows machine, we have the SDA1, which is a VFAT. SDA2 is nothing because I think it's like the smallest portion. SDA3 is the NTFS, which is the main disk that is being, or the main partition that's being used by the computer. And then SDA4 is also NTFS, but it has all the recovery tools on it. Then we have SDAB, which is my external drive, and it's been formatted to be exFAT, which is accessible to Linux, Windows, as well as Mac OS. So I need it to be cross-compatible so I can access it from any machine for editing and using the media, so on and so forth. And then I have SDC, which is VFAT, which is also similar to exFAT, except it's more dedicated to smaller drives. So FAT32 is more for drives that don't have a lot of space. So for example, if you see right here, we have 930 gigabytes that's left on this particular partition, which is close to a terabyte. And then I have 25 gigabytes that's left on this one, which is, it was originally, I think it was a 28 gigabyte thumb drive. So it's not a big thing. So typically FAT32 would be assigned to that. And we covered all of this inside of the lecture portion. So I don't want to take too much time trying to explain what the various file system types are and what their purposes are. So if you haven't seen it, go watch the lecture. It's very, very important. There's a lot of information inside the lecture that will help you make sense of everything else that we're doing over here. So this was lsblk. The next one is fdisk. Now fdisk is one of those commands that requires a sudo permission. So you can just do sudo fdisk and then do L to list the partitions. And so we can look at the list of the partitions that we have here. And so same thing, right? For the most part, it's giving you exactly the same information, just different type of output and formatting. So we have SDA 1, 2, and 3, and 4, which is for our specific SDA disk. And then it actually starts right here. So SDA right here, 447 gigabytes, and then you have the devices or the partitions right here and their sizes, so on and so forth, and then the type of file system that they have, which is in this column. So Microsoft Served, Microsoft Basic Data, Windows Recovery, so on and so forth. Then we have SDAB, which is our external drive, and then it has the description for this as well. And you can see right here, HPFS, NTFS, and exFAT. So these are the different types of file systems that can use it, which is very, very useful. It's cross-compatible. And then finally, we have SDAC in this location, which is our little thumb drive that is running on FAT32, and it's booting our Kali Linux. And then of course the loop is going to be included here as well. And this doesn't have any partitions or anything attached to it. This is just running on the computer live in this particular environment. So that's what we have to list our partitions and our disks using sudo fdisk and then the L option. Now, fdisk is actually something that you can use to create partitions. So we're not going to go into that until we actually get to the partition portion. But this is the command that you would use to list the partitions using fdisk, okay? And then we have another one, which is parted. And parted by itself like this is the command line version of this. And then you have gparted, which is the graphic version of parted. So gparted has, a point and click type of an environment, and it's much more user friendly. So if you don't like the command line, if you just like looking at the list of things and be able to have a drop down box and a menu and all that, gparted would be the way to go. It's more of a user friendly tool. Parted would be the command line equivalent of gparted. And gparted is also another tool that requires sudo permissions to be able to even interact with it or list something. So if I just go to sudo parted, I think I should be able to get into it. Yeah, there we go. So we're actually inside of parted. And now what I can do is, this is an interactive menu. So parted is probably the only tool that is, it just starts out being interactive. As you saw with fdisk, you can technically do fdisk-L and it'll list things for you, so you don't have to go into it to interact with it. But in my particular case, as soon as I do parted, it defaults to my very first disk, which is the SDA1. And then if I wanted to list what's available, I would do print, and then it's going to give me all the partitions that are available in SDA1, okay? And then from here, I can interact with these various partitions or even with this disk, and I can start creating partitions inside of the disk, for example. So if I do the help menu, it'll give me all the different commands that we can run with parted. And again, as you can see, this is a little bit hard to make out because it's like, okay, well, where does the actual command start? And then where does the instruction start? And or the description of the command, for example, where does that start? And then which parts of these are the arguments and so on and so forth. So it's a little bit less user-friendly than using gparted. But parted can also have the option to list the various disks and partitions that you have. Now, what happens is with parted, or I can't do clear. Can I do clear? I can't do clear. So with parted, let's quit this and then clear. So if we do sudo parted and I don't declare the partition that I want to use or the disk that I want to use, it's just going to default to the very first one. So you can see that it's going to just use the dev SDA. And then from here, I can print and then I can get all of the partitions that are inside of dev SDA. It's very different than using fdisk the way that we had, or using the lsblk, the list block devices that will simply just do this, and then now you have all of your disks as well as the partitions that are assigned to those disks. So this is my favorite tool to look at all of the disks as well as the partitions inside of those disks. And then it even gives you the mount point, right? So it says this particular disk can be accessed from this mount point. So if I actually go to my file system, so let's actually go open it up. And let's see if I can zoom in here for you. I can. So let's kind of go full screen with this bad boy here. And we're going to zoom in on these things. And then we have the file system on the left right here. And then you have the 1 terabyte volume, which is my actual location. If I see right here, now this is the thing that I wish I could do that I don't think I can do. I don't know how to zoom in using freaking Kali Linux. That's the one issue with Linux that I'm really trying to find out, because I would very much love to be able to zoom in on this location for you. Maybe we'll do it in post. So if I don't do it in post, if I forget to edit this in post, you can just kind of zoom in on your computer and look at this location up here. And this location is the actual path. So it's media, Kali, F7, DC, etc., etc. So if we actually go to here, we can see that it's media, Kali, F7, DC. So that's the path that this specific disk has been mounted to. So I can get access to it via my file system if I need it to, right? And that's what it looks like on the left side right here. It says 1 terabyte volume. And then this is my regular file system with the bin and the boot and the yada, yada, yada. And then this is the Windows file system that I can't even access because it's offline. It's not available to me because I'm not inside the Windows computer. So that's it. This is literally how we're able to look at, oh, I can scroll up and down. That's kind of, okay, well, that's useful, at least. So this is what it looks like right here. And then these are all of my media files that I've saved from this recording session that we're doing for the practical exercises of Linux Plus, right? So this is it. This is my external drive. And this is what it looks like inside of the actual file system viewer, like the file system manager. And then this is what it looks like on the command line, okay? So you can list all of your stuff with lsblk. You can do sudo fdisk and then the list command. So let's do that, right? There we go. So now this is the list command with sudo fdisk. And then if you wanted to look at a specific disk, you can just do sudo parted, and then you can do dev sdb, for example, and press enter, and it'll go into dev sdb this time. And then now I can do print, and then it'll list the only partition that's available inside of SDB, which would be SDB1, right? And that's basically it, right? That's how this whole thing works, and that's how you can list your various disks and your partitions. So now that we have this, we can go into creating partitions and then formatting it to turn it into a file system, so on and so forth. Okay, so here is the issue that I ran across while I tried to do this before I started this demonstration for you right here. So when we do lsblk in my particular environment, okay, so this is what I'm dealing with. This is the original computer. So this is the Windows machine. As you already know, this is my external drive that everything's being stored to. And then this is the thumb drive that Kali's booting from, okay? So since I have these environments, I can't, for example, I can't create a new disk. As you saw, for example, I can't show it because I already cleared my screen, but you saw those error messages that were here a couple of seconds ago. Those error messages were me trying to create a new partition inside of the SDA disk. Now, what's happened is that the total size of this disk that is even available is this 447 gigabytes, okay? Inside of this 447 gigabytes, this one has 100 megabytes mounted to it or dedicated to it. This one has 16 megabytes. This is the main partition that has the 446 gigabytes. And then this last one for our backup has the 500 megabytes, okay? The only way that I can actually create a new partition in this disk is I would need to free up some space. So I would need to unallocate some of this space, for example, and make it free, make it available to create a new partition. Now, if I do that without backing up my system, and I apologize, I should have thought of this in advance, and I should have prepared and backed up and done everything. But for a number of different variables, I did not think of that, number one, and I can't stop the recording of this training series because I have made promises to our community that this will be live and running, and then my actual personal life is limiting me from going back and forth and trying to do this. So for a variety of different reasons, that's my bad. I own up to it. And unfortunately, I can't demonstrate it in a live environment. But what I'm going to do is I'm going to give you a detailed step-by-step breakdown of what would need to take place in order for this whole process to happen. So for you to actually find your disk, for you to create a partition and then create a file system, mount that file system onto the new partition, and then use that file system for whatever you need to use it for. Okay, we're going to go through the actual process together, and you're going to get a great detailed step-by-step breakdown. I just unfortunately can't display it to you on my terminal in a live environment, and I apologize profusely for that. I hope you don't get upset about it. I do understand if you do get upset about it, but hopefully you'll still get the value that you need, and hopefully you'll still get the instructions that you need, and it'll all make sense. Okay. So that being said, this is because of the fact that I'm limited on my environment. So what we're going to do is we're going to go through the detailed breakdown of everything through, I guess, kind of like a lecture format. So except this is just going to be command by command. I'm going to explain everything to you, and you'll know exactly what commands to run in what order so that you can actually accomplish this particular task. All right, so obviously we're going to be doing this inside the terminal. So this piece, you should already have the terminal open. So you can just click the terminal button up here, or you can do Control-Alt-T, and then you'll open up a new terminal, or search for it in the terminal application menu. So open up the terminal, okay? The next one is to identify the disk that you want to partition. So we already know how to do that. And we go through the LSBLK listing of the block devices. And so let's say in this particular example, it is actually dev SDA. That is the disk that you want to use to create the new partition on. Okay, so you already know how to do LSBLK. You've seen multiple examples of this. Once you do that, it'll show you the output, which is very similar to this. And what you're looking for is this version, right? So this would be dev SDA, this would be dev SDB, so on and so forth. And what this does is it's the one that doesn't have the numbers at the end of it. If it has a number at the end of it, that means that's a partition. And then you can also see right here, so under the type right here, it says that this is a disk, so you're looking for the disk. And then all of these ones are partitions inside the disk. This is another disk, which is SDB. This is the partition inside of it, and so on. You can also do this with sudo fdisk L, which will also list it for you. And in this case, it's actually giving you the disk name. So this would be dev SDC, and then this would be dev SDB, so on and so forth. So you can actually identify your disk that you want to use in multiple ways so far. Okay, so you need to identify the disk that you want to use. That would be the next step. Then you need to create a new partition. So we're going to do this with fdisk in this particular case, okay? You do sudo fdisk dev SDA, and this is going to open up fdisk in interactive mode, and it's going to do it with dev SDA. So I can actually show you that. So we can do sudo fdisk, and then we do dev SDA, and then this is opened up inside of interactive mode with fdisk for us, okay? Now, this is the part that I can't do demonstratively, or I can't demonstrate this part. So N would be to create a new partition. What I can do is I'll go to the menu for you, and I'll show you what that means. So you do N, and you create a new partition. Okay, so you press N, and then you press Enter. P would be for primary partition. So when you get prompted, actually the next thing that it does prompt you to do is not the type of partition that you want. The next thing that it prompts you to do is choose the partition number. So it would be from 5 to 128. Now, if I press 5 and press enter, it says not enough free space. So I have to actually free up some space. And that's where I kind of ran across the glitch. So it's not going to ask you for the primary or extended or any kind of a partition. You can essentially just skip this step because this is assuming that this is an empty disk. So on my disk, I have multiple primary partitions. So that was not asked of me. If you're using an empty disk, you will most likely be asked if you want a primary partition or if you want an extended partition. So it would be either P or E for primary or extended. And then you would say, enter the partition number. So that is what we actually got asked. So what is the partition number? And in this case, I wanted to do 5, but I don't have space. So then you would say 5, and then you press enter, and then you would accept the default starting sector, and then press enter to accept the default encoding sector to specify the actual size. And then you would say W, press W, and then you will write the changes. And that basically is saving all of these edits that you've made. So it won't save until you actually do W and press enter. When you press W and press enter, then it saves the new partition that you made. So then in this case, it would be dev SDA5, right? So let's go back to our LSBLK here. And we can see over here that we have SDA 1 through 4. And so this is the output that I used to get the instructions for you. And so this is why it's coming up with 5. If there were no other partitions here, the primary partition, the default would be dev SDA1, like what you see here, SDB1 or SDC1. So if you had no other partitions, you wouldn't start with 5, you would start with 1, okay? So far, you have now created your new partition using the fdisk command. So then what we're going to do is we're going to format the new partition and add a file system to it, okay? So you can see right over here that we actually have the partition that we made, which is dev SDA5. So what we're going to do is we're going to use the mkfs, the make file system command, to create a file system on that new partition. So in this case, we're going to use the XT4, which is one of the most modern versions of file systems. I'm not going to go into the details of file systems because there's a lot of different versions. You've already seen exFAT, you've seen FAT32, you've seen NTFS, and now this is XT4. So this is a more modern version of a file system that you can use, but then you can technically do NTFS if you wanted it to be strictly Windows compatible, or use any of their file system types, just depending on what your needs are. And to find that information, you can go refer to the lecture video so that you can know the difference between the file systems. And then you can just find that information by using the timestamps in the lecture video description or in the top comment of the lecture video. So once you have that, once you know what type of file system you want to use, you would do mkfs dot and then the type of the file system itself. So it would be XFS or FAT32 or NTFS, whatever. And then you would assign the path of the partition that you're going to use, which is dev SDA5 in this case. And then you would press enter. Once you do that, it's going to create a file system on this particular location for you. Okay. So now we have creating a directory to mount that individual partition, this file system that was just created. And this you can do with a sudo make dir command, so mkdir, and that's exactly, you should already know how to do this because we've done this so many times in this specific tutorial video. So this part is not going to be new for you. So you're going to just create a new directory that is going to be mounted onto this particular partition. And once you have that, then you use sudo mount, and then you would do the location of the actual partition, and you're mounting it on to this directory that was created. And once that's done, you go back to either disk file system in the human readable menu, or you can even do lsblk. Okay, so let's do this with actual names here. So we do sudo fdisk dev sda. We use fdisk to actually open it up in interactive mode, and then we'll press N to create a new partition. If it's prompting you for primary or extended partition, you can select that option. If it doesn't, it'll ask you what partition number you want to use, so you'll do that. You press enter, and then you press W to write the changes, and now you have your new partition, which is going to be SDA5. Then we go into sudo mkfs.ext4, and then we are going to create a file system, which is xt4 file system on this partition. And then we're going to mount that by creating a mount point. So this will be our directory. So we're going to make a directory for our mount point, and then we're going to mount the file system using the mount command, and it's going to be mounted. So this is going to be the partition that's going to be mounted on this location. And then you do df-h to display it for you in a human readable format. And the DF stands for disk file system. So it'll just display it for you in a human readable format. And I'll show you what that output typically looks like. And then if you need to unmount the file system, you would use the sudo unmount command. So mount new disk, which is the specific path that we created, right? So this is the directory that we created for it. So you want to unmount the partition that's been attached to that. And then once you've done that, if you need to delete it, you go back into fdisk and then you would do sudo fdisk, again, SDA, because that's the disk that we created our partition on. And then you would be in interactive mode. You press D to delete a partition, and then it's going to ask you which partition you want to delete. And then you would do the number 5 and you press enter. It would delete it, and then you have to do W, enter, so that you can save those changes. Otherwise, it's not actually going to delete your partition for you. This is very important. This is one of the reasons why, or this is actually literally the primary reason why I wasn't able to demonstrate this for you inside the command line, is because I did not have a backup created of my file system, which is my bad. And I am not living my own advice, and I'm not an example. So don't do as I do, do as I say, so to speak. This sounds very hypocritical, so I apologize. But I did not have a backup, and so I was not comfortable with creating some space so that we can do the allocation of space and then create the partition and the file system, so on and so forth. This is very important as well. So each one of these things, each one of these steps should be done in order so that you don't mess anything up. I do recommend to do this on an empty drive. Do this on an empty disk so that there's nothing being used. And then from there, you don't even have to worry about creating a file system or a partition and losing data, so on and so forth. So in order to do this, my biggest recommendation is to do it on an empty external drive. Apart from that, I mean, you can do what you want to do, but in our particular example, we're using the primary file system, and then we're creating the partition, so on and so forth. So this is the workflow to create a partition, then the file system, and then mount that new file system so that you can use it in essentially whatever activity that you need to on your computer. There are a few other commands that I do want to share with you while we're on the topic of file systems and disks. And one of them is called FSCK. So this is File System Check. And typically this is what the system, anytime that you boot your computer, it's actually running this as one of the first things before it makes your system available. So it'll check all of your file systems to make sure that they're actually running properly. And so if you wanted to do it manually, you would just do FSCK, so File System Check, and then you do dev, let's say SDA1, for example, press enter, and then it'll say you must have read/write access or be root. Okay, fine, my bad. So sudo fs check dev SDA1, and then we're going to look at it, and it says, do you want to remove it? So it says copy volume label. There is no label in the boot sector, but there's volume label system stored in root directory. And it is a fat directory from Linux, so on and so forth. Copy volume label from root directory to boot sector, or remove volume label from root directory. And we're not going to do either of those. So I'm just going to do Control C and I'm going to exit it. And that is how you check the health of any given file system. So again, sudo fsck. Now I can do dev sda3, I think was my actual computer. And so it says this is not found. Oh, interesting. So that's not even available for me to check. So because the SDA disk, as I already mentioned, is my actual Windows computer that this Kali Linux is being booted on top of. So we'll do sudo fs check, and I know that we can do dev sdb1 because that's our external drive. And now it's going to says 45 files, 160, or 45 directories, 160 files. It's corrupted. That's hilarious. Files corrupted are 1, files fixed are 0. What else do we have? The error, Hank Hackerson, Zoom meeting, double click, etc., are currently being used. So this specific file that's being created right here, actually right here, this is the full file. This piece that's being created is actually still being written to, because I'm writing, or I'm recording right now live. So when I finish this recording and I end the recording and this file has been finalized, then when I run this, it should not say that there's a corrupted file because this thing is still being written to. So apart from that, I think everything else is fine because I've done so many freaking things. So right here, this is the full path of what's going on. And actually, I'll show you this because this is kind of useful to be able to see. So if we go inside of our volume here, this is it. So this is the file that they're referring to, this very, very top one, the Hank Hackerson Zoom meeting, etc., etc., etc. This is still being written to because we are doing a recording right now. So once we have the recording finished, then from here, we can make sure that hopefully it's actually running fine. So apart from that, I'm fairly confident that my file system on that external drive is all good. And since we're here, we might as well actually check our third disk as well, which is dev sdc1. Press that and look at this. Oh my God, these are all the things that are currently running on that. There are differences between boot sector and its backup. There's mostly harmless. The differences are such and such, and then all of this is jargon to me, so I don't even know what this is like some kind of an encoding that I would need to break down. But it says, do you want to copy the original to the backup, copy backup to original, or no action? And then we're just going to do Control C to get out of that. So that's pretty much it. That's how you can check the health of any given file system. And it's really nice because it really does tell you what's going on. And then if there are any errors, so if you want to fix any errors, for example, you can do fsck and give it the Y flag right here. And then that would automatically fix any errors that it finds. Now, I don't want it to accidentally wipe my data or cancel my boot for this live Kali Linux, so I'm not doing that. I just wanted to show you how the diagnostic actually looks like when you run the file system check. And finally, the next thing that I want to show you real quick is how to create a swap partition. So if you don't know what this is, swap partitions serve as the logical backup to your actual RAM, your random access memory that's on your computer. So if you have a computer that has 4 gigabytes or less of RAM, then it's technically a slow computer. And sometimes if you have multiple processes that are running and some of the processes are sitting in the background and they're not actively being used, they will be placed inside of the swap partition until you are ready to use them again. So that way your computer can save its resources and not use the physical RAM for computing. Instead, it will just use the swap partition to store all of those until you're actually ready to use them. So if we wanted to create a swap partition, we would pretty much follow the same process as we did before. So first and foremost, we're going to do list block devices to actually list all of our block devices and identify where we want to create our partition. So in this case, it'll be dev sda, which would be the disk that we're going to use. And then we're going to go into sudo fdisk dev sda so we can get into fdisk in interactive mode and use this disk to create our swap partition. And then what we're going to do is press N to create a new partition. If we want to designate, if it does asks you for primary or extended, you can just use primary for your primary partition because typically swap space is actually a primary partition. And then you would dedicate the partition number. So similar to everything else that we've done. And so far, everything is exactly the same. Then you need to specify the size of that partition. So it would be the 2 gigabytes, for example, to be a 2 gigabyte swap partition. And you can adjust this in any way as you want. And then you do T to change it, to change the actual partition type. And then the hex code for a Linux swap partition is 82. So this is where it gets a little bit complicated. But you need to use the hexadecimal code for a swap partition. So you would change the type, which is done with the T command, and then the hexadecimal code for a swap partition on Linux would be 82, and you press enter, and then press W to write it, and now you have created a swap partition on your disk, okay? So again, N to create a new partition, P for primary partition. You select the partition number, press enter to accept all the default settings, and then specify the size. So it could be 4G or 8G, whatever, however much you need. I think 2 gigabytes is pretty good. And then you can go into the partition type. So you dedicate the size to it, and then you do T to change the partition type. Hexadecimal code for a swap partition is 82. You press enter, and then you do W to write the changes and exit fdisk, and now you've created a swap partition. Once you've created the swap partition, you need to format it. So very similar to what we did with mkfs, but now we're making a swap. So it would be mk swap. So sudo mk swap, and then you give it the new partition that you've created, and now it's just going to automatically turn it into a swap partition. It's not something that you would have to create a directory for and then point the directory to the partition, so on and so forth. Immediately, you just give it the partition and then you say, make it a swap partition. And just like that, you've created the swap partition. And then you can do swap on. So that's the other piece that a lot of times I think it's missed. So you do sudo swap on, and then you give it the partition space again, and it'll actually turn it on as a swap space. And then you do swap on show to make sure that you actually have this swap space that's available, right? Then once it's done, if you don't want to turn it off, you don't have to. But typically, you may turn it off by using swap off. So that would be the command to just change this partition or turn it off when you're done with it. All of this is done in a temporary environment. You're doing it in a live environment. If you wanted to do this permanent, you would edit the etcfs tab file, and we talked about this a lot also in the lecture as well. So you add the entry for the swap partition to make sure that it's actually done. So you would do sudo nano. You already know what nano is, meaning you're going to open this fs tab file. So let me actually show you what mine looks like. etcfs tab here. And this is the only partition that I have here, which is the temporary file system. There's nothing else that I have as a permanent boot because I'm on a live boot of Kali Linux, meaning once I turn off this computer and restart it, anything that I have saved inside of this configuration file is going to reset back to this. So in my example, I don't have a permanent display of all of the file systems and partitions that are going to boot every single time that I start this computer, right? So we have nothing to write to, so we're just going to enter. We're going to get out. So you would go into the FS tab configuration file to be able to configure your permanent partitions. So for making the swap permanent, and then you would add this kind of a line. So actually this line exactly would be the line that you would add right under this particular line. So this is the first temporary file system that's available. And then you would go right down here, and right under that, you would add this line. And it would say that this specific partition doesn't have a file system type because it is a swap partition. And these two, as you can, I forget what the dedicated terms are that are relevant to these, but it will essentially say that this is just a swap space for those. I do explain this whole thing field by field inside of the lecture. So just go to the swap section for the lecture for swap file systems, and then you'll be able to know exactly what each one of these things stands for. But it's basically what it is, right? This is the path of the partition. There is no file system type because it's a swap space, and that's it. And then you add that line, you press enter, and then you're all good. And then you save it. And then if you don't need to use it anymore, you just do sudo swap off and then turn that off. So if we did it instead of an example that we did before, if we just created one, we would say sudo fdisk, go into the disk itself, new partition, it's going to be primary, partition number 5, default settings, it's going to be a 2 GB partition. The type we're going to change using T. 82 is going to be the Linux swap hexadecimal code. So you type in 82 and press enter, and then W enter, and then you write all the changes. So you saved it. And then you take that partition that you just created and you turn it into a swap by doing mkswap with a sudo command. Sudo mkswap, this turns into an actual swap partition. You turn it on by doing sudo swap on, and then you look at the list of your partitions by swap on -- show. If you wanted to make it permanent, you go into the fs tab document, sudo nano etc fs tab, add this line to the very end of the document, and then save it, and then you're all good. And then if you ever wanted to turn it off so you don't have to use it, you would just do sudo swap off and then just give it the path of the partition, and you are all good. Backing up is always important. Careful execution is always important. But this is how you create a swap space and how to turn it on using swap on, and then turn it off using swap off. All right, so in conclusion for this particular section, I do apologize that I wasn't able to properly demonstrate everything inside of the command line for you, but you do know everything that you need to know. All the need to know stuff is available. So The very first item is how to mount something, and you do that with the mount command. How to unmount something is done with the unmount command. And then essentially right afterwards, you would just give it the SDA, whatever, SDA3, and then it's going to unmount SDA3 for you. Typically, these are all going to be done with a sudo command to accompany them. So mount and unmount will mount or unmount a partition for you, okay? And then you have the various tools that you can use to get the partition information that you need. So for example, lsblk will get you all of your partitions in a very user-friendly format. If you wanted to look at the file system type, you would just use the -f command with list block, and then it would give you all the file system types in this case. And then you can also list with fdisk and do -l, and it will list all of the partitions for you as well and give you all the data for it, as well as the sizes and the types of partitions like FAT32, so on and so forth. If you wanted to create one, you would go into fdisk and then you just assign or you dedicate where you want to go and create your new partition in. So you have to say fdisk and then give the path of the actual disk that you want to work with. So let's say it's SDA, press enter. Now you're inside of interactive mode with fdisk. If you're not sure what to do, you press M and you look at whatever the options are that are available. And then there's a lot of documentation, obviously, that is also available for this. And you can, of course, use something like the Gemini AI or ChatGPT or something like that to also help you along with your step-by-step instructions of what you do. And then essentially just go through it, right? If you want to delete a partition, if you want to list the partitions, create a new one, print a partition table, change the partition type, verify the partition, print information about it, or resize a partition. These are all of the generic commands that are available. A lot of cases, they will require some kind of an argument with it. So it would technically be, for example, so let's say I want to print the partition table. So let's say I want to print a partition table. So if I just do P by itself, press enter, it'll actually show me everything for the partition table for this given disk. So SDA right here. So I have the partition table. So now I know that these are my partitions. So if I wanted to resize a partition, I would do E, and then I would give it the partition that I want to resize, and then it would go ahead and help me to do that. So fdisk is used to either list your disk partitions, or you can actually use it in interactive mode and create new partitions, resize partitions, so on and so forth. And then we have the parted command, which is another one, sudo parted, that if you just do it by itself, it's going to open up the very first disk that it can find. So you actually do need to give it an actual location that you want to look at. So if I wanted to do dev.sdb, it'll open up dev.sdb, and then from here I can go ahead and just use everything inside of the help menu to list for myself. So let's say print. I want to print all of the partitions inside of my disk right now, and I'll print the only one that I have inside of this disk, so on and so forth. And then with this, you can do make partition, etc., etc., etc. What I will say is that the parted seems to be a little bit less user-friendly than fdisk. So if you're going to use parted, then you might as well just do sudo apt install and then do gparted and then install the graphic user interface of gparted, which is actually very, very easy to use, and it's very powerful and effective. So if you're going to use parted, you might as well use gparted. I just want you to know what the commands look like. So if you did parted dev sdb, if you see this, then you know that this is what you need to do, or this is what's going on, is that the parted tool is going to open up the SDB disk, and you're going to open it up for interaction with the overall partition creation and resizing, so on and so forth. So these are the various tools that you can use to list the disk information or even interact with the disk to create partitions. And then we have, of course, the file system command, which is the mkfs file system, or the mkfs. So let's do man mkfs to actually open this up, and it'll show you what all the different choices are that you can actually use. So you would do mkfs, and then you can do dot and then give it the extensions right here. So you can do mkfs xt2, vfat, xt3, so on and so forth. So let's see, where's the ntfs? Is ntfs over here as well? I think these are not the various available types that are here. So we can do the type and then assign it that way. So again, mkfs make file system can be used to create file systems for you. And then you would have the directory that you would need to create. So if you're doing this, of course, you would need to do a creation of make directory to create the mount point for the new file system like that. And then you would connect the file system that's been created with MKFS, and then you would attach it to the new mount point, that new directory, and then you would actually mount it, right? So you would do sudo mount, and then you would attach the partition that you created to the file system. And we already covered all of those instructions. So that's kind of the big thing that I had for you. And I just wanted, I'm sorry that I wasn't able to demonstrate it. And hopefully you were still able to understand what we just did. And hopefully you actually got some value out of it. So now we can move on to the next section in our tutorial, which is going to be the section on networking and how to interact with your network inside of the command line of Linux.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.
All right, so we are now inside of our networking section, and networking is another one of those topics that's going to come up very frequently, depending on the company that you work for, or really the necessities of your own life even. Sometimes you may just need to know these things for yourself. So networking is a big topic. We're not going to go through network plus kind of a supplementation here, but what I am going to do, I'm going to give you a series of commands that are very, very useful, and you can use them to look for information, to configure certain settings inside of your network as well as your computer, and we'll have some fun. So the very first command that we want to talk about would be the IP or the ifconfig. Now, depending on the version of Linux that you're running and the system initializer that you're running, one of these things would work, if not both of them. So IP is kind of the more modern version of ifconfig, and then you have ifconfig. So ifconfig by itself, if you just run it right here, it'll show you the list of the configurations of your internet, really, your connection, right? So the ETH0 would be the interface that we have here. This one is the IPv6 address that's been assigned to it. The Ethernet address especially. So I think actually that's like the MAC address, my bad. So that's the Ethernet MAC address that's been assigned to our interface. We have the local or the loopback interface, which is the 127.0.0.1. This one is across every single computer. It actually has the same exact loopback local address, which would be 127.0.0.1. And then you have WLAN 0, which in this particular case is the IP address that's been assigned to my virtual machine on this Linux device, okay? And then this is the network mask. We don't need to go heavily into it. I went into the subnet and the network mask and the broadcast address and all that stuff. I went through all of these things inside of the lecture portion. So I'm not here to explain what all of these things mean, but I am here to show you how to get certain data. For example, getting your IP address that has been assigned to your interface, or getting the name of your interface. This is what the purpose of these commands are. So more often than not, if you see 127.0.0.1, that is not the IP address, that's the loopback address, and that's the address that's assigned to every single computer without exception. Every single time that I've ran this on any computer, it could be a virtual machine, my own machines, 127.0.0.1 is for the loopback or the local address, the local host address. And then you're looking for something like this when you're looking for your actual IP address. So this would be the IPv4, the INET, and then when you see INET 6, that is the IPv6 address. As you can see over here, it's much longer and much more complicated. And the main reason is because there's only so many iterations of these numbers that can be generated. So there's like 4.5 billion, something like that, different IP addresses that can be generated. And a lot of times they are actually repeating IP addresses because they work in different regions of the world, and some of them are private. So there's a private IP address, for example, and then there is public IPs and yada, yada, yada. So this is how you find your configuration for your IPs and your internet. Now, what we can do is we can run a few different commands here to work with, for example, assigning an IP address with ifconfig, or looking at an interface and taking the interface up or down and various connections here. So this is already running. So this is literally the only interface that I have over here. So this is already running and it's already connected. So you see the status right here. It's actually up and it's running. If I wanted to take this down, for example, I would associate with it or do that command with the WLAN0 interface name. So it would be the ifconfig. So let's clear the screen. It would be ifconfig and then WLAN0, and then I would just do down if I wanted to bring it down because it's already up. If I wanted to put it up and actually have it start running, I would do WLAN up. So it's very simple to interact with an interface if you want to bring an interface up or down, assuming that you have a much larger list of interfaces than I do in your network. So if we did the manual for ifconfig, we can see all of the options that we can actually run with this thing. And obviously there's a bunch of stuff that's available. So display all the interfaces that are currently available, even if they're down. Display a short list like netstat-i, which is another tool that we're going to get into. And then be more verbose for error conditioning or error conditions. The interface or name of the interface. This is usually the stuff that's assigned to it. So for example, ETH0, what we have, or WLAN0 is what we had. Bring it up, take it down, and the variety of other choices. So we have -arp that will go to the address resolution protocol on this interface, so you can enable or disable it. You can go to the promiscuous mode of the interface, meaning that if you actually enable it, it'll be more promiscuous and it'll actually connect to more devices or allow more devices to connect with it. If you turn it off, then it will be as conservative as it can be, and it won't let any other devices outside of your network actually connect with it or communicate with it. You have alt multicast mode, so you can enable or disable that. MTUN is the parameter that is the maximum transfer unit of an interface. And let's see, where was I? I kind of skilled right here. So MTUN is the maximum transfer unit of the interface. And it's typically there's some kind of a number that's associated with it. So this N is replaced by a number, and usually it's the number of bytes. So we have DST address, so which would be the destination address. So set the remote IP for a point-to-point link. This keyword is now obsolete, so point-to-point would be the keyword instead of using the DST address. And then the net mask address, if you wanted to set up the network mask for this interface, you would do it with this, adding the prefix, deleting the prefix, tunneling, so on and so forth. So there's a lot of options that comes with this because this is a very big command inside of networking. So there's a lot of stuff that you can do with the ifconfig command. And then once we get into IP tables that have to do with the firewall rules and creating block or allow rules and all of the other things, we can talk about what networking in general kind of does. So this is more for just getting the information about your interface that you're in right now. So you can do man ifconfig if you want to learn more about it, or just look up a lot of the documentation that's available for ifconfig. So if I wanted to assign an IP address, I could also do that as well. So we could just combine a few of the commands. So for example, it would be ifconfig, and then let's say we do the ETH0 interface, and we want to assign an IP address to this interface. So we would do, let's say 10, 10, 10, 10, for example. That would be the IP address that we want to assign to that interface. And what we're going to do is we need to also give it the network mask, which is our subnet mask. And then we need to give it the 255.255.255.0. And if you don't know what this means, I do recommend you watch the lecture, because it's very important to understand at least what subnetting and network masks are, and what these 255s represent, and what all of these different the variations that could be generated from this subnet mask, versus if I took the subnet mask and changed it to 0.0 at the end, how many different variations could be created with that. So in this particular case, if we do 255.0, that means in this subnet, there can be 254 different changes made to this last item. If I don't do that, and if I do 0.0, in this subnet, we can create 65,000 different IP addresses. So it's essentially doing 254 times 254, and it will give you that number. So this is a very, very powerful tool, and ifconfig can be used to assign an IP address to an interface. You can find the IP addresses of interfaces, and you can get more information about your local computer's connection to the internet. So that is what ifconfig does. Now, IP would actually be the more modern version for figuring out network connections and everything else that we got. So as you can see, there's a lot of commands that are or options that are available for the IP command. So I can do IP address, for example, and I'll just press enter, and now it's going to show me all the IP addresses and connected to my devices. So now we can see actually color coding, which is super freaking useful. This would be the ETH0 interface, the WLAN 0 interface. And then look at that. We got the IP address, the INET IP address. This would be the broadcast address. This is the INET 6 IP address, and so on and so forth. So this is actually a much more user-friendly version of this particular command, or the kind of like the ifconfig command. So we have the code state down for this particular interface. So it's actually been down. This one is code state up because it is actually up. The transfer units that we were talking about, both of them transfer in 1500 bytes, I believe. So that's what I think. That's what that. I don't think it's I don't think it's 1500 kilobytes. I think it's 1500 bytes, which would be 1.5 kilobytes, and etc., etc., etc. So this is the version of the IP command, IP add, ADDR, that will actually display all of the IP addresses. So if we wanted to get the state of the network, for example, we can use IP link, and it'll give you the state. Instead of giving all the other jargon and all the other information, it'll just show you the state of everything. So this is down, this one is up, right? And if you had a much larger network, you would be able to just look for the down and up just to see what the state of all of these network connections are. Now, if I wanted to assign an IP address to an interface, then I would use the IP A and then add, and then we would continue with the rest of the instructions. So for example, 10.10.10.10 would be the IP address, and then we would go ahead and assign it to the, for example, let's see, we actually also need to do a subnet mask for this as well. So instead of doing what we did with IP or ifconfig, where we did 255.255.255.0, we would have to do what is considered as a 24 bit right here that you see right there. That 24 represents this subnet mask. So I promised that I wouldn't go too much into the details, but I kind of have to. So if every single one of these are called an octet. So if this is 8 and this is 8 and this is 8, that means this is a 24-bit subnet mask. And if this was changed into 0 and 0, now we have 16 bits, so 8 times 2, and that would be a 16-bit subnet mask. But in this particular instance, in this example, we're going to assume that it's a 24-bit, meaning that there is 255.255.255.0, and that would be our subnet mask. And then we're going to go dev and then ETH0, which would be assigning this IP address at that subnet to the ETH0 interface. So IP A add. So you would do IP A stands for add, or like addition, and then ADD stands for the address. And then now you're going to add that address to the ETH0 interface. So that's what IPA is like. And it's not to be confused with the really horrible tasting beers or whatever those things called. So IPA, IP space A will be how you can add an IP address to an interface. If we want to bring something up, so if we want to bring it up or take it down, it would be IP link and then set the interface up or set the interface down. So you're looking at the IP link, then you want to set the interface either up or down, and that's how you take an interface up or down. We can always do manual IP to look at the various options that are available for our specific tool. And of course, just like ifconfig, there's a lot of different stuff that is available for IP. And I highly recommend that if you're not going to read through these manuals, at the very least, you think of any common case that you can think of and then take that common case into an AI assistant and ask it, hey, so what would I do? And what version or what flags or options of the IP tool would I use to get this data or to do this activity on my network? And then kind of get as much information as you can so you can wrap your head around this a little bit. Because of the massive amounts of commands that I have to go through, if I went through all of these options and give you all of the details of this, it would take me forever and it would be a very, very, very large tutorial. And unfortunately, I can't do that. So I'm just relying on the fact that you would be interested enough to go teach yourself these instructions here. So that was for our interface configuration and just getting data about our interface, which would be done with either IP or ifconfig. Now moving on to the next portion here, which is checking for network connectivity. Network connectivity is something that you are, for more often than not, you're trying to troubleshoot whether or not a website is up or whether or not you can actually connect to something, right? So let's say that in your Wi-Fi settings, it says that you're actually connected to the internet, but for whatever reason, you can't connect to it. Or let's say you're troubleshooting access to a website. So the website is down and the website is supposed to be up, or you're trying to find why something is loading so slowly versus the normal load time that it's supposed to take, and what is happening with the path that that specific connection is taking and all of the routers that it's connecting to on its way to its final destination, so on and so forth. This is where all the network connectivity troubleshooting kind of comes in. So ping is like the most common tool that is ever used. So when you ping something, you want to see if it's up or not. So if I ping Google, it's just going to give me, yeah, you're getting the connection. So if you get something like this, that means it's actually connected and Google is up. And it's saying that it's connecting from this particular piece to this destination and seems to be all good. And it's taking 21 seconds and 30 seconds and 22 seconds, or excuse me, milliseconds, sorry. So it's taking, this is the length of time that it's taking for us to get a response. Now, if you just let it run, it's just going to keep running. And so you'll get really like an infinite response from Google as long as Google is up. Now, if I want to cut this, I actually have to do Control C to end it, and then it will cancel that connection. And then we can see at the bottom that we have google.com ping statistics. There were 39 packets that we transmitted, 39 were received, there was no packet loss, and the time was 38,047 milliseconds in total, which is approximately 38 seconds that was running. And that's it, right? So this is the minimum, the average, maximum, and the amount of time that it took to make these connections, to send these packets and receive those packets. If you wanted to run ping, but then limit the number of connections or the number of packets that are being sent out, you would do the -C option. And then now I say I wanted to just send 5 packets to google.com and then press enter. And now it'll do 1, 2, 3, 4, 5, and then it ends. So it sent 5 packets to Google and received 5 packets back from Google. And we can see that everything was done all good. So 4 seconds in total that it was taken, and we never lost anything in transit. So obviously google.com is up. Now, there's been multiple situations where I was hired to do a pen test, a penetration test, and I had to look at a web application. And one of the first things that I run is ping, especially if I'm trying to load the application on my browser and the application isn't loading for whatever reason. I would run a ping to see maybe it's been blocked off, right? Maybe they don't want you to get access to it and you have to take a different approach to get access to it. So you first run ping, which ends up sending an ICMP packet, which is a ping packet essentially, and it sends it over to see if there's anything that we can do, right? So, or if there's any connections that can be made to it. There is something called a ping flood. That is an attack that is done in the world of hacking, or even like black hat hacking, which essentially you send a flood of ICMP packets and you send them in a short period of time. and you don't do anything other than something called a denial of service, which is essentially when I bring the service down. So if I send so much traffic to your server that your server can't handle that traffic, and you don't have a load balancer and all these things put in place, or you don't have a firewall that's blocking a certain number of pings from a certain IP address, so on and so forth. So you don't have anything like that, then your service will crash, and the person who's trying to access your service will be denied. So that's a denial of service. If I did a distributed denial of service, that means it's me as well as, let's say, 100 different computers or internet devices that are also sending those ICMP packets to that location. So now they don't know where it's coming from, and they can't block any given IP address. And now there's a bunch of different floods that are coming in. And now we can most likely guarantee, if it's a small enough company, because like Google, they have load balancers and they have backup redundancy servers and all these things. So it's very, very difficult to take down Google. I don't think anybody's ever taken Google out of service, but you could do that. So ping is used for connectivity to just make sure that there is a connection taking place. But if you really wanted to crash something, you could actually do a ping flood and then send it a bunch of different ICMP packets and then kind of bring that service down, right? So ping is a connectivity tool. And then, of course, we can look at the manual for ping to see what we can do. So you can use only IPv4 addresses. You can use only IPv6 addresses. You can do an audible ping, which will give you little beeps every time that it does it. An adaptive ping, you can do allow pinging to a broadcast address. So you can actually ping a broadcast address. Don't allow ping to change source address of probes. Count the number of requests that we're going to send out. So that's what we just did right now. Capital C will be a connect system call on socket creation, so on and so forth. There's a lot of stuff. If you wanted to do a flood, this is what we would do. So a -F command, you would do a flood ping. And for every echo request, it'll send, that is a dot is printed instead of sending that full line. And while the backspace, everything that is received is going just to be a backspace that's printed, and it's going to be a rapid display of how many packets that are being dropped. So you're going to send a lot of packets, and it's going to be 100 times per second instead of doing 1 per second. So it's going to be a much faster ping series of packets that are being sent out. And for the most part, you do this to see how resilient a network connection is. You don't do this just because you're trying to see if something is up. This is mostly done for testing. Then capital F to IPv6, and then help, and then force DNS resolution for output, the intervals for how long you want to wait for each ping to be sent out. So you do -I and then 5, and then it'll wait 5 seconds instead of doing it every 1 second, so on and so forth. There's a lot of options, as you can see, that are available for the ping tool. And again, this is one of those things that if you want to get good at this stuff, you definitely want to go and look at the ping tool a little bit closer to see how you can use it for network connectivity checks, as well as maybe even some pen testing stuff. So now the next command that we're going to talk about is traceroute. The traceroute command, so let me actually show you what they say in the manual here. It prints the route that a packets trace to a network host. So essentially, it tracks the route that the packets take from an IP network on their way to a given host. And the time to live protocol is what's used. And it attempts to see if there is a time exceeded response from each gateway along the path to the host. You can really use a bunch of different options, as we will probably go through in a little bit with all of our commands. But essentially, this is what we're trying to find out, is how many different hops. They call it hops. So if we do trace route, for example, and then just give it the website, so google.com. And then in this particular case, it took what? It took 10 hops. It went 1 from our location, and it ended up at the IP address for Google. And the amount of hops that it took is literally these 10 hops. And then it took about 7 milliseconds to send this packet, 7 milliseconds to receive the packet. I believe that's what these specific items mean. Actually, I need to verify. I think one of them is send, the other one's receive, and then the average time or the combined time between the two. And then this is for the second packet. And so it went from this, and it landed on this first, and then it went from this, landed on this, and then landed on this, and then it landed on this, and then landed on this, until it finally ended up at the IP address for Google. So this last location is the actual destination that is trying to land at. Now, sometimes you want to see what the path is that something is taking and exactly why it might be taking so long to connect to something. Or if there is some kind of a suspicion that somebody is intercepting your traffic and you want to see along this path that is taking if any of these IP addresses seem to be suspicious. So you can write a script that will take the output of this command, and then it'll see if any of the IP addresses that are being hit along the way are actually listed on a VirusTotal database, for example, to see if there's some kind of a malicious IP address that is now intercepting your traffic. So you could be sending a request to a website. You could be interacting with a website. So this could be your website. You could be entering sensitive information about yourself, your credit card information, or the information about your clients, something like that. So you could be going through this whole piece, and as you think that you're just interacting with the internet, somewhere along the way, one of these malicious IP addresses is intercepting the traffic. So that could be one of the troubleshooting things that you can do with traceroute, or it's just taking way too long to load and it's taking way too long to connect to something, and you're wondering why it is. And then you can see if it's taking its sweet time somewhere, or if something along the way is really holding it up and it's stuck at one particular location for a much longer amount of time than it actually should be. So if we go ahead and clear this and then run it one more time, I should be able to see. So let's see, traceroute.google.com. We should see now we also have, again, another 10 packets until we finally ended up at that location. And then so if we run traceroute Google one more time, and then you can also see that the destination, it changes every single time because Google changes their IP address. They have a dynamic IP address. It's not a static IP address. And this is mostly because they want to, it's a security measure so that they don't worry about somebody finding their actual dedicated IP and then trying to attack the IP, so on and so forth. So this is a very useful tool. Now, there are some things that we can do, a few options that we can attach to this to see what we can do. So for example, if I actually run it one last time, so let's run it one more time, and we can see right here that it says there are 30 hops max. And in this case, in this instance, instead of taking 10 hops, it actually took 8 hops this time around. And then one of the big things that I've noticed every single time is that we actually have this one address that is being hit every single time. So maybe that is the connecting router from me to the actual internet, and then from there it's going to Google, right? So the maximum 30 hops is one of those things that are you can actually declare. So you can say that you want to take a maximum of 30 hops, and then from there, hopefully it won't take more than 30 hops, but it's the kind of a default setting that it has. So I can do traceroute and then do -m and then do 30 and then do google.com, press enter, and it'll stay under 30 because we're dedicating the maximum number of hops that it should take to get to the destination that it wants to. So let's try a different one. So let's do maximum of 5 and then see how that would work. Press enter, and then it would only take 5 hops, but it doesn't end with the Google location. It will just stop at this one location, which is the lang yada 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 at lacox.net. And I know lacox.net is actually the internet service provider. So the 5th hop is typically what we can assume is going to be the connection that is made to our ISP, and then from there it's going to try to connect to the internet. So a maximum of 30 is what would give the permission to actually send it and actually land where it needs to land and finally connect to Google. Okay, and at the 5th space we can see every single time we have cox.net, so that is rest assured, we can be very confident that that is our ISP's router, or at the very least, there's some device that is intercepting my traffic right now. And I'm not at my home internet. I'm actually in Las Vegas visiting my sister. So it could be maybe my sister is being hacked or something, which I don't think so. I think it's actually because that's her internet service provider. But this is a very useful tool. So if you see a question of, okay, what is ping used for? That is used to check the connectivity and the amount of time that a certain number of packets will take to get to Google. And then you can do C5 and you say, okay, they're only going to send 5 packets. It's going to count to 5 and then it's going to turn off the connection. It's going to cancel and cut itself off. If we wanted to look at, I think it was the iteration. So if I wanted to do, was it the iterations or maybe was it the delay? So let's go see what that one command was. So instead of it doing 1 second, we can see interval. Yeah, interval. So it was an interval. So we can actually go and do this. So we can do ping and then do C5, and then we can also do interval 3 and then go to Google. So it'll still send 5 packets, but now it's going to wait 3 seconds. 3, 1, 2, 3, 1, 2, 3. So the interval can be changed. And this is actually very useful because sometimes if you actually are doing a pen test and you don't want to see, you don't want to show up on Wireshark, for example, their network sniffer or their internet intrusion detection system. If you don't want to show up on their end as somebody who's trying to scan their network or ping their network, then you would increase your interval from I3 to, let's say, I30. And then it would wait 30 seconds between each ping that it sends out. And that's much harder to detect because, especially if it's a really busy network, there are going to be so many packets that are going to be sent back and forth to that network during those 30 seconds that it's going to be hard to try to determine what the person is or exactly what's going on, and somebody's trying to ping them and somebody's trying to scan them, so on and so forth. So the interval option, when it comes down to network connection with a lot of different resources, that's going to be something that you'll see as an option that's available with pretty much most resources, so that you can really kind of hide your track, so to speak, or make yourself a little bit more sneaky as you do your activities online. So that is what we had for network connectivity. It was ping, and then we had, of course, traceroute, which tracks the number of hops that something will take to get to its destination. And then usually it's not going to go more than 30 because that's the default setting of maximum 30 hops. But then you can just see that it'll take however long, and then there might be something that shows up in the middle that would be your internet router, and then all the other hops that are taking are the other routers across the internet that it connects to before it finally lands at google.com. And if you wanted to check to see if there's anybody watching you or anybody intercepting your traffic, you can take the output of this and then feed it into a script that will check every single one of these IP addresses against a database like VirusTotal. And then from there, it will let you know whether or not any of those IP addresses are malicious. And if you see that IP address showing up all the time, you can rest assured that somebody's intercepting your traffic and you need to block them from your, your IP tables or from your firewalls, etc., etc., etc. So now we can move on to viewing network connections and the 2 very important tools that are used to find the connections that you have in your network. All right, to get your active network connections, there are 2 tools that we are going to look at. One of them is netstat and the other one is the ss command. And so the ss command is actually kind of the more modern version of netstat, and they pretty much do the same thing. So if we did netstat, for example, and pressed enter, it'll say that these are all of the connections that we have, right? So we have the connection, it's been connected. It'll give us there's so many, so there's actually a pretty long list right here. But it's the stream connection, dgram connection, the person that it's actually connected to, or the bus that's being used to make the connection. Very, very, very large freaking list of items here. So we can kind of narrow this down a little bit by feeding netstat a few extra options here. And we can go look at the manual for netstat to see what all of the different options are for it. So it'll print network connections, the routing tables, the interface statistics, masquerade connections, which are kind of like hidden connections. So you hid your IP address from the world, and multicast memberships. These are all of the options that are available. So what we can do is we can display the kernel routing tables, for example, using route. We can look at the interfaces, all the network interfaces. We can look at all the masquerade connections. We can look at the statistics of everything. And then, of course, there's a verbose output. There's the wide. So don't truncate IP addresses and make them as wide as needed. There's the numeric addresses. Instead of trying to determine symbolic hosts or ports or usernames, just give me the numeric addresses that are important. So this is what, if you want to look at the actual IP addresses that are being connected. In a lot of cases, you will end up doing that exactly, so that you don't look at IP or you don't look at usernames or ports or what they're considered to be symbolic hosts, which one might be the website or the name that is for that specific domain. Instead of that, you just look at the IP address that's connected to it. Numeric hosts, numeric ports, numeric users, the variety of protocols that you want to connect to. So this is actually a really big one. So the protocol family, if you do -A, it will be the address families, perhaps. I think it's going to be all. So if we do -A, it'll be everything. Let me just double check and make sure. I think it actually is everything. There is a different way that we can. I don't think it is everything. I'm sorry. I don't think -A is everything. It might be the protocols. It's not the different types of IPs that can be connected, but it might be the protocol. So UDP, TCP, so on and so forth. The displaying of the additional information, any timers that are related to your network, the PID of it, so the process ID, show only sockets that are listening. This is for all, so show both listening and non-listening sockets. So previously what we had was the protocols here, which would be -A, that will show all of the protocols that can potentially be on your system. So it would be INET, INET6, Unix, so on and so forth. If we do a lowercase a, it's going to show listening and non-listening sockets. So that's what's important. -F will print the routing information. -C will print from the route cache, so on and so forth. And then you can actually send the output into a variety of different formats, as well as even into a file if you wanted to, because you can see it's a very, very large output. So instead of printing it onto the screen, you can actually just have a very large output sent into a file. So we are going to try to look at a few different options here. So we can do netstat, and then we will do a couple of flags. So we will do TCP, so T stands for TCP connections, U stands for UDP connections, and then we want to do listening, so all of the listening ports, and then we just want to look at the N version, do numeric version. I don't want the symbolic version. Press enter, and then we can see that, I mean, this is the only thing, and it's a UDP protocol. This is the local address, and it's listening. And that's basically it. This is the only one that's actually listening. And then we have the local address, so on and so forth. So because I'm literally one person on this one Linux USB that is running on this network, and I think everybody's asleep and nobody's connected to me, so on and so forth. So this is the output that I get. But if you had a larger network, you would get all of the addresses that are actually in listening mode in TCP ports and UDP ports, and they are in listening mode. And then we can do the netstat and then do AN. So this would be all of the established connections. And of course, we're going to do the numeric version as well. So this is going to be either listening or not listening. And if we just do this by itself, press enter, we can see that there's a bunch of stuff going on. And then you can grep for any of these things. So you can do connected, you can do listening, you can do established connections. So I'm trying to see if I can scroll and find an established, and I can't even scroll to find the established. So what I can do though is I can actually pipe this command. So I can do netstat and then do AN again, but we're going to pipe it into a grep search, and then we're going to search for established, right? Press enter, and these are the only connections that have actually been established in my particular case. They are all coming from my local IP address with the exception of this piece, and then they're going to these various IP addresses, and that's what I got, right? So these are all of my established connections. And these are TCP connections, TCP6 connections, and then these are the UDP connections that are going out from my device, and then they're going into the internet, and they are all established connections, right? So this is a very useful tool to try to see who you're connected to. And then again, you can take this and you can output this particular result. So if I already kind of showed you how to do this when we were in the very, very early of this training series. But if you do something like this and you do that, and then we can do the connections.txt, for example, press enter. And now you can see that the output is no longer on my screen. But if I do an ls command, we can see that there's an actual text file that was just created, and it took the output of this command and it put it inside of this text file for me. So I can now create a script to analyze that text file to see if any of those network connections are malicious. So if I do a cat, or not even a cat, if I do a nano and then go into my connections and then open it up, we can see exactly what we saw on our display earlier. But now we're looking at it in a very neat format inside of a text file that I can manipulate later on and see what else can potentially, for example, if there's any negative IP addresses or any malicious IP addresses that are inside of it. So very, very useful to learn how to just output something. And it's as simple as literally just doing this little beautiful greater than symbol that outputs the result of this whole thing, and it outputs it inside of a given text file. If I ran this again and I had other connections, it would replace the contents of this. So you should already know this from earlier in the training. It'll replace the content. So if I wanted to append it, then I would do double greater than symbols. And then from there, it will actually add it to the end of the file. It won't replace anything that is inside of this file. So if I do this one more time, again, it'll be run, and then we can do nano and then do connections. And now we can see that we have, I mean, it's pretty much the same exact output. It's just duplicated in this instance. Actually, no, look, we have these other addresses that are at the bottom right here as well. So I have now made a little edit, and I don't want to keep that edit, so I'm not going to save this. So I'm going to do Control X, and it's going to say, do you want to save it? I'm going to say no, and I'm going to get out of that. But so now we appended it instead of replacing all of the contents of that file, right? So this is how you take the outputs of these commands and put it inside a file for further processing. We did cover this earlier on. So it's, and I did mention that if you run a scan or if you run any kind of a command, you can output the results of that into a text document. So I was worried that I didn't share that with you earlier, and it's such a basic concept that I was like, oh no, did I not tell them? But I definitely did tell you that. It's under the functional operator section, and I know for a fact that I shared that with you. Okay, so the next tool that we're going to talk about is going to be the SS command, which is the more modern version of the netstat command. So as the name already implies, or the sockets, what's going to happen is that netstat gives us the results. We do SS. It also gives us all of the results here. And so we have established in this case, and these are TCP, and then these are the ICMP6, UDP, so on and so forth. So this is a more modern version of it. And I personally, honestly like the netstat output more than this, but we can actually run the same exact command that we did, which was TCP, UDP, listening, and on the numeric value, and then just give me everything that's available. And now these are the ones that are listening, and it's the same exact output that we had in our other situation, which is the UDP. And then we have the WLAN for our specific interface on our local network. And then this is the IPv6 address of it. And then it's actually connected and it's listening, right? So this is a very useful little trick command. So if I do ss-sys, for example, it'll show me the summary statistics of everything. So it says, there's INET 13 connections, 8 IP addresses that are IPv4, and then 5 IP addresses that are IPv6. And then we have 6 UDP connections, 6 TCP connections, nothing that's been fragmented, and then 1 raw connection. And that's it. These are our total connections, TCP, which are 7, which will be the overall. And then we have the closed that are 1, orphan 0, and 1 that's waiting. And that's basically, 771 potential socket connections. that have been taking place in this particular environment. It doesn't show you which one is unestablished or not listening or is listening. It's just saying this is the total activity that happened within this network. And this computer has not been down for the last 2 days. So it's been up and running for 2 days. So it explains the 771 and it explains why there's such a big difference between the 771 and then what we see over here between these actual connections that are currently running. So that is the statistics, summary statistics of the socket usage. And then we can show the processes that would be using something by doing the -p command or the -p option. And then now it says Firefox is using this and Zoom, and of course, Zoom in a lot of cases, Firefox and Zoom, because I only have Firefox and Zoom that are open. And then there are a few things that are running in the background, like the daemon and the terminal and so on and so forth. So these are all the processes that are actually running and working. And again, this is kind of a very overwhelming output. So you want to learn how to sort through this. So if I did SS and I did -p, for example, and then I grep this with the EST, I think that's what it was. It's not stab. Maybe I think that's what it was. Now we can only see the ones that actually have the stab stat, not stab stat, the stab. My God, I'm status. Yeah, stab status. I just drew a blank. We have the status of established, and these are all the connections that are available to us that have a status of established. Dude, I literally had such a big brain fart in that moment. That was crazy. But yeah, so that is it for our SS command. And of course, you can do man SS, and it will give you all of the various options that are available for your SS command and what you can do with it. For example, show socket memory usage. And so we can go and do this. We can do SS-M, and it will give you the socket memory usage. And then let me see what I can find here. skmem right here. And then this is the output. So we actually should look at the manual because this gives us a sample output and what it would show. So if I do memory, it says this is the output format. So SKEM, so this would be the memory allocation. This is the buffer, the web memory allocation, so on and so forth. There's a lot of acronyms here. Of course, there's a lot of great documentation that's available on the SS command. So if you wanted to learn how to use all these different options and show the threads, for example, that are using the sockets and information about the internal TCPs, so on and so forth, all of these things would be available for you inside of the manual as well as the documentation that's available online. But again, the key point here is to know what if you see netstat, you can rest assured that somebody's trying to find the active network connections on the computer. If you see SS, you can rest assured that somebody's trying to find the network connections on a computer. Netstat and SS both have to do with network connections. So this is one of the things that you need to kind of wrap your head around. When I share these commands with you, and I've mentioned this multiple times already, so I'm just repeating myself. So hopefully if you skipped to this portion of the tutorial, I do get to disclose this to you as well, and you didn't miss it in the earlier portion. So the main point of this is so that you know what tools are available to do certain activities, and then I will give you the most common commands that can be ran. And then from there, you'll go ahead and do your own research with either the AI tools or looking at documentation so you can find what you specifically need for your individual use case. So that's what we had for looking at active network connections, which was netstat and SS. Next in line is our DNS Lookups series of tools, and these are very, very useful as well. So this is for querying DNS to get IP addresses or to try to find DNS information about any given website, like for example, where they're hosted and where they're registered and what their certificate authority is, so on and so forth. This is more for reconnaissance of pen testing and ethical hacking, in my opinion. But it's also very useful to try to just learn more about your network and where you're connected to and what an IP address, who owns an IP address or who owns a website, especially if you've done all of the previous commands to see where your connections are, for example, and you know what path your connection is taking on its way to its destination, that's typically what it does, right? So let's say you ran traceroute, you saw a couple of IP addresses that seem funny, and then you ran netstat, and then you saw those same exact IP addresses, and now you're trying to see, okay, well, who owns this IP address, for example, right? So, or who owns this website, for example. So what we're going to do, the first command is going to be ns lookup, and it's going to look up the DNS records for any given website. The command itself is very simple, so it would be ns lookup, and then we would just give it the domain, for example. So let's say tryhackme.com. That's like a one that I use because I love TryHackMe as a website. They're very, very cool for teaching you about the basics of cybersecurity, and that they take you from the basics and the foundations all the way to more advanced strategies and tactics. And this is just a cool little plug for TryHackMe. There's actually a link to TryHackMe inside of the description below. So let's say we're looking at the TryHackMe website. So this is actually their server address, and then this would be the DNS. So on port 53 is their DNS address. The non-authoritative answer is tryhackme.com at this particular address, and then they have another address, and then they have another address, so on and so forth. So these are all of the information, and so these are the IPv6 addresses, as we can see here, and these are of the IPv4 addresses that they have for their website. So nslookup tryhackme.com, very, very easy command, right? So nslookup google.com, for example, and it's going to give you the server address, and then the google.com IP address, and then the google.com IPv6. And then if I ran this again, I wouldn't be surprised if it changed, and it did change, right? It's because they have a dynamic IP. So the first one was ending in 14, the next one is ending in 46, and then the IPv6 is actually the same though. So the IPv6 address, oh no, the IPv6 address, yeah, this also changed because this is 816 right here, and this is 810. So a company as large as Google, of course, is going to have dynamic IP addresses because they probably get hack attempts all the freaking time. So NS lookup is a very, very useful tool. And then you can change the DNS server to the public DNS, for example, by doing something like NS lookup, I think it's server, and then do 8888, and then it would change the server's IP address like that. So it says it can't find the domain. Actually, so hold on. Let's go do this, and then let's do tryhackme.com, and there we go. So NS lookup interactive mode using the default server. Oh, actually, no, you know what? I probably did run this incorrectly. So let's actually go and look at the manual for NS lookup to see if there is a way that we can figure out how to assign a server. So the host, this command looks up information for the host using the current default server or the user server. Server domain, they'll change. And let me see if I can actually find it, because now I'm a little bit obsessed with learning how to use NS lookup, and I've got to the end of it. So let's do a quick search with our AI utility. Ah, see, I knew that I had something missing. So first, we want to actually turn our resolve configuration file. We want to go into that file, and we want to add our name servers, which are the public name servers for Google, and we want to add those as our name servers. So if I actually go back into the NS lookup here, and if I run one of these commands originally, we can see that our server in this case is the 68105, etc. And if I did ns lookup tryhackme.com, our server is still again 68105, etc. So if we don't want our server to be displayed when we're looking up the various domain names and their ownerships, we can actually change our server's information by going to the resolve configuration file, which is stored inside of our Etsy. And then from there, we would just add the Google DNS servers into the file, like name server, name server, and then save it. And then now you can go and look at the verification of the confirmation by just doing nslookup example.com. So let's actually do that. Let's try this for example. So we're going to do nano Etsy resolve configuration. And then from there, we're going to add these servers. So I'm just going to copy these two. I could just do copy right here. Okay, cool. Let's go and check it out. All right, cool. There we go. And we have these. So at the bottom of this, I'm just going to go ahead and paste my selection. Oh, that's weird. It didn't copy that first N here. So there you go. N, name server. The resolver may not report more than 3 name servers. I see. So generated by the network manager. So let's actually go and delete these options right here and then go up here and we'll change these options. So let's see, generated by network manager. I will go ahead and paste this, and then let's do a write-out, save it, and then close it out. And now we're going to do NS lookup and do tryhackme.com. And look at that, it changed it and assigned our Google DNS servers for publishing so that we don't, for whatever reason, they don't track it back to the fact that we were trying to look them up. Pretty cool, right? So that is the NS lookup tool. The next tool is going to be the dig tool. And the dig tool, as the name implies, will dig up information for you about a given website. So tryhackme.com, for example. And now we're getting a bunch of information about tryhackme.com. So we have the, let's see, the IP addresses that they've been resolved to, the query time, the server that we have used to send it up to them, and the message size that was sent to them. So tryhackme.com is what we queried, and then this is what we got. So this is their header, and so this is actually not their header. I apologize, but it did essentially give us the same exact IP information that we got from NS lookup. What we can do is we can get the short version of this. So if I do same thing, tryhackme.com, and press enter, or I think it's plus short probably. TryHackMe, not short. What am I doing, bro? Dig and then short, TryHackMe. I'm like, what am I writing here? So it is, I think it is plus short then. So let's clear this up and do dig plus short, and then let's try to do tryhackme.com. There you go. Okay, so that's the shortened version that it just gives you the IP addresses. Usually it's like a dash to imply that the option that you want to use, but in this case, it's a plus. So now these are the IP addresses that we got previously when we just did a dig tryhackme.com, and then we got those exact IP addresses over here as well, right? So pretty cool, useful little tool. And this will give you the details of the same output that we got pretty much from NS lookup, but it just gives you a few little options to make it more user friendly, for example. And we can always go into the manual to try to see the variety of different options that we can run with this thing. So we can look for the IPv4, IPv6. We can look for the ports. So the query, the address must be a valid address. The class, so set the query class, sets the batch mode in which dig reads a list of lookup requests to process from a given file. So if you want to actually import data from a file, you can do F, and then check this out. This is actually really cool too. So let's go back here and actually create a quick little file. So we will do a nano of sites.txt. And then I'll do www.google.com, I'll do www.tryhackme.com, and I'll do www.facebook.com. So those will be our sites. Save this thing, and then we can do dig-f sites.txt, run it, and then look at that. Now it'll look up everything that we had in all of the websites that we had for that. So now we can go back into the manual to see what else we can do. So, I mean, this is as simple as when I say that look in the manual so that you can see what you can do with it, that was really a simple explanation of it, because I never have run it from a file before, but I was like, oh, you can actually import from a file. So let me go create a file, put the sites in the file, and then we just do the -f and then give it the file name, and it'll read from the file, right? So it's it's kind of one of those things that as much as I can in real time, I would like to give you examples of how to do these things so that you can kind of get used to doing them, right? To get your brain in this mode of, okay, let me do some real live testing, not necessarily troubleshooting, but kind of experimenting, where you just work with these various options that are available, and then see, okay, all right, this is what we can do. You can load it with a file. You can do the type and see which can be any valid query type. It indicates the resource record type to query. So we can do, let's see, we can do the IXFR, which is required. XFR, no idea what any of these things mean, because this is nitty gritty in the depths of the networking conversation. So I'm not like a networking master. I just know that I can potentially just run these options with any of these commands or the websites, or if I really wanted to learn more about it, I could just say, hey, what does this mean? And I would just take this particular option and I say, hey, GPT, I'm using dig and I want to know what this particular, I want to know what the add flag, AD flag, or no AD flag, what does this mean? Because this description right here kind of doesn't make sense to me. Can you please explain this to me? And it'll go ahead and give you a very nice explanation. So that is the power of combining manuals and documentation with the actual tools like Gemini and GPT and Meta's AI, so on and so forth. X is Grok. That's like one of the new up and coming ones that I think is going to be a really powerful AI. But anyways, I digress. So let us move into configuring of firewalls. This is like a big one. All right, so let's get into our firewall management section of our networking subsection or the networking category. So firewalls are very, very important, as I'm sure you can imagine. And inside of Linux, we have two very useful. One of them is basic, which is the UFW. Another one is a little bit more advanced, which is IP tables. And what we're going to talk about first, obviously, because it's the more basic one, which is UFW. So UFW is the uncomplicated firewall. So if I actually go into there's no manual entry for it. So let's see if we can actually open it up. There is no UFW that is installed. So what we have to do first and foremost, we need to install the uncomplicated firewall. So let's actually do that. All right, so UFW is now installed. So let me go look at the manual. And there we go. So obviously I was running Linux from a USB live boot. If you don't already know, if you just skip to this section, I've said it in every section. So if you watch this all the way from beginning to end, I apologize for constantly repeating myself, but I kind of have to do that because some people just skip from section to section. So we have the UFW, which is managing a net filter firewall. It stands for the uncomplicated firewall. And there's a lot of different rules that you can do. So you can deny, allow, etc., 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 disable, enable, so on and so forth. So one of the big things that you want to do is go through the manual for this and look at any documentation and see what specific rules are most important to you. So if you don't know what port 53 represents, or what port 80 represents, or port 22, or any of these things. If you don't know what those things represent, then I wouldn't set rules to deny traffic from there or allow traffic from there. So the big thing is that you should understand what that means. And this is not a networking tutorial, so I'm not going to break that down for you. But for the most part, hopefully you do understand that you can block access from an IP address, you can block access to an IP address, and then back and forth, there's the ingress and outgress. So the type of traffic that's incoming basically and type of traffic that's outgoing. And then you can even block traffic on individual ports, whether they're incoming or outgoing. So that's the overall concept of firewalls. But then there are a lot of different rules that can be placed to make your filtering, your firewall filtering, even more complicated and advanced and just sophisticated and useful, I should say. So for the most part, I'm going to go over how to enable the firewall, how to allow or block certain traffic, and the configurations that are important for UFW. And then we're going to do the same thing for IP tables. But firewalls are complex softwares and you can do a lot with them. So I would encourage that you get a good fundamentals understanding, foundational understanding of networking protocols so that you know what you're doing when you deny or allow traffic in any type of an environment. And then once you have the importance of that and you understand that, then you can start creating some firewall rules to either block or allow traffic and activity to take place on your network. So that being said, let's now talk about the UFW, which is the uncomplicated firewall. So everything that you do with UFW requires a sudo command because obviously it is a very powerful tool. So the first one that you want to do is just enable it. So if you do UFW enable, and I don't want to enable it yet, mainly because the fact that I haven't set any of my rules in place. But once you have all of your rules, all of the firewall rules that you set in place, you would enable the firewall. And then the other thing that you can do is, of course, you can disable the firewall. So this is the first command that you need to know, right? So we can do all the configurations that we do, But if we don't enable it, then none of those configurations mean anything, and they're actually not going to do anything for you. So that's the first part, is that you need to either enable it or disable it, okay? The next thing is what you have to understand between the allow and deny rules. So you can technically do allow all or deny all without creating any rules. If you don't create any rules, it basically just allows everything to take place, and it'll just go back and forth. If you don't deny, or if you create a deny rule and you don't specify the port, for example, then, or if you don't specify that you want outgoing or incoming traffic to be denied on any given port or from any given IP address, these things are very important. So it's very important to be specific with your rules that you're creating for the firewall. So there are allow rules and there are deny rules, and you can do allow all or you could do deny all. And then you can allow IP addresses to do something. You can deny IP addresses from doing something. You can allow outgoing or incoming. You can deny outgoing and incoming. So these are they're very comprehensive. They cover a lot of different fields or categories of traffic. And then we can do things like, for example, just checking the status of it. So that would be probably the best thing that we can start with. So we do sudo UFW status, and it says it's inactive because I haven't activated it yet. So if I do an enabled, right? So, and this will be any rules that would be available as well. It would also show those rules here. So let's say I want to block all traffic, for example, that's coming on the SSH port, for example. So if I want to block the traffic that's coming on SSH, I can just do sudo UFW and then do deny SSH, right? Boom, press enter. Rule has been updated. Now you do sudo UFW status and it still isn't active. So I guess it's not going to show me my rules until I activate it. So we can do a UFW enable then to actually turn it on, and firewall is active and available on the system startup. So now if we do sudo UFW status, hopefully it'll say it's active, and there we go. So now we have the deny action that we've taken from TCP. So it's going to be to the TCP port, meaning if I do deny SSH, I'm denying incoming traffic for SSH. If I wanted to deny outgoing traffic on SSH, I would actually have to do sudo UFW deny out SSH, and then you have that, and then clear this up, and then let's do sudo UFW status, and now we can see, sudo UFW status. There you go, my bad. So there you go. Now I have two different rules, two different rule sets. So these are the IPv4 and IPv6, and it's saying deny incoming, and then this is IPv4, IPv6, deny outgoing. So there is no possible SSH connections that can be made on my system right now. And for me, it's a very, very important rule because, I don't want people to remote connect to my computer without me having any kind of a rule in place, right? I don't want anybody other than me to be able to remote control or remote connect to my computer, which will actually take us into the next set of rules, which would essentially be allowing a specific IP address to do something, right? So if I do sudo UFW allow, and unfortunately I don't know the IP address of my home computer right now, but I could technically do allow from and then do 10, 10, 10, 10, for example. That would be the IP address. And then to any port 22, for example. So now I'm saying that I can allow that traffic to come from that IP address to any IP address on port 22 in my system. And if I press enter, rule has been added. And again, we can go and look at the status to see what's going on. And then now we have one allow rule that is inside of our incoming connections here that is from this IP address specifically, but everybody else will be denied, right? So this is a very simple way to understand how these rules actually work. So for the most part, if you want to be like really, really secure, you would say, okay, I'm going to deny all traffic on my remote connection port, which is 22, or FTP, which would be port 21, for example. I don't want anybody to have FTP connection to anybody on my system or on my network. So then what you can do is you can just say sudo UFW deny and then we can do FTP, right? Rule has been added, sudo UFW deny out FTP. And now we have that rule added. And now we can go to sudo UFW status. And now we have another set of rules here that it says port 21, which is the FTP port, now has been denied. There is nothing that is allowed to incoming here, and then there's nothing that's going to be outgoing on port 21 for us either. Okay. So this is the basic gist of it. Now, if I wanted, again, so if I wanted to allow one specific person or one specific IP address to be able to do something, we would be sudo UFW allow from 10, 10, 10, whoops, 10, 10 to any port 21, which is the FTP port. And then I keep saying UFE. I don't know why my finger is just going to the E. There you go, UFW. There we go. Now the rule has been added. And then again, sudo UFW status. And then we look at that. And then now we have one specific person, 10, 10, 10 on port 21, that is allowed to do any activity that they want to on port 21, which is our file transfer protocol port, right? So you kind of get the gist of it, right? So you can do allow rules, you can do deny rules, you can create some more complex rules going back and forth between interactions of any IP addresses, for example, and so on and so forth. So I'm going to give you a few more examples here, and then we'll go into the IP tables firewall. So let's say you want to now delete some of these rules. So let's say something happened and now you no longer want to deny traffic on port 22, for example. So how do you do that? So we can go ahead and do, let's get to the top of the screens here. So we can do sudo UFW, and then we would do delete, deny, and then SSH, for example. And then rule has been deleted. And now I can go sudo UFW status, and then we can see that the two rules that we had to deny traffic on SSH has now been deleted. So you can essentially just do the delete command, and then very simply you can delete that specific rule. So I can do this now. So I can do sudo, let's go back to the top again, and let me see if I can do this right. So sudo UFW delete allow, and then we can do 10, 10, 10, 10, and then do SSH. Oh, I see. So I need to do the full command of this. So it would be something like, all right. So actually, instead of needing to do a full command like this to make your life a little bit easier, I just looked through the documentation, because we can always look through the manual to help us make our lives a little bit easier, right? So what you can do in this case is when you do a status, so we can do sudo UFW status and then do a numbered status. So now we can look at all of the rules associated with their individual number that's been assigned here. So now I know that this one specifically is rule number 2. So I want to do sudo UFW delete 2. Press enter, and now it's being deleted. Proceed with the operation. Yes, definitely go ahead and do that. And the rule has been deleted. So now sudo UFW status numbered again. And then we can see that that one that was previously there on the SSH is no longer there. And now we can move forward with deleting the rest of these, for example, if I wanted to do it, right? So I can literally one by one, I guess I could just go ahead and deny these. So, or I can delete these. So let's say delete, let's say 1, 2, 3. Let's see if it'll actually do that combined. And so the application profile command, da 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 da, all of these things are actually not available. So I can't do 1, 2, 3 like that. So let me see if maybe we can separate it by space or something. So let's try to see what ways we can delete multiple rules. All right, so unfortunately, we actually have to do this multiple times. So I can't actually even do the separation by commas or spaces. So we literally have to do this every single time like this. So boom, yes, and then it's been deleted, run it again, boom, and then yes, and then now the next one has been deleted because they just keep moving up to the top, right? So we can just do it like this. And then so let's clear it and then get a UFW status numbered one more time. And then we can see that there are 4 more rules left. So we can do UFW delete 1 again, and then boom. And now there should be no more rules. So we don't have any more rules. We're just at a status of active. So that is the overall interaction that you can have with UFW. Now, one of my favorite things to do is that if I don't know how to write a specific rule, I will go ahead and ask one of these AIs to actually help me write the rule. And that's kind of the purpose of these AI assistants, to make our lives a little bit easier. So if we wanted to go ahead and interact with any of these AIs, and get any of these rules for ourselves, as long as we know what we're trying to accomplish, we can definitely go ahead and make it happen. So if I know that I want to, let's say, deny traffic coming in from one specific IP address, I would say, all right, how do you write that rule? Or if I want to allow traffic, for example, if I want to allow traffic that is for any specific IP address, how can I do that? And that's a very important rule to understand as well. So this is a very important overall strategies to just be able to make the most of these freaking tools that are available to us, which are these AIs that are supposed to be making, taking over the world, so to speak. But at the very least, we can try to help them to make our lives easier. So there are things that if you know how to write it, so deny from any specific rule, for example, you can technically try to do that, or you can craft these like very magnificent sentences that we previously had. So, for example, deny from 10, 10, 10, 10 to any port 22, right? So deny from this to any IP address on port 22, or delete deny from da 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 da. So let's just do that. It's been added now. So now I can do sudo UFW delete deny from 10, 10, 10, 10 to any port 22. Let's see if, oh, whoops, boom, rule deleted, right? So that's the piece of it that if you kind of know what to do. So you're doing, actually, let's go to the one where we created. So we are going to delete from first to whatever, and then, or we're going to deny, sorry, we're going to deny traffic from this IP address to any IP address on port 22. I want you to deny all of that traffic. Now, if I wanted to change this again and say, I want you to sudo UFW allow from 10, 10, 10, 10 to any IP address. So this any represents IP address. So this would be the destination, or excuse me, the source, and then this would be the destination. And then you would say on port, yada, yada, yada. So we can also do this, right? So we can say deny. So we can create the reverse of it. So we can say deny from any to 10, 10, 10, 10. Okay. And then we can say port 22, enter, and the rule has been added. So now it's taking from any source address to this destination address on port 22. It is now denying that traffic. So if I actually go and check now the status of my firewall, we can see that we actually have denying anything from anywhere, and it's been denied completely. And that is pretty much it, right? I deleted the very first one, but I could technically recreate it. So UFW deny from this one, whoops, to any port 22. And now we've done that deny rule as well. So if we go to UFW status numbered, we should have two rules, and we do. So this one is to this location on port 22, and then this is to our port 22 from this person, and we want to deny both of those traffics, right, that are taking place. So this is a very, it's not complicated to be able to write these rules here. And let's just do a few more examples just to kind of give you the hang of it. So we do sudo UFW allow from 8888 to any port, let's say 25, which is for SMTP traffic, for simple mail transfer, okay? And then we'll do sudo UFW allow from any to 8888 port 25. There you go. Rule's been added. So now sudo UFW status numbered, and it will give us the rules that we have. So not complicated, right? Uncomplicated firewall. That's the whole thing. You can do deny all in general and just say deny everything on a port and then only allow this IP address. and then you can allow everything on a port and only deny a certain IP address. These things are fairly simple to do, right? So as long as you know what it is that you're trying to accomplish, you can either find the instructions on the documentation, or you can just go to Grok AI, or Gemini AI, or Copilot from Microsoft, or GPT, any of these powerful AIs, Claude AI. There's so many really good ones out there. So you can go to any of them and say, hey, listen, I'm trying to create this rule that I wanted to allow traffic to happen on uncomplicated firewall on this port for this IP address, but I want to deny everybody else. What are the rules that I need to create? Or the vice versa of that. So as long as you know what you're trying to accomplish, you can at least find that specific rule and have the AIs created for you. And then you just come in here and you type it up the way that I did. Or you will go and read through the documentation. And I'm pretty sure for the most part, everybody's going to go to the AI tools, because it's so much easier to have a conversation with these guys instead of having to sift and sort through documentation to try to find the answers that you're looking for. So that's literally the purpose of these AIs, is to make your life easier so you don't have to go and spend a lot of man hours to try to find the answers that you're looking for, and then all the hours to do trial and error to try to find all the answers that you're looking for. So, that being said, let us delete these rules now. So here we go. Delete one, enter yes. And now should be nothing. So now that I'm done playing around with UFW, what I'm going to do is I'm going to disable UFW. And I keep saying UFE. So UFW disable. There we go. And now the firewall has been disabled. So we do UFW status and it's inactive. So there it is. That was our interaction with the uncomplicated firewall. All right, the next firewall that we're going to work with is the IP tables firewall. And this actually, thankfully, is already installed on my machine. So what I'm going to do is I'm just going to first walk you through the IP tables manual, as we normally do. And you can see that there's a lot of stuff that's going on over here. The way that IP tables works is that it actually works with getting network traffic controlled in either direction by creating packet filtering rules, otherwise also known as, I forget, they're called chains, I believe. So you would create chains, which would be for input chains or output chains, and then you can filter, allow, block various types of traffic, pretty much in the same way that we did. The syntax is a little bit different, but what you're doing is you're creating chains, okay? And then the chains can have various rules that are attached to them. So you have tables, you have chains, and then the specificity, the specification of these rules. So sorry if that didn't actually make sense, but I'm going to kind of explain some of these things for you by showing you what they mean. In the lecture portion, we actually went through the variety of functionalities that IP tables can do. So for example, the default table for filtering, meaning the filtering of the traffic, this is the filter table. You have the network address translation filtering, which basically, it's not actually really I guess it is a filtering. So network address translation is when you want to interact with the outside world, when you want to interact with the internet, but you don't want them to see your actual IP address. So it will go ahead and kind of disguise your IP address as it goes out to the world. And you can kind of display yourself as an IP address that you're not, so that when people are capturing that traffic, if people are capturing that traffic, they won't know who was interacting with them. Or if somebody is running a intrusion detection system or some kind of a security appliance, and you're interacting with their website or their IP address, it shows a different IP address than who you are. So if they block that IP address, they're not going to block your actual IP address. So it's a very, very important little feature that's available over here. And it works with 4 built-ins here. So you have the pre-routing built-in for altering packets as soon as they come in, the input for altering packets destined for your local socket, the output for altering packets that are locally generated before going to the world, routing to the world, and then post routing, meaning packets as they are actually about to go out, you alter them. So this is what network address translation does. So NAT. And then mangle is used to for specialized packet alteration. So until the 2.417 kernel, it had two built-in, which was pre-routing for altering packets before routing and output for altering locally target packets before routing. Since this updated version, there's now the input, the forward, and the post routing that basically mangles your IP address, which is, I guess, another way of saying that it is disguising it. But I think this is a rule that is specific to IP tables. And then you have the raw table, which is mainly for configuring exemptions from connection tracking. And then you have the security table, which is for mandatory access control, meaning things for the sec mark or the consec mark targets. Mandatory access control is implemented by Linux security modules like Selinux. So this can work very similar to Selinux or in tandem with Selinux. It's very, very useful. IP tables is like it's an important firewall, and a lot of companies require that you know at the very least how to interact with it and what chains are and what tables are and how to configure these chains and tables. So there's a lot of stuff that is available for IP tables, and I'm going to give you some of the ways that we can create these commands. But if I were to kind of give any piece of advice, it would be to learn IP tables. So compared to, a lot of the other tools that you would be exposed to inside of this Linux tutorial, when you're dealing with security and system administration, UFW is important. So uncomplicated firewall, as you saw, it's fairly easy to use. But IP tables is a little bit more complex and sophisticated of a tool, as you just saw, just based on the tables and the options that are available over there. And if you're going to make yourself valuable to any kind of a company, this would be the tool, in my opinion, that would really make you stand out compared to everything else. So obviously, you do need to get good at Linux, and you do need to know how to do all the things that we were doing. But if you get really good at IP tables on top of everything else that we're talking about, I think you would definitely stand out when it comes down to everybody else that's competing for the same job that you're trying to compete for. So that being said, let's now go into running some commands with IP tables, which is a very, very, very powerful tool. So the very, very first one would be to just kind of understand what it is that you can look at for just the rules that may be in place currently. So obviously there wouldn't be any rules that are available for us right now, but it would be with the dash capital L. So you do sudo iptables dash capital L, and it will list the rules. Actually, no, there we go. Look, we have these chains. So reject forwarding, and reject output, reject input. These are all of the rules that are currently in place. So I stand corrected. Look at that. So policy accept of these target protocols. It's going UFW before logging output, all anywhere UFW. So it has the UFW rules that may be available as well. This is very, very cool. I had no idea. I thought this was going to be an empty output. So very, very cool that we actually kind of have the input chain here, the forward chain here. We have the output chain here, and the UFW after forward chains and after logging, so on and so forth. So just to kind of give you a quick, because I did go through this inside of the lecture, but just to give you an understanding of what the chains are. So the input chain handles the incoming traffic. The forwarding chains handles packets that are supposed to go out through your device. And then the output chain handles outgoing packets. So the forwarding chain is when your computer ends up being the kind of like the filter, so to speak, between traffic that's coming from a different computer and is supposed to go out into the world and interact with the internet. The forwarding chain would be when you act as the filter. The input would be anything that comes in, and then the output would be anything that's going out from your computer. So these are the three chains that we have, and then we already saw what the various tables are. So these three chains are inside of the filter table, which is the default table, and then the NAT, which was the network address translator. Those chains would be the pre-routing, post-routing, and output, which you already saw in the manual as we went through. Mangle, same thing, pre-routing, output, forward, input, etc. All of those. And then we have just looking at the rules themselves, which is what we're looking at over here. So I'm actually just reviewing my notes just to make sure I don't leave anything out for you. And I think so far we are good. So what we're going to do now is we're going to create a couple of rules here just to show you what the interaction is like with IP tables. So the first command would be, of course, sudo, then you're going to do IP tables, and then A would be adding the rule, and we're going to add it to the input chain, and it's going to be on the protocol of TCP, and then the destination port is going to be 22, which is our SSH port, and then J is essentially the command or the option that would say, are we going to accept this or are we going to delete it? Or we're going to deny it, excuse me, drop it, excuse me. So it's either accept or drop the traffic. So in this case, I have sudo IP tables adding into the input chain for my default filters table. And on the P port of TCP, the destination port is going to be 22. So we're going to do the TCP port 22. And then we want that traffic to be accepted. We want to allow that traffic to take place. You press enter, and now it's done. You actually have it. So again, if I went sudo, let's go lowercase here, sudo IP tables, and then -L, we should hopefully see that freaking rule at some point that I created. So input policy accept, and then right here we have TCP destination accept this particular rule. So that was the one that we just added to our input chain. And there it is. It actually is available. So we know that our command worked. So next one that we can do here is it's going to be the drop rule. So let's say that we want to do a drop. And actually, I think for the most part, I don't want to mess with port 80 because I'm connected to the internet and I don't want to mess with it. So I'll drop the packets from a different port. How about that? So we will go and do sudo IP tables, because in my sample command that I have on my notes, I was going to drop the traffic from port 80, but I'm connected to the internet and I'm like, I don't know if I want to drop HTTP traffic here. So, okay, sudo IP tables A, and it's going to be input, and the port is still going to be a TCP port. The destination port is going to be port 25, which is for my SNMP, or not SNMP, SMTP, excuse me, the simple mail transfer. So this is for essentially for email. And then we're going to say J and then drop. Press enter. We have the rule added, sudo IP tables L, show me my list of rules here, and then we go all the way to the top to our input chain, and now we have a new rule that's been added here, which is on the SMTP port. So it's dropping anything from that specific port. So you can hopefully you can actually see the pattern that we're using here. So you can hopefully try to experiment with this a little bit on your own computer. If you're not connected to the internet, you can drop traffic that's port 80, which is the HTTP traffic. You can drop traffic for really any of the other ports as well. 3389, which is for the remote desktop for Microsoft, so on and so forth. So you can drop traffic on any port essentially if you wanted to. So just to kind of show you how to design the rules is the purpose of what we're going through right now. So we did the inputs, we did the accept as well as the drop. And then what we're going to do is show you how to delete a rule. So unfortunately, unlike what we did with UFW, where we could just delete it by its number, we actually have to write out the rule itself that we're deleting, except now instead of doing the add piece right here that you see, instead of doing that, we just have to do the D. So D for delete. So instead of doing add, we're going to do D, and then it's going to delete the whole rule that we just created. So boom, you do that, and we got that. And then the next one was the, let me see. So actually I can even do this and then just delete port 22's rule that we had over here. And I think it was an allow rule actually that we created. So we need to delete the port 22's allow rule and press enter, and it says help for it. So allow does not exist for port 22. So let me see. Let me actually go look at the not UFW IP tables list of rules that we have over here. I thought it was port 22. It is port 22, destination TCP accept. I definitely thought that that was the rule that we had created. I'm like, I'm losing my stuff. I thought that was, honestly. So let's see if maybe it was a different command that I had entered, and now I need to just verify so I don't mess up. It's literally right here, a input J accept. I literally thought that was it. So press, and so there you go. Okay. Huh. That's weird that it didn't work this time, or it worked this time around, but it didn't work the first time around. So I wonder, maybe I probably misspelled something. So let's go look at the rule again, and then we can see that the rule has been deleted. So the adding and the deleting of the rules with IP tables actually has to do with this portion right here, this very first option that you give it. So D would be deleting the rule, A would be adding the rule, and then you're adding it to the input chain, and then it would be TCP port, and then it would be port 22. And then the final piece is, do you want to accept or do you want to deny? And that is how you create the rules for IP tables. And then we also covered how to delete the rule for IP tables. If you wanted to save a rule, right? So let's say that we have any given rule that we want to save. So how do we do that, right? How do we save a rule to the IP tables configuration file, which is the rules.v4 configuration file? All right, to be able to save it, actually, it is not that complicated, honestly. So we're going to do IP tables save. I just had to refer to my notes just to make sure I do everything correctly. Because again, once I teach you this, I'm going to hope that you're going to study it and remember it, so on and so forth. And I don't want to give you wrong instructions for you to remember, and then you come back and curse me out. So we're going to do sudo IP tables save, and then we're going to do our helpful greater than symbol, and then we're going to save into the etc IP tables rules.v4 file. Now, what this command is going to do is I can just press it, and oh, there is no actual IP tables rules v4. So now what we need to do is we need to go ahead and find that. So let's see if I can find the rules.v4 file. All right, so here is what I got. So I'm looking at my etc folder list, and there is actually no IP tables that is included in my list of configuration folders, which means I actually have to create one. So I know that the location for it is going to be so based on, let's go back to our location that we were at originally when we were messing around with these things. So if we go to the man of the IP tables, and if we look at, let's see if we can find the configuration file that they're talking about. Because I know based on documentation and based on my little research that I just did right now, that there is actually a rules v6 for IP table for, IPv6 rules, as well as rules v4 for IPv4 rules. I know that for a fact we can actually do that, but what I want to do is I just want to make sure inside of the documentation it actually even gives us those instructions, so I can show you that we can find it, because I Googled it, but I want to see if it actually exists inside of this manual. If it doesn't, then I'll just show you what I found from the Google search that we did, the internet search that we did. Okay, so I can't find it here, and I literally just skimmed this, so I apologize if it does exist in here, and if you found it inside of the manual, then just drop a comment and let me know which section you found it in. But I'm just going to show you the research that I just basically pulled it off of Google to show you where it is that we found it, and then from there we're just going to create our rules file and then save the rules that we have inside of this list. Basically what you're doing is you're looking at this list of rules, you're taking all of these rules that are existing here, and then you're just saving them inside of the rules file. That's all we're doing. It's just that you need to make sure that you have the rules file to save those rules into. So let me show you the notes that I got. All right, so here's what we got. We can create a directory and files, for example. So we would do a sudo making of the directory, and it would be -p to be able to actually make this etc IP tables directory in this case, if it doesn't already exist. Then once we have it, we can save the rules to the file inside of that directory. So iptables save is the command, and then we're just going to refer to this thing, and then save it to rules v4 or rules v6. So IPv6 rules would be v6, IPv4 rules would be v4. And that's basically it. If you wanted to make sure that it's persistent across all of your reboots, then you would need to go to the etc rc local. If it does not exist, then you can go ahead and create it. So etc rc local. And so let's go see if it actually does exist in our cd. Let me just, not cd, let me list the stuff that's inside of the etc file. So we're looking for the rc.local. And in this particular case, I don't see rc local. So there is no rc local inside of my etc folder, which means that I would need to create it. So if you do that, then what's going to do is it's going to create that exact location here for the persistence of the rules. So we'll do the adding of these particular lines. So it has to be a it has to be a bash shell. And then from there, this is a shebang. We're going to talk about this when we get into scripting. This implies that we're creating a bash shell. And before the exit 0 line, which is right here, the very end of the shell, we're going to add these rules inside of it for persistence, right? So every time that you restore it, you actually essentially your system loads all of those rules every time that you reboot your computer. Every time that you restore or restart your computer, the rules would be loaded from these specific locations that you had. And then once you've created that file, you would make it executable by doing a +x command to it so that it actually can be executed. And then from there, it essentially runs it. So just again, to reiterate, we're going to make the directory for etc IP tables. In this particular case, we're going to save the IP tables v4 into this, IP6 tables into the v6. And then from there, if we wanted to make it persistent, which for my case, it doesn't apply because I'm doing a live boot from a USB file or a USB drive. And that live boot, every time that I reset this or every time I reboot this, it's going to wipe everything that I've done because I don't have USB persistence. And you can technically reboot and still maintain all the previous settings by enabling USB persistence. I just haven't done it in my current instance. And I'm so far along inside of this tutorial series that I don't want to reboot and redo this whole thing and reconfigure everything that I've done for this, for my file systems and my partitions, and to make Zoom downloaded. And because I literally would have to download Zoom again, and I would have to create all of the configurations that I've created to be able to record these tutorials for you. And to be very honest with you, I have like zero patience right now because there's just so much stuff that is going. I'm not going to give you my personal life. What am I doing? That's so funny. I'm not going to cut this out because it's impossible for me to locate this in the hours of recordings that I've done. But just bear with me, okay? I am human on the end of this thing. And I'm going through some stuff, but I still want to deliver this tutorial to you. So hopefully you can respect that. But okay, so the first thing that we're going to do to be able to save our IP tables rules that we have over here is we're going to create an etc IP tables folder. So let's go over here. We're inside of the etc folder, and we're going to just clear our screen here, and we're going to do make dir etc and then IP tables, and that's going to be our directory. Whoops. So make dir needs to be with a sudo because it is a very important folder, the etc folder. So now we're going to create the IP tables. And there we go. Now we have it. So now what I'm going to do is I'm going to save my IP tables rules by doing IP tables save. And then I'm going to do the etc IP tables rules.v4, press enter, permission denied. I wonder why. So let's see. Maybe we need to change the permissions of that specific directory, right? So we're going to go to our sudo chmod command, and we're going to give so actually let's not even do that. Let's first see what the permissions of that specific location are. So we're going to do list of all of the etc folders, and we want to look at the IP tables directory to see what the permissions are. I have a feeling it has to do with permissions. So we're going to look at, there it is. So IP tables. And we have rewrite execute for our user. We don't have read write execute for the group, and we don't have read write execute for everybody else. Well, we do have read write execute for our user, which is very interesting because I would think that it should, if my root user can do it, I don't know why I wouldn't be able to save that file. So let's see, IP tables one more time, save, and then we're going to do inside of the etc IP tables and then rules.v4. Permission denied for my shell. Fascinating. Okay, now I got to try to figure out exactly what's going on here. Okay, so I literally just learned something new today. So permission denied occurs because the redirection with that greater than symbol does not inherit pseudo privileges. So to resolve this, we can use the sudo t, which properly handles the redirection of those elevated privileges. I didn't know that that's what we needed to do. So now we can actually rerun this one more time. And let's make sure that it actually works. We're going to do this first, and then we're going to pipe it into the sudo t. And then from there, we're going to do etc IP tables, and then rules.v4, enter, and completed. Look at that. It actually saved it into the file. I love it when things that I try for the first time actually work on these command lines. It's one of the most greatest experiences that is literally, it's like, it's such a high, dude. It's such a great feeling. So, okay, cool. Now then we can do that. We can do sudo IP6 tables, right? Because we have IPv6 as well. And we're going to do save, and then we're going to do sudo t, and then etc IP tables rules.v6, and then press enter. And look at that. Those have also been completed. I am so freaking excited that this actually worked. And we both just learned something brand new today together, live in real time at the same time. So very cool. We were able to go ahead and restore and save those things. Excuse me. So the next command would be to restore rules, for example. So if we wanted to restore the rules, it would be IP tables restore. And then instead of doing this greater than symbol, we're going to do the reverse version, where we are going to take it from the etc IP tables rules.v4 file, and then we're going to bring it back into our location. So we're going to restore our rules essentially. So if you have a rules.v4 file, for example, that you created on a separate computer, and you want to import all of those rules into this one particular computer that you're on, you would just do the IP tables restore. And then you just need to make sure that you are using this specific sign, the symbol which is less than instead of the greater than symbol. And then when you run that, then you can restore the rules from this particular file into your current instance of IP tables, which is, again, very freaking useful that you can do. So let's now go into our next gear here, which is looking at the specific table contents or the rules that are associated with the table. So if I do IP tables T, that will be the symbol for, or the option for referring to a table. And then I want to list the rules. So you already know what the dash L does. The dash capital L will list it. So I want to now view the command tables and the contents of everything that is inside of our network address translation table. So we do that, and these are what is available for network address translation. These are the specific rules that are inside of it. So we have chain input, chain pre-routing, chain output, and post-routing. And this is how you can look at any given table's contents or any given table's rules, right? So we can do this one more time for the next one. So we can do sudo IP tables and then do dash T and then do mangle and then do L, and now we'll get everything that's for the mangle table, right? So if you wanted to look at the contents of a specific table, instead of just doing sudo IP tables dash L and then getting this whole freaking thing right here, instead of looking at this massive output, you can just specify which table you actually want to look at by doing the sudo IP tables dash T, lowercase t, and then providing the name of the the table. So let's say filter, and then we're going to do L, and then it's going to give us all of the rules that are assigned to our filter, which is the default. So this is actually what we originally saw, but we weren't able to see anything specifically for the Mangle table or for the NAT, the network address translator table, so on and so forth. So that is it. That's all we got. That's all she wrote for the IP tables as well as the UFW firewalls that we have over here. And again, UFW was much more straightforward and a little bit easier to understand. I will say that IP tables is not that easy to understand. So you do need to know that it deals in tables, as the name implies, and then each table has its various chains. And all of this is covered inside of the lecture. So I do recommend you go to the lecture video and at the very least, skip to the portion on IP tables if you're not going to watch the whole video, which you don't have to. Just skip to the portion on IP tables and then listen to the instructions over there so you have a better understanding of what IP tables is, what it does, how it works, what tables are, and the chains that would be within those tables. So that's all I got for you in this particular context. And now we can move on to our next section, and let me refer to my notes here. What is our next section? We're making some pretty good progress here. So we are on the networking, and we just finished configuring the firewalls. So the next section is going to be process and job management, which should be an easy one. I think it's going to be a quick one.
This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.